Hi everyone and welcome back to PrepFusion. So in this video we will discuss all the solutions of the examination that was conducted today, ReplicaX. It is a all India mock test and it is still available for you guys to attempt. So if you have not already, make sure you go and attempt the test, then you watch the video solutions. You will learn a lot from it and all the tests, right? The Killer X, Booster X, and obviously ReplicaX and the test concept X, all of them are open for you guys to attempt. So make sure you attempt them before the next week, because next week all of them will be closed. So make sure you attempt them, and yeah, after that we will start with the solutions. And I just want to discuss a bit about the level of the paper. So the time when I'm recording this, of course students have not attempted the paper, but my hunch is basically the paper is from moderate to the tougher side. It is moderate to tough. It is not easy. It is going towards moderate to tough. Okay, that is the level of the paper. So let's see. Of course, we'll come live Sunday. We'll come live Sunday at either at 6 p.m. or 6:30 p.m. Just be notified on our channel. You will be notified. Make sure you be press the bell icon and you will be notified, and you can join the live session for the complete analysis of the ReplicaX examination. So let's begin with the questions. Yeah, let's solve this question. All the workers are hereby instructed to reach the factory by 8:30 am. So this is a statement. Now the statement above assumes which of the following? 1. Some of the workers do not arrive at the factory in time. Is this a correct assumption? And second point is, workers will follow the strict warning given in the notice. So the first point tells me that we are assuming that workers do not arrive in time. This is not a valid assumption, right? So we are giving a notice that all the workers are hereby instructed to reach the factory by 8:30 am. So we are giving you a notice, right? How do I know whether workers come in time or not? This is just a notice to let the workers know they should arrive by 8:30 am, right? It may happen that they already arrive in time, right? So this first assumption is incorrect, right? According to the given statement. Second assumption is correct. Workers will follow the strict warning given in the notice. That is the reason why I am giving the notice, right? This is the reason that my assumption would be that after giving this notice, workers will follow the strict warning. This is a warning. So in this case, option 2 is correct. That is my assumption. That is the reason why I am giving a warning, right? So that they can follow the given notice. So option 2 is correct in this case, that this is a correct assumption. Option 1 is not correct. I don't know whether workers arrive in time or not, right? So option 2 would be the correct answer for this question. Below are two analogous groups, group 1 and group 2, each having listing words in decreasing order of intensity. So intensity is getting reduced. Identify the missing word in group 2. So here we see ecstatic, then happy, then content, right? So ecstatic is like very high intense, right? You are very happy, like you are jumping in joy and stuff. Happy, you have a smile. Content is just you, like it's normal, right? It's not even happy or something. It's just normal. Your face is normal. So obviously intensity is decreasing. Here we see loud and audible. So audible is you're able to hear the person. Loud means like I'm shouting, right? That is louder, like more noisier. Here something must be there that is very high intensity. One is noisy, and like what? Let's see the options. Deafening means like whatever audio is coming, right, that can make your ears deaf. Noisy, very like high noise, that's why noisy. Silent and whispering are basically they are lower intensity, right? But I need a word that is higher intensity. So either it can be deafening or noisy. That is a doubt, right? So here something must be there that is of very high intensity. We see ecstatic is like very happy, jumping in joy. So which has more intensity? Deafening has more intensity. Why? Because it can make your ears deaf. If I say the neighbors are noisy, is there a possibility that ears can go deaf? No, right? They are noisy, they are very loud, that is there. But the more intense word here is deafening, right? So deafening would be your correct answer for this question. A trader buys potatoes of two different varieties P and Q. So there are two different varieties P and Q. Let's assume he is mixing it, so they are in the ratio of P is to Q, and mixes them with a certain ratio, that is, let's assume P by Q, right, and sells them. So the selling price is 192 per kg. Now the cost is this for P. So what is the cost per kg of P? It will be 160. And what is the cost of Q per kg? It will be 200, right? Simply divide by 5 and divide by 4, dividing them by their weights. If the trader makes an overall profit of 8%, what is the ratio of the mixture P and Q? So the trader makes an overall profit of 8%, right? So if he makes an overall profit of 8%, we know how do I calculate profit? It is percentage 1.08, because it is 8% profit into the cost price will be equals to my selling price, right? Basically your selling price minus cost price will be the profit percentage, that is nothing but the profit on the cost price, right? 8% of CP, right? That is how we compute the profit. So it's very simple. So yeah, now how to compute that, right? How to compute that? Yeah, we got this. So what is my cost? Because I have to compute my cost price, right? Because they have given me the selling price and this ratio. So what is the cost price that I am currently incurring if, let's say, P is getting utilized by P ratio? The ratio is, so P by Q, right? That is the ratio. P by Q is the ratio. So what will be the cost per kg? What will be the cost per kg? It will be 160 into P plus 200 into Q. If I assume P plus Q equals to 1, right? It's very simple, right? If, let's say, I am taking P amount of P only and I am taking Q amount of Q, and both of them are adding up to 1 kg. So what is the cost per kg there? It is 192, right? Very simple arithmetic I'm doing. That's all, right? So cost of P per kg is 160, and then I'm multiplying by the amount of P getting used, that is P only, and cost of Q per kg is 200, and amount of Q getting used, that is Q only, right? I could have changed this to X and Y. Things would have been same only. Now this will be equal to my cost price, right? So what is my cost price? Let me compute the cost price here. So cost price here would be selling price divided by 1.08. So 192 divided by 1.08. Let me compute that. 192 divided by 1.08, that is 177.78, right? That is my that is my cost price, right? Yes. Now so this value will be equals to 177.78, and P plus Q is also equals to 1. So let me divide this whole equation by 40, right? If I divide this whole equation by 40, this will be 4P plus 5Q, and this, if I divide by 40, this will be 4.44. Now if I multiply this by 4, this will be 4P plus 4Q equals to 4. Now if I subtract, this will be Q would be equals to 0.44, and your P would be equals to how much? 0.56, right? So what is the ratio? They are asking me the ratio. So this would be almost 5:4, very close to 5:4, right? Very close to 5:4, because if you divide, like, basically 0.55 is, if I approximately write this as 0.55, right, this will be almost 5:4, that is present in option A. Okay, there will be some points, like, but it will be very close to 5:4. So option A would be the correct answer in this question. Read the following information carefully. A, B, C, D, F, G are sitting around a circle and are facing the center. So all of them are facing the center, right? So let me make a circle, and all of them are facing the center. So let's assume this is the center, right? Now let's read the statements. G is second to the left of C. So G, this person, is second to the left of C, right? So let me make C, and to the left of C. Now which side is left? If I'm facing on in the center, right, to the left would be on this side or this side? It will be this side, right? So second to the left of C, that will be somewhere here, right? G would be here, and somewhere in between there will be some other person. Now, continuing on that, who is to the immediate left of F? So if there is a continuation, right, who, then this who is basically the most recent person that was discussed. C was discussed, so they're talking about C here, right? G is second to the left of C, who, that means they're talking about C. C is who is to the immediate left of F. So to the immediate left of F, C is there, right? So if I assume F to be here, then the left of F is this. So to the immediate left of F, there is C. This diagram is absolutely correct. Now let's go to the third statement. A is third to the left of E. A is third to the left of E. So third to the left of E, currently nothing is mentioned. I don't know where A and E will be. So let me just mark them randomly. A is here, and to the left of, sorry, A is third to the left of E. Sorry, first I have to draw E, right? So E is here. Left would be, I'm facing towards here, so left would be here. Third to the left of E. So A is somewhere here, and in between there will be some other person. I don't know. This diagram may be incorrect because I have yet to read the fourth statement. So B is between D and E. So B is between D and E, right? So B would be between D and E, right? So this is not a correct position for B. B would be somewhere here, right? Because if I place my B here, then it will be between A and E. That is not possible. So B has to be somewhere here. It will be between D and E. So D has to be the immediate right of B, right? Okay. So this is a rough diagram. Now, how many people are there? So A, B, C, D, E, F, G, H. So A, B, C, D, E, F. Now this one person was missing here, right? So that means our diagram is still not complete. So we can place E over here, right? If I place E over here, so to the immediate left of E, A can come here, and then B can come. Sorry, B has to come to the immediate right of E. That is not possible. So no, this is not possible. Actually, what is possible? So D can come here, right? D can come here. So all this can be shifted to the in the anti-clockwise direction, correct? So D can be between C and G. That is totally valid. Now B will be here. I'm just shifting everything to the anti-clockwise direction. That's it. That is what I'm doing. I'm just shifting everything to the anti-clockwise direction, right? Okay, and A is here, but A is to the second right. Okay, this is also not valid, right? Because A has to be to the second left of E. Sorry, A is to the A is to the I read it wrong. A is to the third left of E. I'm sorry. So A is to the third left of D. Okay, things have gone a bit wrong. Okay, this is, let me keep the D over here. So sorry, there will be 2% in between, right? 2%. Okay. So where can I keep E and B and D? So if I shift everything there, that is not valid. So if E is here, B has to be in between. They've talked about G. G is to the second left of C. That is correct. Who is to the immediate left of F? Okay. So, okay. I got it. So what, I can shift everything to the clockwise direction, right? I can shift everything. I can shift A to here. If I shift A to here, what will be happening? So then E can come here, right? Don't worry, I will place everything. Then I will explain you after arranging what is happening. So now all the arrangements are correct. Okay, all these arrangements are correct. They are not equi-spaced, but they are correct. So let me read the statements once again. So G is second to the left of C. So G is second to the left of C. So first and then second, right? So second to the left of C. Yeah, this is the left of C, and the second person is G. That is correct. Now, who is immediate left of F? So left of F is C. Correct again. A is third to the left of E. So third to the left of E, right? So this is the left, right? This is the left hand side of E. E is facing this side. This is the left hand side of E. So 1, 2, 3. Yeah, third person is A. Correct. Then B is between D and E. So B is between D and E, again correct. So all the arrangements are correct. Now you're proper. Now you will answer the options. A is fourth to the right of E. So no, A is okay. To the right of E, right? So here 1, 2, I'm to the right hand side, meaning anti-clockwise, correct? It is facing this side. So 1%, 2%, 3%, 4%. Yes, first option is correct. A is fourth to the right of E. This is correct, but they have asked you to mark the incorrect answer, right? False. Be careful while reading the question. They have asked you to mark the incorrect. G is to the immediate right of D. G is immediate right of D. Yeah, I'm facing this side, and to the right of D, I have G. That is correct. So this is again not your answer. F is third to the right of D. Okay, so I'm facing this side. Right of D would be 1, 2, 3. Sorry, hold. F is third to the right of D. Sorry, to the right of D, right? So I'm facing this side. Right of D would be 1, 2, 3. No, third person is C, not F. So this option is certainly your answer. Let us read the last option as well, just to verify. B is immediate left of D. So okay, D is facing this side. Left of D would be this. Yeah, B is to the immediate left of D. Absolutely correct. So option C is your answer for this question. In a school, the periodical examinations are held every second month. In a session, okay, every second month there are examinations that are held every second month, right? In a session during April 2010 till March 2011, a student of class 9 appeared for each of the periodical exams. The aggregate marks obtained by him in each periodical exam are represented in the line given below, right? So each exam, how much marks is he getting, it is represented. In which periodical exam did the student obtained the highest percentage increase over the previous periodical exam? So basically, in which particular month was the highest percentage increase, right? How do I calculate percentage increase? It is the final value minus the initial value upon the initial value, because they are asking me over the previous periodical exam, so it will be upon the initial value into 100. Obviously that will give you the percentage increase. It's very simple, nothing to think about. Graphically also you can see, like, there is a huge jump here, right, and there is a quite a jump here, but these jumps are very low, right? So it intuitively makes sense the percentage increase, right, would be somewhere here. That will be maximum. It will be either uh, October, August, like October 2010 or December 2010, right? So if we see one thing intuitively how we can do, I will tell you. So there is an increase of 5, there is a jump of 5. So these are same, right? Here also there is a jump of 5. So these are not that high. But I see there is a jump of 15. There is a jump of 15 here. Great. Both these jumps are same. Now, if both these jumps are same, that basically the final minus initial for both these cases is same, that is 15. The denominator is different. For this case, in October 2010, the denominator is 370 for the first case. And for the second case, the denominator is 385 for this case, right? It is 385. So certainly this one is lower, right? So overall, if the denominator is lower, so overall this ratio will be higher in October 2010. So your answer would be October 2010, and you can safely calculate it. So it will be for October 2010, it will be 15, the difference, final minus initial. Final is this one, initial is this one, upon the initial value 370. You can compare this value into 100, obviously. Compare this value with the next one, right? This one, 15 upon 385. Sorry, yeah, 385 into 100. If you compare, obviously this one will be higher, right? You can calculate the percentage. This one will be higher. So option C will be the correct answer for this question. The Memo service has trains going from Mumbai to Pune. So I'm going from Mumbai to Pune and Pune to Mumbai every hour, right? So every hour, every 1 hour, I have trains that start both from Mumbai to Pune and from Pune to Mumbai as well. Okay, great. The first one from either station starts at 6 a.m. So my starting point or time on both the sides would be 6 a.m. The trip from one city to another takes 4.5 hours. So this time duration distance is around 4.5 hours, 4.5 hours basically. And all the trains travel at same speed. Okay, so for all of them it will take 4.5 hours. If a train starts at 12 noon, so I'm starting at 12 noon, okay, from Mumbai towards Pune, I'm starting from 12 noon. Okay, how many will it pass during its entire journey? So how many trains will this current train pass? So I have a train here, right, that is traveling from Mumbai to Pune, that starts from 12 noon, and every hour there are trains that start. So of course it's a 4.5 hour journey. So it will meet some trains. What will be those trains? That is what they are asking me. Correct. So basically they are asking me how many trains will it pass during its entire journey. So what is happening, right? One train, there are two tracks, right? Memu service, there will be two tracks. One train will be going from Mumbai to Pune, and the other train will be coming back from Pune to Mumbai, right? There are two tracks parallelly. So once this train goes from Mumbai to Pune, it will obviously cross the trains that are coming back, that are coming from Pune going towards Mumbai, right? So okay, so it is starting from 12 noon, correct? If I see a train that starts from 6 a.m. from Pune, this 6 a.m. train would reach here at what time? At 10:30 a.m. So the first Pune train that will reach at Mumbai will be 10:30 a.m. Next train would reach at 11:30. So till this point, right, my train has not even started. So of course, this train, right, that starts from 12 noon, it will not see this train. Now, the next train, right, that starts from what time? That starts at 8 a.m. The train that starts at 8 a.m. that will reach here at 12:30 a.m. Sorry, p.m. So certainly somewhere in the middle, right, it will reach at the station at 12:30. So it will be somewhere in the middle here, right? Once my train starts from Mumbai, this train, it will somewhere meet this 12:30 p.m. wala train, correct? Now, what about the next train? Now, this train will finish its journey when? At 16:30 p.m. Right, 16:30, like we should actually not provide 16:30 here. So it's a 12 hour. So 16:30 basically means PM only, right? Or you can say 4:30 p.m. Same thing. Don't worry. Right? Okay. So I have to calculate how many trains are actually crossing or in there on the track in this whole period from 12 to 6:30 p.m. right? So this is one train. Then another train that will start at 9 a.m. right? That will reach here. So that will also be on. That will somewhere meet. That will reach here at 13:20 p.m. So this was also one train. So two trains. Then again another train is there that will reach here at 14:30 p.m. 3 train, right? Now, okay, this will 1 2 3 9 a.m. 10 a.m. then 11 a.m. 12 a.m. 13. So what is happening? So I have to, first of all, I have to find out the starting point from where this train will see the trains that are coming from the Pune side. The starting point is 8 a.m. right, because the 8 a.m. train will reach at 12:30. So somewhere in the middle it will meet, and this train, right, that starts from Mumbai at 12 noon, this will reach at Pune at 16:30, right? That is basically 4:30 p.m. So I have to compute from 8 a.m. till how many trains are there till 16:30, basically 4:30 p.m. All those trains will somewhere start from here and somewhere meet this train in their respective tracks, right, in the in the track, right, somewhere they will meet in the middle. Okay, so from 8 a.m. to 4:30 p.m. how many trains I have? So how many hours is that from 8 to 4:30? It is basically 16 minus 8 plus 1, right? This is the amount of hours, that is 9 hours. You can calculate between 6. So if I start from 8 to 16, I have 9 hours. Cool. So how many trains will be there? Each hour there are trains. So total I have 9 trains. Correct. So here 9 trains will be answered. Like you can solve this very easily, very quickly. I'm just explaining you all this, but all this is not required. You know, there are trains that will start from Mumbai to Pune, Pune to Mumbai. Or they have told you that my train starts from 12 noon. and they're asking me how many trains will it meet that are coming from the other side, right? Pass. So basically what is happening? Basically, right, I have to compute the starting point, because if I see 6 a.m. train reaches here 10:30 a.m., my Mumbai train does not even start there, right? So it will certainly not meet. I have to see the starting point. I saw that at 8 a.m. it is reaching here 12:30 p.m. So somewhere in the middle they must meet. So 8 a.m. is the starting point. Then I will compute till 4:30 p.m. because my Mumbai train is reaching its destination Pune at 4:30 p.m. So before that, whatever many trains are there that will start, it will obviously meet the Mumbai train that is coming from Mumbai. So I will calculate the number of hours from 8 a.m. to 4:30 p.m. that is 16 minus 8 plus 1. Very simple maths, arithmetics. So 9 hours, and every hour I have a train. So there will be total 9 trains that this Mumbai train will cross. So answer would be option C. Yeah, this is a good question. ABCDF is a regular hexagon of side 6 cm. What is the area of triangle BDF? So this is a regular hexagon. Now they are asking me what is the area of triangle BD and F, right? So if it is a regular hexagon, do you know what are the angles of each of this? So it's a regular hexagon, right? So all these will be same angle, theta, 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 and theta. Okay. So do you know what is this angle? This angle also will be theta only, right? So it's very easy for you to remember. So if I have a triangle, what is the total sum of angles? It is 180. If I have a square, what is the total sum of angles? It is 360. So there is this formula, right? 180 into n minus 2. This I have told you in aptitude as well how to remember it, right? So it's very simple. When my n is 3, addition would be 180. When my n is 4, addition would be 360. So this is how you remember, right? You remember it for triangle and square. Then you remember the formula. You write it down. Okay, you write it down. Write down the formula and verify whether they are matching. Or if even if you forget, right? Okay, I have forgotten. But you know somewhere it is something like 180 into something, right? What is that something? How can you derive it? So you can derive it by examples. You draw triangle, you draw rectangle, and okay, you say okay, there are 3 sides. So it is something n minus something. I don't remember. So it will be n minus 2, because here if it is 180 into n minus x, right? X has to be 2 here, otherwise it will not be 180, right? That's how you remember the formula. Cool. So in this case, it is a regular hexagon. So I have 6 sides. So it will be 180 into 4, that is 720, right? And if I have 6 sides, I will have 6 angles. So each angle will be basically 720 divided by 6, that is nothing but 120 degrees. So each angle would be 120 degrees. Cool. Each angle is 120 degrees. That is fine. Now what is the problem? This is 120 and okay, so all these are 120, right? All these are 120 angles. Okay, and this is also 6 centimeter. This is also 6 centimeter. So these two sides are same. If these two sides are same, these two angles has to be same, right? We know simple property of triangle. If the sides are same, angles has to be same. I hope you remember it for the same triangle. Again, here also this will be theta. This also will be theta. This also will be theta. This also will be theta. Now this whole angle is what? 120, right? And which is equals to what? Let me assume this as y. This will be y plus 2 theta equals to 120. Y plus 2 theta equals to 120, right? And do you observe all these triangles are congruent? So how do I congruent? So these two sides are same, these two angles are same, this angle is also same, right? Side angle, side. All these 3 triangles are congruent by side angle side. So that means this side also will be same. Now if all the sides of a triangle are same, that means these angles are also same. That is what? It is a equilateral triangle, that is 60 degree, 60 degree and 60 degree. So your theta comes out to be this 60, right? Y is 60 degree. So your theta comes out to be 30 degrees. So this is 30 degrees. We got to very good amount, because what do I have to calculate? I have to calculate the area of this triangle, right? For that I need to calculate the side. I need to compute the side. I am getting there. So this is 30 degrees. Now how will I solve it? Now what we know, this I have a triangle here, right? And this angle is 120. If I drop a perpendicular bisector, right, and this angle is same 30, this angle is also 30. So we know if it's a perpendicular bisector, this will be divided x by 2, this also will be x by 2. If this whole length is x, right? So all I am doing is I am taking this triangle and this is my x. So this will be x by 2, x by 2. This side I know, this is already 6 centimeter, this is already 6 centimeter. So this is 6, this is 6, right? We know, like, if I drop a perpendicular bisector, right, again you can use the angle, so side, this side, an angle. So angle, side angle, or side angle, side, right? So they will be again congruent, correct? If they're congruent, that means these two sides must also be same, correct? So okay, so that means this overall is x, and if these two sides are same, that means each of them will be x by 2 and x by 2. Cool. Now you can simply use trigonometry. So this will be 90, right? So trigonometry would be cos of 30 would be equals to what? Would be equals to base upon the hypotenuse. So x by 2 upon the hypotenuse, that is 6. So that would be x by 12, and cos 30 is root 3 by 2. Root 3 by 2. So x would be equals to 6 root 3. So x is equals to 6 root 3. Now what you can do is, now what you need, this is an equilateral triangle and you have got one side. All you need to do is calculate the area of this triangle. Again we can use the same property, whatever I taught you just here. I can use the same property. Again, if I drop in a perpendicular bisector here, I know the side, although there is a formula, right? I know there is a formula and I know you know that, but still without the formula, if I want to do it. So this is 6 root 3, this is 6 root 3. It is an equilateral triangle. Again, this is a perpendicular bisector, so they will be divided equally. So this is also 6 root 3 actually, but as they are divided equally, this will be 3 root 3 and 3 root 3. Now I think it's pretty simple to calculate the area of the triangle. I don't know this side, right? Because I need, for area, what do I need? I need half into base into height. I do know what is base. Base is this 6 root 3. What is height? So again we can use the sine of this. So this angle is 60, right? It is an equilateral triangle. So this angle is 60. So sine 60 will be equals to height upon the hypotenuse, that is, let's say x upon, I'm assuming this to be x now, upon 6 root 3. Sine 60 is root 3 by 2. So this will be 6 will go there, 3 into 3, that is 9. So x would be equals to 9. So that is basically height would be equals to 9. So half into, this is 6 root 3 into 9, that is 3 root 3 into 9, that is 27 root 3. So 27 root 3 is your answer of the question that is present in option B. So option B is the correct answer for this question. The following pie chart shows hourly distribution in degrees. So hourly distribution in degrees of all the major activities of a student in a day. So these are all the activities of a student in a day. It is a distribution, hourly distribution, right? They have represented it in terms of degrees. If the time spent in game is equal to the time spent in homework, so time spent in game is equals to the time spent in homework, okay, in all other activities, and time spent in all other activities remains constant except sleeping, then percentage increase in time of sleeping would be equals to what? Okay, so what is the amount of sleeping here? What is the initial amount of sleeping? So theta sleeping, right? So overall this should be 360. So this is 45 plus 105, that is 150, right? 150 plus 60, that is 210, plus 60, that is 270. So remaining would be my 360, that is 90. This would be 90 degrees. So this is 90 degrees. Okay, now this is 90 degrees. So initially the sleeping period was 90 degrees, because obviously it will be proportional to the hours, and degree will be proportional to the hours, right? Because this represents the hourly distribution. Okay, initially it was 90 degrees. Now what are they telling me? If the time spent in game is equal to the time spent in homework, so time spent in game and homework are equal. So both of them are x now. So this is also x, this is also x. And time spent in all other activities remain constant except sleeping, right? So time spent in homework is how much? It is 45 degrees, right? Now it is equals to time spent in game is equals to, time spent in, what is the time spent in game? It is 60 degrees, right? 60 degrees is equal to the time spent in homework. So now they are telling me the new time spent in games is equal to the time spent in homework previously. So I should mention in the question, this will be mentioned, don't worry, that when they are talking about the homework, they are talking about the previous time. They are talking about the previous time, right? This, so the student is changing the time spent in game, new time, to the previous time, right? Time spent in homework previously it was 45 degrees. Now time spent in game also will be 45 degrees only. So both of them will be 45 degrees, right? And all others are same, this and this are same, and time spent in all the other activities remain constant except sleeping. Okay, sleeping can change. So if there is a delta, what has changed? This is constant, games has reduced by 15, so obviously sleeping will increase by 15, right? Because this all has to add up to 360. So sleeping will now increase by 15, so it will now become 105. What are they asking? The percentage increase in the time of sleeping. So percentage increase would be the change, that is 15, upon the initial value, that is 90 degree, into 100 percentage. So 1 by 6 into 100 percentage, that is 16.67 percentage, that is option 4. So option 4 is the correct answer for this question. To do a work independently, B requires 6 more days than what A requires. So B requires 6 more days than what A requires. So what is the efficiency of B? It will be 1 by B. And what is the efficiency of A? It is 1 by A, where A is the number of days required to complete a particular work. So if I relate the efficiency of B with respect to A, it will be what? Because B requires 6 more days. How many days A requires? A. So B's efficiency would be 1 by A plus 6. Got it? So this is the first step. Now what are they asking me? If they are working together, it will take them 2 days less than what A requires alone. So if they are working together, right? So basically 1 by A plus 6 plus 1 by A, it will take them 2 days less. That is, what is the efficiency? It will be 1 by A minus 2. So per day efficiency would be 1 by A minus 2, because the work will be completed in A minus 2 days. Now what are they asking? B, now they are asking me what is, in how many days B alone can complete the work. Basically they are asking me this value, right? Okay, this is B value. So first let us solve this, and then we can find A, and then we can solve for B as well, because B is nothing but A plus 6. It's very simple work time problem. Okay, so so how to solve this? There is no other way than to solve and than to do cross multiply. Okay, so let me multiply these things. This will be A plus 6 into A minus 2, and on the other side will be A into A plus 6. So this will be 2A plus 6, 2A plus 6, into a minus 2, that is a square plus 6a. So this will be 2a square. This will be 2a square minus 4a plus 6a minus 12 equals to a square plus 6a. 6a will be cancelled. Now what will happen? So this will be a square minus 4a. 6a has been cancelled. Okay, that these things will go on the others. Okay, this is correct only. A square minus 4a minus 12 equal to 0. So this will be my 4 plus minus b square minus 4ac. Okay, b square 16 minus 4ac, that is plus 48 by 2a minus b plus, yeah. Okay, so what will be this? This will be basically 64, right? So 4 plus minus 8. So of course it has to be 8 only, plus 8 only. It cannot be minus because a can, like days cannot be negative. So this will be 6 days. So a is equals to 6. So b will be equals to a plus 6, that is 6 plus 6, that is 12. Right? So option A is the correct answer of this question.
Yeah, so did you solve this question? Look, there are three perfect logicians or professional logicians. They are going into a bar and the bartender is asking them, do all three of you want a drink? So three guys are there and he is the bartender who asks them that, do all three of you want a drink? Okay, what he's saying? He's saying, I don't know. What does that mean? It means that yes, he wants a drink. Why is that so? What is the question? Do all three of you want a drink? That means this particular guy, if he was not wanting a drink, if he doesn't want a drink, then he would have simply said no. Did you understand this point? That he is asking all three of you want a drink or not? All three of you. If he knows that, sir, I don't want a drink, that means the answer would have been no. That all three of us don't want a drink. I don't know about these two, but surely I don't want a drink. What does that mean? That all three of you want a drink? No. That would have been the answer. But if he is saying that I don't know, what does that mean? That means yes, I want a drink, but I don't know about these two guys. Is that understandable to you? Three answers could have been there. Yes, no, I don't know. These three answers could have been there, right? If this particular guy did not want a drink, then his answer would have been no. Why is that so? Because he is asking, do all three of you want a drink? If he doesn't want a drink, that means all three combined doesn't want a drink. I don't know about these two, but if I don't want the drink, that means all three are not wanting the drink. Two of them wants the drink. It might happen that two of them wants the drink, but all three are not wanting the drink. Is that understandable to you? So his answer would have been no. If he doesn't want the drink, that means he is wanting the drink. Same goes for the other guy as well. Yes, he is also wanting the drink. He is also wanting the drink, and he is the perfect logician. That means he has already understood that yes, this guy wants a drink, this guy wants a drink. Then depending on his mindset, that sir, if I want a drink, then he would have said yes. If he doesn't want a drink, then he would have said no. That means this guy knows that these two guys want a drink. That means now it's up to him. Now it's up to him. If he wants a drink, then he would say yes. All the three guys are wanting the drink. If he doesn't want a drink, then he would say no. That all three doesn't want a drink. These two guys want a drink, but I don't want a drink. Is that understandable to you? So either yes or no. Is this logic clear to you? Three guys are there. Bartender is asking, all of you wanting a drink or not? All of you. So first one said that I don't know. That means I want a drink, but I don't know about these two guys. If he was not wanting the drink, what he would have said? He would have simply said no. No, all of us doesn't want a drink. What does that mean? That means two guys maybe wanting the drink. I don't know about them, but surely I don't want a drink. Then he would have said no. But he is saying I don't know. What does that mean? If he is saying I don't know, that means he is not sure about these two guys. At least he wants a drink for sure. Same goes for the other one as well. Now the last one would either say yes or no, because he knows that these two guys are wanting the drink. Is that understandable? Okay. So this was a good question. And sir, why would you frame this kind of question in aptitude? Yes, these kind of questions are asked, not in this manner. We guys are engineer, right? If someone would have been there from class 11th, 12th or class 10th class guy, then I would not be asking this particular question. First, I thought that I should be putting coffee here, but we guys are engineers, so I know about you. Okay, so drink would work for you. So yes or no would have been the answer. I hope it is clear to you. Let's go to the next one. Yeah, so this was a very good question. Hardly, I guess, 3 to 4 people would be able to answer it. Like, people will be comfortable with this option, but they will be struggling here. So let's first prove the first two options which was there in our class notes only, and would have been there in all the class notes, right? Because this is very standard thing, that if your xt is real, if your xt is a real valued signal, what does that mean? If xt is real valued signal, then what about the phase spectrum? Phase spectrum would be, sorry, not phase spectrum, magnitude spectrum. Magnitude spectrum would be even. And what about the phase spectrum? Whatever the angle you get at positive frequency plus whatever the angle that you get at negative frequency, both should be even multiple of pi, or you should say multiple of 2 pi. Both should be, addition of both of the angles should be multiple of 2 pi, or you can call it even multiple of pi, right? This is the scenario. Some people remember it that they will simply put it equals to 0. Then they will say that, sir, magnitude spectrum would be even, but angle spectrum should be, phase spectrum should be odd. That is absolutely baseless. Why is that so? 90 degree minus 90 degree. You would say, sir, it is a odd spectrum, right? It is a odd spectrum. But what if 90 degree minus 90 would be written as 270 degree? Is it looking like odd? Would you call it odd spectrum? But it is actually odd only, because 90 and minus 90. That's why we should never say that phase spectrum is odd. This statement is baseless. Phase spectrum is odd. This doesn't make any sense. What we should say? Let us say this was omega 1, so this would have been minus omega 1. This is omega 1, this would have been minus omega 1. So whatever the angle that you are getting at the positive frequency plus whatever the angle that you are getting at the negative frequency, if you add both of them, what you are getting? 360 degree. If you add both of them, what you are getting? 0 degree. Is it a odd multiple of, is it a even multiple of pi? Yes. Is it a even multiple of pi? Yes. In place of n, you put 0. This is something you will be getting. In place of n, you put 1. This is something you will be getting. That means, yes, it can work for real signal. Is that understandable to you? So saying that phase spectrum is even or odd, that doesn't make any sense. In a lot of notes, I have seen this particular thing. Okay, they write down that phase spectrum would be even or odd. That doesn't make any sense. This is how we should remember it. Angle at positive frequency plus angle at negative frequency should be equal to 2 and pi. Although that even odd theory will work here, right? This is even and this is odd. This is even, this is odd. So both of the options would be correct. But ideally, we should check that at this particular frequency, at positive frequency, whatever the angle I am getting, at the negative frequency, I am just getting the negative angle of that. Let's just say at this is your omega 1, this is your minus omega 1. So at omega 1, I am getting, at omega 1, let's just say I am getting angle 70. So sorry, minus 70. Then this angle would have been plus 70. So minus 70 plus 70 would have been 0 degree angle, which is a even multiple of pi. Right? So this option would be correct. Same goes for this option as well. This option would also be correct, because here let's just say at omega equals to 1 and here omega equals to minus 1. So here the angle I am getting is minus 3 and here angle I am getting is plus 3. So plus 3 minus 3, what that would be? That would be 0. So that would also work, right? So this option and this option, both of the options would be working. That means these two options are correct. This option is correct and this option is correct. What about these guys? Sir, real part of x of omega, imaginary part of x of omega. Sir, what it is? So x of omega is written as real part of x of omega plus j imaginary part of x of omega. Do you understand this point? Surely you understand this point. If your x of t is real, then what would be the scenario? This would be the scenario, that x of t should be equals to x conjugate t, or you can say that x of omega would be equals to x conjugate minus omega. Now if this is x of omega, then what would be x conjugate omega? Just take the conjugate of this. That means conjugate of this, what will be the conjugate of j? That would be minus j. What will be the conjugate here? This will be the conjugate. What will be x conjugate? Minus omega. X real conjugate minus omega minus j x imaginary conjugate minus omega. This is equation 1. This is equation 2. Both should be equal. If xt is real, if xt is real. Did you understand this point? I am just taking the conjugate. That means this quantity could also, like, basically I am taking the conjugate of this plus j would be replaced as minus j and then taking the conjugate of this. But the thing is that this is the real part, this is the imaginary part. Both will be real quantity only, no? 3 plus 2j. Is it a complex number? Yes. This is the real part. Yes. This is the imaginary part. Real part is 3 and imaginary part is 2. So real part is also real and imaginary part is also real only. So this will be real only. Although x conjugate of this conjugate will not make any sense. But still let's put it there. Okay. Although this conjugate will not make any sense, but let's just put it there. Now if your xt is real, that means equation 1 would be equal to equation 2. What does that mean? That means x real of omega should be equal to x real conjugate of minus omega and x imaginary of omega should be equal to x imaginary conjugate minus omega, and then there is a negative sign as well. Just compare negative sign as well. So these two conditions should be satisfied if your xt is real. So imaginary part, is there any meaning of conjugate? No. So imaginary part should be even. Sorry, real part should be even. Real part even. There is no meaning of this conjugate sign because this value will also be real and this value will also be real only. Because this is the real part, this is the imaginary part. So they have to be real, no? I just gave this example, 3 plus 2j. So this is real, this is also real. Right? So what does that mean? There is no meaning of this conjugate. So can I say that real part has to be even? Because x r of omega should be equal to x r of minus omega and imaginary part has to be odd. You are not going to mug it up. In this manner you are going to derive in the examination. So this case we are getting for xt equals to real. Who knows, they may ask xt equals to imaginary. Then will you again mug it up? With this also you will mug it up. Then for even odd also you remember some results. So nothing we are going to mug up. In this manner we are going to derive in the examination. Okay. Who knows, I am asking something, they can ask something else as well. So you should have the aptitude that sir, I will be able to write down x of omega, x conjugate of omega, x conjugate of minus omega, and in that manner I will be able to solve it. So this real part has to be even and the imaginary part has to be odd. This is real, sorry, this is even, this is also even. Not correct. This is even, this is neither even nor odd. So this is also not correct. Is it even or odd? No, this is neither even nor odd. Don't get confused with this 2 pi. People will be thinking in the direction of angle. This is not the angle, this is the magnitude. Okay. This is 2 pi, not the angle. What is the angle? Here what is the angle provided? Minus 180 degree. Here what is the angle provided? 0 degree. Right. So basically positive means 0 degree angle. Negative means minus 180 degree angle. Right. Or plus 180 degree angle. So don't think about the angle. Just simply we have concluded this particular thing, that real part has to be even and imaginary part has to be odd. So both are not correct. Only these two options are correct. If I wanted to make it real, then what would have been the scenario here? That this should be somewhat like this. Imaginary part should have been somewhat like this. If this is the scenario, then your job would be done. Say yes or no. Right? If this is the scenario, then your job would be done because this part is now odd. So this would have been real. But here, this is the scenario. Well and good. I hope you have understood something new here. Let's go to the next one.
For a synchronous machine operating as a motor under no load conditions, determine the magnitude of the reactive power. So if it is operating under no load conditions, these are the values given: a terminal voltage, the synchronous reactance, the armature resistance is 0, the excitation voltage EF is 2, all values are in PU. Then they are asking me what is the magnitude of the reactive power delivered by the motor. So do you remember this thing, that this is my motor, right, and this is my Vt angle 0 and this is my EF angle delta, right, minus delta, because we say that obviously if some active power transfer will happen, then obviously this delta, like this angle of the voltage will be higher than this angle, because then only active power will flow from the like terminal voltage, right, from the bus, infinite bus. Now the thing is that they're telling me it is operating under the motor is operating under no load, that means no active load is connected, right? If no active load is connected, that means the power input to the motor is simply 0. Power input to the motor is simply 0. If it is 0, that means this value VTEF by XS sin delta, right, will be 0. And if it is 0, that these all values are non-zero, that means your delta value is 0. Delta is 0, correct? So this angle of the voltage and angle of the angle of the voltage of the motor, excitation voltage and the terminal voltage are the same. So let me actually copy this. So this will be 0. So what is EF? EF is 2, VT is 1 angle 0, and this is J1.25. Now, of course, it does not take any active power, but you see, right, there is some inductive link connected, and if there is some inductive link connected, the active power will flow. How to calculate that? It's very simple. We have the voltage difference, right? If we have the voltage difference, reactive power certainly will flow no matter what. So do you remember the formula of reactive power? It was this, right? VT by XS into VT minus EF cos delta, right? So if I'm starting from here to here, then I'll write VT by XS first, and then I'll write VT minus EF cos delta, the difference of the voltage between them, right? So this will be equals to what? VT is 1, XS is 1.25 into VT 1 cos delta, delta is 0, right? Delta is simply 0, right? If cos delta is 0. Okay, hold on. Delta is 0, yeah, this will be 1. So the reactive power flow, this will be actually EF is 2, so this will be minus 1 by 1.25. Now what is 1 by 1. It is, I think, minus 0.5, 0.8 PU. So that basically means that the motor is delivering the reactive power, but in the question I have asked the magnitude of this reactive power, right? Magnitude. Okay, so the magnitude would be 0.8 PU. This will be your answer of the question.
What about this question? Sir, initially capacitors are shorted, no initial voltage is there. Initially means at t equals to minus infinity. I'm talking about at t equals to minus infinity. In the capacitors are shorted, no initial voltage is there. 15 voltage will be applied at t equals to minus infinity. What does that mean? Sir, here there is 0 voltage if I apply the open circuit test, and here there is 15 volt. That means this diode would be turning on. If the diode is turning on, then what will be the circuit? You know the circuit, but what I need to care about? I need to care about the circuit at t equals to 0 minus. At t equals to 0 minus, what will happen? So steady state would be reached. In the steady state, capacitor will be open circuited. If the capacitors are open circuited, let's just say this voltage is V1 and this voltage is V2. So what will be the V1 V2 voltage? So V1 voltage would have been, sir, 40 divided by 40 plus 20 plus 15, or that would be 75, right? Into whatever the voltage was applied, 15. So 8 volt. And what would have been V2? This is simply the half of the resistance, so it would come out to be 4 volt. Now at t greater than 0, for t greater than 0, at t equals to 0 plus, what will happen? Sir, this is having 8 voltage, this is having 8 voltage, and sir, this guy is having 4 volt. That means, sir, here 8 volt, 4 volt, here total voltage is 12 volt. But sir, what is the voltage applied? 3 volt is applied here. What does that mean? This will be turning off, right? Open circuit test I am applying. Open circuit test I am applying. That means no current will be flowing here. So there will not be any drop across to 15 kilo ohm. So 12 volt here, 3 volt here. This will be turning off. If it is turning off, then what will be the circuit? R, C, 4 volt initial charge, R, C, 8 volt initial charge. So this kind of circuit you would see, right? This capacitor is 5 microfarad, 5 microfarad. Both are same capacitance. So 5 microfarad, 5 microfarad. What is the resistance? R to R. So 20 kilo and 40 kilo. This is the scenario. This is charged to 4 volt, other one is charged to 8 volt. This is charged to 4 volt, other one is charged to 8 volt. Now see this circuit. Now what will happen? This 4 volt will be discharging. How it will be discharging? if from this capacitor I current is flowing, so this current will also be I. This current will also be I. If in this branch I current is flowing, so this current also has to be I. This current also has to be I. If in this branch this current is I, so this current also has to be I. What does that mean? In the whole loop I current is flowing. What did I say? From this capacitor if I current is going, then this current also has to be I. Both branches are in series, so this current also has to be I. This is also I, this is also I, and this is also I. So in the whole branch I current is flowing. That means this capacitor is getting discharged through this 20 kilo ohm resistance only. What about this capacitance? From here there is no current coming. If this current is I, this current is also 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 I. That means in the whole loop I current is flowing. So this capacitor, C capacitor, is discharging through 40 kilo ohm, and this C capacitor is discharging through 20 kilo ohm. Is that understandable to you or not? And what is your output voltage? This is my output voltage V naught T. So I need to write down V naught T. What will be the expression of V naught T? This capacitor is discharging through 20 kilo ohm. What does that mean? This 4 voltage will be discharging. 4 voltage will be discharging completely. So 4 e to the power minus t by tau. What will be the time constant? At 150 millisecond I need to find out. So 100 millisecond. Plus 8 volt will be discharging. 8 e to the power minus t by tau. So 200 millisecond. Now I just need to find it out at 150 millisecond. So just put the values, I will get the answer. So 150 divided by 100, that would become 1.5. So 1.5, and then calculation we need to do 1.5 plus minus e to the power into 4 plus bracket on. This would become 150 divided by 200. What that would be? 1.5 by 2. So that would be 0.75. So 0.75 plus minus e to the power 0.75 into 8. Then bracket close. 4.67. You are getting 4.67 volt. There you go. So is there any option? Yes, sir. This is the correct answer. So this was the only good thing here, that this capacitor will be discharging through this resistance only, and this capacitor will be discharging through this resistance only. So it will become a first order circuit, not the second order circuit. Okay, then let's go to the next one. Yeah, what about this one? Were you able to solve this one? Look, it is not tough if you just read it out. What this block is doing, what this F block is doing. This F block is taking the input and calculating its Fourier transform, then inverting it, multiplying with 2 pi, and then omega is put as t. This is what it is doing. Are you able to understand this point? Take its Fourier transform. What is the Fourier transform of x of t? That is x of omega. So take its Fourier transform, then invert it, and in place of omega put t, and then multiply the result with 2 pi. This is what this block is doing. Now this particular input 2 pi x of minus t, 2 pi capital X of minus t is going as the input to this F block. So what it will do? First it will take its Fourier transform. So do I know the Fourier transform of capital X of minus t? It is not the small x, it is the capital X. So do I know the duality property? If this guy comes here, what will happen? This omega is replaced as t. Then what will be its Fourier transform? 2 pi x of minus omega. What will be the Fourier transform of x of minus t? So that would be 2 pi x of plus omega, right? If here minus t you are putting, here also minus sign you need to put. And what will be the Fourier transform of small x of minus t? That will be capital X of minus omega. Now what it will do? Whatever the input is there, take its Fourier transform. What will be the Fourier transform of this one? So 2 pi as it is. X of minus t is having a Fourier transform of 2 pi x of omega. So 2 pi square it would become x of omega. X of omega. In place of omega you need to put minus omega, and then in place of omega you need to put t. Is that understandable to you? Take the Fourier transform. What will be the Fourier transform of 2 pi x of minus t? If x of minus t is having this Fourier transform, then what will be the Fourier transform of x of minus t? So that would be 4 pi square x of omega. Just multiply with 2 pi here, multiply with 2 pi here. So this is what we are doing. 4 pi square, small x of minus omega. Small x of minus omega. Small x of omega. Small x of omega. But what this is doing, whatever the Fourier transform you are getting, it is putting the negative sign. So putting the negative sign, then omega is replaced with t. Omega is replaced with t. So this is the output we are getting. And then whatever the scenario you are getting, that will be multiplied with 2 pi as well. Fourier transform of this one, in place of omega you are putting minus t, then multiply with 2 pi. So as of now the scenario is that I am getting 8 pi cube x of minus t. Now it will be again fed to f. It will be again fed to f. What is fed? 8 pi cube x of minus t. Say yes or no. Now x of minus t will be having a Fourier transform of capital X of minus omega, and this 8 pi cube is constant value, so 8 pi cube would come. X of minus t will have a Fourier transform of capital X of minus omega, capital X of minus omega. But in place of omega, what I need to put? Minus t I need to put. So here what I will be getting? Plus t. In place of omega, I was putting minus omega. So here in place of minus omega, I will put plus omega. And then in place of omega, I will put t. So this is what I have done. Along with that, I need to multiply with 2 pi as well. Right? Because this is multiplying the result with 2 pi as well. So what we are getting? 16 pi to the power 4 x of t. There you go. So this is the answer. Okay, so I just wanted to check the duality property. For checking the duality property, this question has been framed. Okay, you just need to know the Fourier transform of capital X of t. If you know this particular thing, then this question was cake for you. But you just need to think here that what this particular block is doing. Whatever this block was doing, just keep on writing it down and you will be able to get the answer. Okay, again a good question. Hardly 10 people will be able to solve it. Let's go to the next one. Like very straightforward. Everyone should be able to solve this one. Okay, everyone should be able to solve. Here you are applying 10 volt, 2 milliampere current you are getting. What is this voltage? Simply you can see that, sir, here I am voltage conversion I can do. So this was my network. Here I am applying 5 milliampere into 1 kilo ohm. What I will be getting? Resistance of 1 kilo ohm and battery of 5 volt. So 5 volt, 1 kilo ohm. And this is the scenario. Load is also the same. 500 ohm and 500 ohm. So this is 1 kilo ohm load only. So only thing that has changed is this 10 volt has become 5 volt. So if this has become 5 volt, then this response would have been becoming 1 milliampere. So here how much current would be flowing? Here how much current would have been flowing? 1 milliampere. Now this 1 milliampere will be flowing here as well. 1 milliampere current will be flowing here as well. So what will be the value of Vx? Vx value will be 500 ohm into 1 milliampere, that would be 10 to the power minus 3. So what will be the answer? 0.50 volt. Very simple thing, right? 10 volt, 2 milliampere, 5 volt, 1 milliampere. 1 milliampere will be flowing through this 500 ohm. So answer would be 0.50 volt. If you were not able to solve it, that means you lack problem solving skills. You need to solve more and more problems. Okay. Otherwise, this should have been solved. Let's go to the next one.
Figure shows 4 electronic switches 1, 2, 3, 4. Which of the following switches can block voltages of either polarity applied between terminals A and B? So I see this BJT can certainly block the opposite side voltage, but I have a anti-parallel diode. So this will conduct when I apply a voltage in the reverse direction. This will certainly block the voltage in the forward direction, but this will pass the voltage in the reverse direction, right? So although BJT has bi-directional blocking capability, but the parallel diode has only unidirectional voltage blocking capability. So 1 is certainly not my correct answer. Okay, 1 is wrong. What about the second part? Second part certainly is correct because this BJT can block voltage in both polarity. Although this diode can only block voltage in one polarity, but because if I apply a voltage in this polarity, if I apply a voltage in this polarity, already the BJT is blocking it. So it does not need the diode to block it, right? BJT is already blocking it because they are connected in series. So number 2 certainly has the voltage blocking capability. Number 3, this is a simple SCR. SCR, yes, it can block voltages in both polarities, certainly correct. What about this again? SCR with the anti-parallel diode, again it cannot block voltage in both polarities because the anti-parallel diode will be conducting. So only option 2 and 3 are my correct answers for this question. A thyristor operates in a circuit where it conducts a half sinusoidal current with 1 millisecond period and a peak amplitude of 100 amperes. Okay, as illustrated in the figure, during conduction the thyristor can be modeled as a constant voltage drop of 1 volt and a dynamic resistance of 6 millihenry. Calculate the average conduction loss in the device. So what will be the average conduction loss in the device? So this is a drop of 1 volt, right? So when the thyristor is on, this is the current through the thyristor, IT. So there will be what will be the power loss? Power loss due to the DC voltage source, it will be 1 into IT average, and power loss in the resistance would be IT RMS whole square into the resistance, right, R. Okay, that is 6 millihenry. So what is IT average? For a simple half wave rectified sine wave, IT average is Vm upon pi, right? Half wave rectified sine wave, Vm upon pi. This is the power loss due to the DC component. And what is RMS? RMS is Vm upon, so Im upon root 2, peak upon 2, right? So basically for a pure sinusoid, the RMS value is Im upon root 2. So for a half sinusoid, the area has been halved, so the square will be 1 by root 2. So certainly the RMS value will be simply, sorry, the as the area has been halved, so the RMS value will be 1 by root 2. So these things, these results are important. These things I have derived in network theory course as well, and in signals also I think you will know about this. So the RMS value would be Im upon 2. So it is Im upon 2, that is 100 upon 2 whole square into R. R is 6 milli ohms. So 10 raised to power minus 2. So this will be 50 square into 6 into 0.001, that is 15, plus 100 upon pi. So that is 46.83 watts. This will be your answer for the question. Two underground cables labeled A and B have conductor resistance to be this, and their insulation resistance are this. And this, right? When connected in series, the combined conductor resistance is this, the combined insulation resistance is this. So this again is taught in our YouTube playlist as well, in the full course as well. This has been taught that if I have two conductors which have a conductor resistance, right, and they are connected in series, right, if the conductors are connected in series, then their conductor resistances will be added. So it will be 0.6 plus 0.8, that is 1.4. So option A is correct. And their insulation resistance will be in parallel. How it happens, all this thing has been derived in the YouTube playlist videos, in the lecture series you can watch, or in the full course also you can watch. So the insulation resistance will be in parallel. So it will be 600 into 400 upon 1000. So it should be 240 megohms, right? So 240 megohms would be the answer of this question. So option A and D are the correct answer of this question. A transmission line having inductance L and resistance R is subjected to a short circuit fault at time t equal to 0. The applied voltage is this. It is observed that at alpha equals to this, the fault current obtains maximum negative DC offset, and at alpha equals to phi 2, there is basically no DC offset, right? Whatever is depending on the value of alpha. Now determine the value of phi 1 plus phi 2 in radians. So essentially it is just like a series RL circuit. Okay, that will be mentioned to you in the question, don't worry, it will be mentioned to you in the question. You just have to model the transmission line as a series RL circuit. Okay, so yeah, it is just essentially a short transmission line, right? Short transmission line. In a short transmission line, we model just with a simple series RL. So our RL is there, and this is the supply voltage that we're applying in the transmission line, that is 230 sine 100 pi t plus alpha, and the fault is happening at the other end of the transmission line. Okay, now yeah, so do you remember the expression of voltage? Do you remember when does the DC offset current is maximum? Do you remember it? So you, like this expression, exact expression I have derived in the full course, right? There I have derived this. So the DC offset will be maximum when your okay, let me show you when it will be maximum, right? So we can derive the expression of current here, right? We can certainly derive the expression of current. What will be the expression of current? So the expression of current, if let's say this is at angle 230, okay, let me assume this to be some V RMS voltage, angle is alpha, right? V is some V RMS voltage, angle is alpha. Okay, so basically my reference is V angle 0 degree. So the this phasor can be represented as V angle alpha. This now what is the impedance here? Z equals to R plus JL, or I can say magnitude of Z angle theta Z, right? So what will be the expression of current? Current expression would be V angle alpha upon the impedance, that is magnitude of z upon theta z, right? Now, but this expression was derived keeping in mind the steady state sinusoidal voltage, right? But this is not the proper expression. What was the proper expression? Do you remember? So the proper expression was something like this, that there was a e raised to power minus alpha t term into v by magnitude of v by z, right, into sine of theta minus alpha plus v upon magnitude of z into sine 100 pi t plus alpha minus theta z. Okay, this is the exact expression that I have derived. You can see in the YouTube playlist as well. There you can see, you can go in the power system playlist. I think it's in the second video. I exactly don't remember, but it is there. I think it's in the fault video only. I think, yeah, it should be there in the second video only, in the analysis of symmetrical faults. Okay, so what happens? They are telling me that your DC offset current obtains maximum negative value. So this is the DC offset basically. So if it obtains maximum negative value, right, that means this particular value, okay, theta z minus alpha, this has to be -1. Then only it will obtain maximum. So this is the maximum value of the DC offset. Okay. So basically sine theta z minus alpha must be -1. So your theta z minus alpha must be equals to minus pi by 2. Okay. Theta z minus alpha must be equals to pi by 2. So theta z is what? Theta z is nothing but the angle of my load angle of the, like this, transmission line, right? Impedance angle of the transmission line. So it will be omega into L upon R. So omega is what? 100 pi into L. L is what? L is 4.6, right? Upon R. So this would be 100 into pi into 4.6 upon 2.5 into 10 raised to the minus 7. So this is the tan phi z, right? Tan phi z. So that is 0.578. If I do tan inverse of this, so your, okay, your theta z actually is almost 90. It is coming out to be 90, which is not supposed to happen. That is interesting. Am I doing something wrong? 2 pi, it should not be 90. Just give me 1 second. Oh, sorry, 0.578. Yeah, it is coming out to be 30 degrees. Okay, and it is obviously minus 30 degrees because, sorry, theta will be plus 30 because it is lagging. That is fine. Theta z is plus 30, no problem. So here I will put theta z equals to 30. That is like this. Also I can put, now they have asked in radians, right? So I will put everything in radians. So theta z in degrees is 30. In radians it would be pi by 6. In radians it would be pi by 6 minus alpha equals to minus pi by 2. So your alpha would be equals to pi by 2 plus pi by 6, right? If I am not mistaken, 30 minus alpha, this should be equals to yes, 30 minus plus pi by 2. So this will be pi by 2 plus pi by 6, that is actually 120. That is essentially 2 pi divided by 3. That is 2 pi divided by 3. Right? That is my alpha. Now what about this is the angle alpha, that is my phi 1, right, in the case 1. Now in the case 2, what they are telling me, in the case 2 they are telling me that when the fault current contains no DC offset. So if there is no DC offset, this particular value will be 0, right? Only then only this DC offset will be totally cancelled. Now you will say how to remember this formula. All this I have taught in the full course. In the YouTube itself it is present. Go into the playlist, power system, there all this is there. So I'm just solving the question. So theta z equals to, theta z needs to be equals to alpha, right? For the case, so basically theta z minus alpha needs to be 0, right? So basically your alpha must be equals to theta z, that is equals to pi by 6. So this is my phi 2. What are they asking? They are asking me phi 1 plus phi 2. So phi 1 plus phi 2 would be 2 pi by 3 plus pi by 6, that is equals to 4 pi, 5 pi by 6. In radians this will be 5 into pi divided by 6, this will be 2.618. okay, so they have asked us to round off to 3 decimal places, so this will be the answer of your question. Given the ideal op amp circuit is shown, calculate the width of the hysteresis loop formed in the input output characteristics, assuming the diodes are ideal, exhibit zero threshold voltage, right? So they're asking me what is the hysteresis loop. Basically, right, what happens is when your input is greater than the upper threshold value, your output will go from minus Vsat to plus Vsat. Okay, and when your input is lower than the lower threshold voltage, sorry, lower threshold point, your output will go from plus Vsat to minus Vsat. We can verify that as well, right? So basically they are asking me this value, right? Your upper threshold voltage, upper threshold point minus the lower threshold point. Basically they are asking me this hysteresis width. Okay, so how do I calculate this? So let's assume that initially our output is at minus Vsat and I want to change my output from minus Vsat to plus Vsat. So what is the input voltage that I need to provide? So this is just like a comparator, right? This circuit is just like a comparator. So if it is at minus Vsat, so certainly this diode will be turned on. If I assume everything to be off, right, this diode will be certainly off, this diode will be on because its N site is at lower potential, right? So the circuit would be something like this. This would be the circuit. If I just remove this part, let me remove this particular part. This is the circuit, right? So if it is minus Vsat, what is happening? If it is minus Vsat, okay, Vsat is 10 volts, right? So it is minus 10. So this diode is on. So the voltage here would be what? This voltage would be minus 5 volt. Okay, this voltage here would be minus 5 volts. So basically my input, if my input is greater than minus 5 volts, sorry, if my input is less than minus 5 volts, right? If my input is less than minus 5 volts, then what will happen? The negative terminal voltage will always be lower than the positive terminal voltage. Then this will always be remaining at the minus 5 volts only. If my input is greater than minus 5 volt, if my input is greater than minus 5 volt, what will happen? Sorry, yeah, if my input, sorry, I was saying wrong, sorry. So if my input is greater than minus 5 volts, okay, then the negative terminal voltage is higher than the positive terminal voltage, right? Then your output always will remain at minus Vsat. I was telling wrong previously. If my input is lower than minus 5, that essentially means what? My negative terminal voltage, currently what is the voltage here? Minus 5, right? My negative terminal voltage, let's take a number minus 6. So the negative terminal voltage is lower than the positive terminal voltage. That means this is at higher potential. So then the output voltage will change to plus Vsat. So the upper threshold point, one of the threshold point is basically when my input is less than minus 5 volts, right? So basically at minus 5, this is one of the threshold points, right? Now what about the other threshold point? That is when my input is plus Vsat. When it is plus Vsat, the other side will be turned off, right? The other side will be turned off. This one will be turned off. This dot will be turned off. Now what will be your output? So if I see what is the positive terminal voltage, it is plus Vsat by 4. So it is 10 by 4 basically, right? So if my input is greater than 2.5 volts, If my input is greater than 2.5 volts, then certainly the output will go from plus VSAT to minus VSAT, right? Why? Because the negative terminal voltage will be higher than the positive terminal voltage, right? So what will be the total width? So this is the lower threshold point. If my input is greater than 2.5 volts, the output will go from plus VSAT to minus VSAT, and if your input is less than minus 5 volts, the output will go from minus VSAT to plus VSAT, right? So this is the width. Basically you can compute the width. The width would be basically minus 5, 2.5. So basically the width would be 2.5 of minus 5, right? You anyways have to decode the magnitude. Anyways you can see in the options, like they are all showing in the positive values, so certainly your option B would be correct, that is 7.5 volts. Let's solve this question. Transistors M1 and M2 are identical and each has a threshold voltage of 1 volt. Okay, now they're asking me, based on the circuit shown, identify the region of operation of transistors M1 and M2, right? Okay, so what is the region of operation? It is linear, saturation. So either it is linear or saturation, right? Okay. Threshold voltage is 1 volt. So okay, what is VGS here? So VGS is certainly greater than VTH. Okay, so if VGS is greater than VTH, then certainly what can I comment? I can comment that my these transistors are identical. VGS is greater than VTH, so certainly either this will be in the saturation region or this will be in the linear region, saturation or linear. Okay, now how do I comment? So I know the current will be same. Let's assume both of them to be in the saturation region. Let us assume both of them to be in the saturation region and they are identical MOSFETs. So if they are identical MOSFETs, that means what is the current in the first MOSFET? ID1 drain current, that will be equals to mu n Cux. They are identical, remember. So I can write directly here Kn, there is some constant, into VGS minus VTH whole square. What is VG? VG is 2.5. VG and this voltage, source voltage, I don't know. So it will be 2.5 minus Vs whole square, right? That will be equals to this current, right? What is the current in the second MOSFET? It will be Kn. They are identical. Kn constant will be same into VGS. Sorry, VGS minus VT, right? VT is 1 volt whole square, and here VGS is 2 minus 1 whole square. So what do we get? So we get this equation, right? So this is 1.5 minus Vs whole square equals to 1 square. So I can take the under root on both sides. This will be 1.5 minus Vs plus minus 1. Okay, I hope you understand why I'm writing here plus minus 1, because you will get two solutions. Okay, this will be 1, and if I take the under root of 1, right, it will be plus minus 1, because if I square, I will ultimately, if I square minus 1 as well, I will get 1. That's why. Okay, so your Vs will be equals to either 2.5 or it will be 0.5. There are two solutions. Vs is either equals to 2.5 or 0.5, right? So if your Vs is 2.5, if your Vs is 2.5, your Vgs is 0, and if your Vgs is 0, then certainly it will be in cutoff region that I don't see in the options, right? So 2.5 is not possible. If I assume it to be 0.5, if I assume it to be 0.5, so this point potential is 0.5, right? That basically means your VGS is how much in the top transistor? It is 2 volts, and VGS minus VT, the overdrive voltage would be 1 volt. Okay, and what is your VDS? VDS is 2.5 volts. So basically, right, for the transistor to be in for the transistor, right, to be in saturation region, for the transistor to be in saturation region, the VDS must be greater than VGS minus VTH, VTN basically. No, it is. So VDS in the transistor M2, right, is what? It is 3 minus 0.5. This point potential is 0.5, so it is 2.5. VGS is actually 2.5 minus 0.5, that is 2, minus VT, that is 1. So I can see 2.5 is certainly greater than 1 volt. So certainly the transistor M2 is in saturation. So transistor M2 will be in saturation. Okay. What about M1? So for M1, the drain voltage is 0.5. Okay. So what is VDS for the transistor M1? It is 0.5. Right. VDS is 0.5 because Vs is 0. And what is VGS? It is 2 minus VT, that is 1. So 0.5, is it greater than 1 volt? No. So certainly your transistor will be in linear region. M1, transistor M1 will be in linear region. Okay. So option A would be correct. I hope you get the point that if my Vs was equals to 2.5, then the transistor M2 would be cut off because your VGS would be 0. VGS is not greater than VTN, then your transistor would be in cut off, and nowhere I see cut off region, right? So certainly I will not choose this option, I will only choose the second option, right? And with that, if I proceed, then I will be able to comment what are the regions of operation for the transistor. And you will say, sir, will this come in your mock test? Yes, this will come in your mock test. Sorry, I mean, will this come in the actual gate examination? Yes, this will come in the actual gate examination. Okay, these kind of questions has come up in examination. You see the recent year question 2025, two questions came from MOSFET, two questions. Okay, it was not on region of operation, but one question was from the MOSFET amplifier. So it's important. Okay, it's not like it's not important, right? So option A will be the correct answer of this question. Let's solve this question. The block diagram of a standard second order system, right, is shown below, and the below graph is the unit step response of this same system. Now it is a second order system, very important point, it is a second order system. Analyze the closed loop frequency response of the system to determine the resonant frequency omega r, and it is basically the specific frequency at which the system exhibits its maximum output magnitude, right? What are they discussing? They are discussing about the frequency response. They are discussing about the closed loop frequency response. Please remember these things, right? This is the step response. This is the time domain response. They have given me the time domain response, and they are asking me regarding the information of frequency response. Okay, two things are different over here. Omega r, if you have studied control system, you'll know what is your omega r. Omega r is basically the resonant frequency of a standard second order system, and for a standard second order system, the resonant frequency formula was omega n into 1 minus under root 2 zeta square. This formula is valid only if your zeta is less than 0.707, otherwise your system will never exhibit a peak. If you remember, the frequency response, your frequency response was something like this, right? It used to exhibit a peak and then it used to go down, something like this. This was the frequency response of a standard second order system. Okay, I'm not drawing it like I am not drawing the exact frequency response, but somewhere you will get a peak, right? And that is called as the resonant peak. That is called as the resonance frequency, where the gain of the transfer function is maximum. So that is equals to omega n into 1 minus 2 zeta whole square, right? Of course, this formula is only valid if my zeta is less than 0.707. So of course, the system has to be underdamped. So zeta will be greater than 0 and zeta must be less than 0.707, then only this formula is valid. Now what was the value of the peak resonant frequency, right? Peak resonance, basically at that particular frequency, what is the magnitude or gain of the transfer function? So gain of the transfer function, peak resonant frequency, is basically the DC gain of the transfer function upon what? Upon the sine 2 theta. What is the theta? Like these formulas are derived in the exam hall, you will have to use the formula. You don't have any other option, right? So KDC upon sine 2 theta. So how do I find out 2 theta, right? So basically we know our cos theta is equals to zeta. All these things I have covered in RPYQ series, so make sure you watch the RPYQ video, time response, there I have covered this. So cos theta is equals to zeta. Cos theta is equals to zeta. So from here you can actually put the values, right? And of course you have to make sure that your zeta must be less than 7.707. Basically your theta must be less than 45 degrees. So not less than, theta must be greater than 45 degrees. If zeta has to be less than this, theta has to be greater, because cos theta is equals to zeta. So all these relations are there. So this is the thing. We have to compute the DC gain of the transfer function. We have to compute the value of zeta, and we will need the value of omega n. These are the three data points that I need, and I have only been given a single graph, right? In a graph, I see a lot of things that are given, right? First of all, this graph is the response of a unit step, and I see the steady state also is 1. And do you know what is the DC gain of the transfer function? DC gain of the system. So DC gain of the system actually is equals to the steady state output, basically C of infinity upon R of infinity, right? In time domain, in frequency domain, it is basically C of 0 upon R of 0. So we know that S equal to 0 in frequency domain is T equals to infinity in time domain. That is how we compute the final value theorem, if you remember it, right? Final value theorem. So if I want to find out the value at T equals to infinity, we put S equal to 0, right? That is a relation. That is how you can remember it, right? This is a very, very important thing, that if you want to find out the DC gain of a transfer function, all you need to see is the gain at infinity, right? So what is R of infinity? R of infinity is the input, right? It is a unit step. So U of infinity is 1. And what is C of infinity? C of infinity, we see that it is settling at 1 only. So this is also 1. So the DC gain or KDC of the transfer function is 1. So DC gain is 1. So my peak resonant would be 1 by sine 2 theta. Now I see that it is reaching peak at t equals to 0.2 seconds, and also I know the value of peak, right? 1.12. So if you remember this thing, that the peak resonant frequency, sorry, the maximum peak overshoot MPO is equals to e raised to power minus pi cot theta. Very, very important formula. Again, I have told you in the RPO echo series how to remember these things. So this is the maximum peak overshoot formula. And do you know what is maximum peak overshoot? It is nothing but the peak value of the output minus the steady state value of the output upon the steady state value, right? It is the normalized value, right? Normalized peak value basically. So C of peak is 1.12 minus 1 divided by 1, that is 0.12, right? And this is equals to e raised to power minus pi cot theta. So minus pi cot theta, from here I will get the value of cot theta, and from there I can get the value of zeta. So let me do the calculations. So 0.12 ln, then divide by pi, then I will take the inverse, and that will give me tan theta. Then I will take the tan inverse, that will give me the value of theta. So theta is equals to 56 degrees approximately. Now what is cos theta? Cos theta would be, that is zeta. Zeta is equals to 0.56. That is my zeta. I got my zeta, which is certainly less than 7, which is certainly less than 0.707. So we are safe in that particular aspect, right? That yes, these are proper values. I will be able to compute omega r and mr. So what is omega r? What is omega r? For that I need the value of omega n as well. I know the value of zeta, so I will be able to easily compute this mr. So mr, if I compute, because I know theta is 56 degrees, so it will be 1 upon sine of 2 theta. So cos inverse into 2 into sine of this comes out to be 0.927. So this will be equals to 1.0 1.0 8 mr. So mr is equals to 1.08. Now what about your yeah, so you will see in the options there are two options, right? Option B and option D. Both of them has mr to be equals to 1.08. I was not able to copy the options, but you will see in the options there are two things, option B and option D. Which one will you choose? For that you will need to calculate omega r. So for that I will need the value of omega n, right? How do I compute omega n? So this information is also given to you. This is called what? This is the peak time. So basically what happens, your peak time is periodic. So this again I have derived in my RPYQ, that your peak time will occur in this range 2n plus 1 divided by omega. So let me put this below, divided by omega d. So divide by yeah, pi by omega d. So basically the first peak will occur when at n equals to 0. This is the first peak, right? The second peak will occur 3 pi by omega d here. This is my 3 pi by omega d. So if this is 0.2, then this point certainly will be 0.6. Otherwise this will not be a proper graph. And then the next peak will occur 5 times this, that is at 1 second, right? And this will go on. This will go on, right? Obviously, like after 4 tau you will settle, your system will settle almost around the 98% error band, so 2% error band, sorry. So you will not be able to observe it, but that's how the peak time, that's how you compute the peak time. But what we are interested in, we are only interested in the first peak. So when n is equals to 0, if n is equals to 0, this will be pi upon omega d. So pi upon omega d value is actually given to us, that is the first peak, that is 0.2. So your omega d is equals to 5. I know my omega d, I know my theta. One more thing that you know, what do you know? That your omega d is equals to omega n sine of theta. So your omega n would be equals to what? It would be equals to, what is omega d? Omega d is 5 pi divided by sine of theta. So theta is 56 degrees, sine of this. So that would be 18.95 approximately, right? 18.9596 approximately, 18.95 radian per second. And one of the options would be 18.95, the option D, and which will not be absolutely your correct answer, right? Because this is the natural frequency of oscillation. This is not the resonant frequency, the frequency at which the peak occurs. This is not that frequency. So resonant frequency, again we have discussed the formula, it is omega n into 1 by 2 zeta square. So natural frequency is 18 point this, so zeta is 0.56, right? 0.56 whole square into 2 minus this plus under root into omega n. Omega n is 18.94 and something. So which is, okay, sorry, I believe 19.94, sorry, which is 11.56. Okay, almost 11.58, 11.56 radian per second. Right, approximately your options will be matching almost. Option B will certainly match. Right, how you can quickly solve it? So there is no shortcut here. One thing is that once you calculate omega n, then you are certain that your omega r will be less than omega n. That is certain, right? That is certain, because the maximum value of zeta, what is the maximum value of zeta? It is 1 by root 2, right? So this value can be 0 and the minimum value of zeta is 0, right? Okay, minimum value is 0, so okay, sorry, it can be equals to omega n as well, right? So either your range will be omega r will lie between 0 to omega n, and you see in the options certainly it is not omega n, because it will be equals to omega n when my zeta is 0. So zeta is certainly not 0, non-zero, we have computed. So basically it will lie between omega n and 0, and that particular case condition is only present in option 2. So it is not present in any other option, right? So option B would be your correct answer for this particular question. The lag compensator shown in figure B is obtained by multiplying the transfer function of the lead compensator as shown in figure A by a rational function x of s, right? We are multiplying this and we are getting this lag compensator, sorry. What is asking? So like assume that the figure A output is sensed at 2. So whatever transfer function they are talking about for figure A, it is this, right? V over Vi. And then they are multiplying this transfer function with this x of s and we're obtaining the new transfer function. Okay. And the output sensed for figure B is here, right? Series combination of 2 ohm resistor and 1.5 farad capacitor. Determine the magnitude of x of s at s equal to 2, right? So simply we have to compute the x of s. So what they're telling me that whatever is this transfer function, let's say the transfer function of figure A is TA of s. I'm multiplying this with x of s and I'm getting TB. That is what they're telling me. That's the simple thing that they're telling me through the question. So yeah, we can do that. So what is TA? And I will prove it to you. Is it a lead compensator or a lag compensator? So TA, let me first compute TA of s. So what is TA of s? So TA of s, this would be V over Vi in this particular figure, right? In this particular figure. So V over Vi, not that simple. Let me first of all write what is, let me assume this particular part to be Z1 and this particular part is Z2, that is 2 ohm, that is understood. But let me first, so what will be your TA? TA would be simply V of s upon Vi of s, right? This would be equals to what? This would be equals to simple voltage division rule, Z2 upon Z1 plus Z2. So Z2 is what? This Z2 is 2 divided by Z1 plus Z2. So what is Z1? Z1 is 1 by Cs into 2, right? Or like basically 1 by SC. C is 1 divided by 2 by S. Sorry, 1 by S plus 2, right? Yes. So this would be 2 divided by 1 plus 2s. 2 divided by 1 plus 2s, right? So 2 divided by 1 plus 2s, that is my Z1, right? So this will be 2 divided by 1 plus 2s plus 2. So 2 can be taken out of the picture. This will be 1 plus 2s divided by 1 plus, so 2 into 1 plus 2s, 1 plus s basically. So this is the transfer function of figure A. So in the figure A, if I draw the pole 0 diagram, so 0 is at s equals to minus half and pole is at s equals to minus 1. So 0 is more nearer to the origin, right? So it is a 0 dominating system. So figure A must be a lead compensator, as they have mentioned here as well, right? Figure A is a lead compensator, right? Because 0 dominating system, so 0 dominating systems are lead compensators. So just I'm showing you, yes, it is a lead compensator. That is correct. Now what about the transfer function B, TB? TB is simply a lag compensator, right? So let me again find out the transfer function here, TB. Again, this again let us assume this is some Z1, or let me assume this is some Z2 and this is Z1. So TB would be again very simple, VO of S over Vi of S, that is Z2 over Z1 plus Z2. So this would be equals to okay. So what is my Z2? Z2 is what? Z2 is what? Z2 is what? So Z2 is this, right? Series combination of 2 ohm and 1.5 farad capacitor, that is nothing but 1 by Cs, that is 1.5s plus 2. As simple as that, right? Simple series combination of 2 ohm and 1.5 farad capacitor, and this will be 1 divided by 1.5 is plus 2. This is my Z1, sorry, Z2, and Z1 is simply 2 ohms. Z1 is simply 2 ohms, right? Okay. So this, if we multiply 1.5s, I have to multiply, right? So this will be 1 plus 3s divided by 4 into 1.5, that is 6s, right? Plus 1. Okay. Now what is the pole 0 here? So I have a pole at s equals to minus 1 by 6, and I have a 0 at s equals to minus 1 by 3. So this time you observe that the pole is nearer to the origin, so it has to be a lag compensator because it is a pole dominating system. That's why it is a lag compensator. So what is my x of s? X of s is this, right? X of s from this equation, it would be what? TB of s upon TA of s. So TB of s upon TA of s. So this will be 1 plus 3s divided by 1 plus 6s, that is my x of s, into TA of s, like 1 by TA of s, that is basically 2 into 1 plus s divided by 1 plus 2s. Now what are they asking? They are simply asking the value of x of s, magnitude of x of s at s equals to 2. So let me put here s equal to 2. This will be 1 plus 6 upon 1 plus 12 into 2 into 3 upon 1 plus 6, right? So this will be simply cancelled. Sorry, this will be 2, 1 plus 4. So things will not be cancelled. So let me compute this value, that is 7 by 13 into 6 upon 5. So that comes out to be 0.646. So 0.646, this will be your answer for the question. Consider the analytic function fz equals to this of the complex variable this. Find the derivative of f dash of z. So if it is analytic, right? So we know if it is analytic, if I am able to write my function fz in terms of z, so, right? So its derivative I can directly do if I differentiate with respect to z, if it is analytic. Or simply also you can take the derivative with respect to z, that also you can do. Yeah, that also you can do, but yeah, this is the best way to go about it, right? If I take the derivative with respect to z. So let me first write this function in terms of z. Can I write this function in terms of z? So it is x square plus y square plus I to xy. So I see some hints here, right? So what is this? This is nothing but 2 into z, right? It is nothing but 2 into z. This is something else, I don't know what is this. This is simply z, right? And this is z bar, that is z conjugate. Okay. So if my function is 2 into, like if the derivative is 2 into z, what will be the actual fz? Simply integrate, because it is analytic, I can simply integrate with respect to z, that will be z square, right? That would be z square. So let me calculate what is z square in terms of x and y. So in terms of x and y, z square would be x plus iy whole square, that is x square plus I square y square plus 2i xy. So this would be x square minus y square plus 2i xy, right? So x square minus y square plus 2i xy. So I see exactly it is the function, whatever they have told me, right? So certainly this will be the derivative of my function fz. Now because the function is analytic, we can only solve this by options, okay? And because it is because it is analytic, that's why the differentiation would follow this particular rule, right? So whenever these kinds of hints are given, make sure you use them and check with the help of options. So option A would be your correct answer for this question. If limit as x tends to 0 is minus 1 by 6, then a plus b by c would be equals to what? So simply I can, if limit exists, right, then I can use the L'Hopital's rule. So L'Hopital's rule would say that if I put x equal to 0 here, this is becoming 0 plus b plus c upon 0. So b plus c, sorry, b upon 0, right? If I put x equal to 0 in the numerator, numerator is b, right? And denominator is 0. So b upon 0, limit will exist if and only if b is also 0, then only I will get 0 by 0 from it, then only limit will exist, otherwise limit will not exist. Okay, so yeah, so b has to be 0, that is for certain. B is gone. So if b is 0, now my limit converts into this a sin x plus cx upon x cube limit as x tends to 0. So I can use the L'Hopital's rule, so I can differentiate the numerator and the denominator. So that would be equals to a cos x plus c upon 3x square. Okay, so yeah, now if I put x equal to 0, this would be a plus c upon 0 again. So again a plus c has to be 0, otherwise limit will not exist, right? So a will be equals to minus of c. A would be equals to minus of c. So I don't even need to solve further. You can solve further, but you don't need to solve further, right? I can simply simplify. So a is minus c, b is 0 upon c. So this will come out to be minus of 1. So minus 1 will be your answer for the question. Of course, you can solve, like you can find out the exact values of a and c, but that is not required for this question. Okay, so minus 1 will be your answer for the question. An 8-bit unipolar digital to analog converter DAC has the voltage range to be this. For a digital word input, this, right, where the leftmost bit is the most significant bit, determine the corresponding analog output voltage. So it's very simple, it is 8-bit, right? So if it's 8-bit, what is the resolution? Resolution is simply the range, that is 7.68 minus 0 upon the range of the digital, right? That is 2 raised to power n, that is 8 minus 1. Correct, it is 8-bit, so range would be 2 raised to power 8 minus 1. Now this is a step size, right? So they are telling me for this particular input. Okay, so what is this? This is basically 1 2 3 4 5 6 7 8. So this is actually 2 raised to power 7 plus 2 raised to power, so be 1 0 1 2 3 4. So 2 raised to power 4 plus 2 raised to power 2 plus 2 raised to power 1. So yeah, we can solve this, should not be that difficult. This would be 2 raised to power 7 is 2 raised to power 7 plus 16 plus 4 plus 2 into 7.68 divided by 2 raised to power 8. So 2 raised to power 8 would be 255. So that is 4.517. So they are asking me to round off to 1 decimal places, so that will be 4.5 volts. Okay, so 4.5 volts would be your answer for this question. In the circuit shown, the clock input has frequency f0 and a duty cycle of 25%. Right, so it has a duty cycle of 25%, this clock. So they're asking me for the signal observed at Q, output of the flip flop, which of the following statements is correct. Actually, they should have mentioned assume the initial value of Q to be 0. That I will mention in the question. Assume the initial value of Q to be 0. So it is a 2-bit binary counter. So what happens in a 2-bit binary counter? So in the first, so this is like a edge triggered. So in the first T clock, right, the 2-bit binary counter will be simply 0 0, and we are taking the LSB, right? If you see, we are taking the LSB. Okay, so here also again we are assuming that the count is starting from 0 0, but even if you don't assume, right, if you assume that it is starting from 1 1, your result will be same because this waveform will be periodic. So although it does not matter, but it's safe to assume with the initial state 0 0. So after the first T clock comes, the output changes to 0 1. Before that it is 0 0. So if it is 0, right, JK is shorted, that is 0, and when JK is shorted and it is set to 0, it is nothing but memory, right? And memory, we are telling you initial value was 0, so it will remain at 0, it will not change. Correct. So in the first clock, right, so first clock pulse, before the first clock pulse, outputs were 0 0, so nothing happens. Correct. So my output Q, so this is my clock, right, and the duty cycle of the clock is 25%. So the time for which the clock will remain high will be much lower than it remains low, right? So let me show it properly. This will be the duty cycle of the clock. So during the first positive edge, because it is a positive edge triggered, because there is no circle drawn, the Q, right, before the first clock edge, the Q would be 0. Now just after the first clock edge, what will happen? Just at the clock edge, the LSB will change to 1. As soon as it changes to 1, what will happen? This will toggle, right? So before it was 0, it will toggle. So your Q also will toggle here, right? Because J, K both are 1, and we know if J, K both are 1, output will toggle, right? Nothing happens here. And then again we wait for the next clock edge. So this particular transaction is 1 T clock, 1 clock period. In the next clock edge, what will happen? Your counter will now go from 0 1 to 1 0, right? So your LSB will be 0 now. This is the LSB, this is the MSB, correct? So if LSB is 0, nothing will happen, right? JK both are 0, it will be memory, so it will hold its value. Now again next clock will come, correct? As soon as the next clock comes, your LSB again becomes 1. As soon as it becomes 1, then again this will toggle, right? Your Q will toggle. And again the next clock will come. If the next clock comes, what will happen? I will again restart, because it is a 2-bit binary counter. So 1 1, again it will go to 0 0, which is again a memory state. So essentially what is happening, right? At every clock pulse, once we will toggle, once we will store the data. So essentially our period is actually 2T clock. If you see at this edge, right, again we will toggle. So essentially if you see, this will be, this whole thing, right, will be 2T clock. Hold on a second. This is 1T clock. Let me mark it like this. This will be the best way to mark 1T clock. Yeah, actually no, this will, okay, this will not be 2T clock, right? So this is happening at after 1T clock, we hold the state. Then in the next T clock we toggle, and again in the next T clock what happens? We toggle again. In the next T clock I will hold the state, right? And again in the next T clock finally I will toggle again, right? So basically I'm toggling, then I'm holding in the next period, then I'm toggling, and then I'm holding in the next period, right? So overall this is a 4T clock, 4T clock. That is the period of my Q, right? What is the duty cycle? Duty cycle is 50%. So for 50% of the time you see it is 0, for 50% of the time it is 1, right? So duty cycle is 50%, and the period is 4T clock, that is 1 by 4T clock, right? And 1 by T clock, 1 by T clock is given as F0, right? F0 is given, that is the clock input. So it is essentially F0 by 4. So your output frequency would be F0 by 4, and your duty cycle would be 50%. So option A will be your answer for this question. A wattmeter's current coil is connected in series with an ammeter and an inductive load. So it's an inductive load that is connected, right? And a current coil of the wattmeter is connected in series with the ammeter, and a voltmeter and the wattmeter's potential coil are connected in series. So the potential coil and the voltmeter, are connected in parallel with each other. Now what they're telling me, the readings from the instruments are as follows. Assuming the voltage drops across the ammeter and the current coil are negligible, if the power factor of the load is X, what is the value of 100 times X? So we know the reading of the wattmeter is VI cos phi, right? So I know what is the reading of the wattmeter, that is 15 watt. I know what is the voltage, that is certainly 120 volts, and I know the current. Current is simply 5 amperes. So the power factor of the load would be this cos phi. This will be 3 by 120, that is 1 by 40, right? So this is the power factor, and this is my X. They are asking me what is 100 times X. So this would be equals to simply 2.5. So 2.5 would be your answer of the question.
Yeah, so let's solve this one. What we are doing here, this is the Fourier series coefficient of a time domain signal is shown here, and you need to, and fundamental frequency is pi, you need to find out the signal, right? So these are the values. C1 value is mentioned, C2 value is mentioned, C3 value is mentioned. So what is your xt, xt is nothing but c of minus 3 e to the power, c of minus 3 is 3, e to the power minus 3, e to the power minus j 3 omega naught t. Omega naught is pi only, which I will put later on. Then 2 e to the power minus j 2 omega naught t plus 1 e to the power minus j omega naught t plus e to the power j omega naught t plus 2 e to the power j 2 omega naught t plus 3 e to the power j 3 omega naught t. Now you see this guy and this guy. So 3 e to the power minus j 3 omega naught t, 3 omega naught t plus 3 e to the power 3 j omega naught t. So 3 you take common, e to the power minus j 3 omega naught t plus e to the power j 3 omega naught t divided by 2 multiply with 2. Okay, so this will become 6. So this particular term is giving you 6 cos 3 omega naught t. So what you are getting, 6 cos 3 omega naught t plus here you will get 4 cos 2 omega naught t plus 2 cos omega naught t. Omega naught value is pi, so this will be the answer. Other ways are also there. This is even, so here even function should be possible. So this is not possible, it is not even. This is also not even, this is also not possible. Then summation of x of k, what it will give you, k going from minus infinity to infinity. What it will give you? It will give you the value of xt at t equals to 0, right? Xt at t equals to 0. So at t equals to 0, here value you are getting 3 plus 2, 6 value you are getting. But what is the total summation? 3 plus 2 plus 1, 6 into 6, 12. So 12 should be equals to x of 0. So in which of the option it is matching? In this option it is matching. So option is 4. Okay. Very simple question. Let's go to the next one.
A moving coil ammeter has an internal coil resistance of 1 kilo ohm and gives full scale deflection when a potential difference of 500 millivolt is applied across the coil. Right. So basically, its internal resistance is 1k, and obviously it gives full scale deflection when a 500 millivolt is applied. So with this, I will be able to calculate what is my full scale current. Full scale current would be 500 millivolt upon 1000. So this will be 0.5 milliamperes. Now they want to extend the range of the ammeter to 1 milliampere. What shall be the shunt resistance that shall be connected, RSH, right? So again, we know that the voltage, maximum voltage that I can apply is 500 millivolts, and this is 1 kilo ohm, and the current that my meter can take is 0.5 milliamperes, and I want to extend the range to 1 milliampere. So the remaining 0.5 milliamperes must flow through the shunt resistor. So if I know the current through the shunt resistor, if I know the voltage across the shunt resistor, then certainly I know the shunt resistance. So it will be 500 millivolt voltage divided by the current, that is 0.5 milliamperes, milli, everything is in milli, right? Millivolt, milliamperes. So this will be 1000 ohms. Okay. So 1000 ohms will be the correct answer of this question, right? 1000 ohms would be the correct answer of this question. So yeah, 1000 will be the answer of this question. Determine the electric flux density vector d2 in the region 2, given that the electric field in the region 1 is this, the relative permittivity of the regions 1 and 2 are this. Okay, these are the relative permittivities, and they're asking the interface is at z equal to 0. Now all they're asking is what is the electric flux density in the region 2. So we know that if I have region here, right? If I have a region here, we know the tangential components are same. So basically ET in the region 2 and ET in the region 1 will be same. The normal components, right? The normal components are related like this. So simply their electric flux densities of the normal components are same. Okay, electric flux density of the normal component would be same. So what about their electric field intensities? So their electric field intensities will be actually different. So yeah, electric field intensity En1, this will be epsilon 1 will be equals to epsilon 2 into En2. That's it, right? That's how they are related. These are the boundary conditions. This already has been taught to you in the full course, in the video itself. One video is there, that is the boundary conditions video, right? So here, if I relate this, So their tangential components are same. So if my plane is z equal to 0 plane, right? So what are my tangential components? Obviously whatever components are in the ax cap and ay cap direction, those will be same. So your ax cap and ay cap directions, these will be same, right? Yeah, so electric field intensity, here I have to compute the flux density, not the field intensity, right? So let me first of all form the electric field intensity, then I will obviously write the electric flux density. So this will be equals to 50 into ax minus 30 into ay. Okay, so one should be plus, one should be negative. If I see, right, one should be plus, one should be negative. This is both plus, not possible, right? Not possible. Like electric flux density and electric field intensity will be proportional to by a constant scalar, will be proportional by a constant scalar. So the signs will not change. The signs whatever I have here, they will be same, right? Because the scalar is simply epsilon, correct? So I see this is possible, this is certainly possible, this is also certainly possible, right? Okay. Let me compute the normal component. So normal component will be related like this. So what is the normal component here? That is 90. What is the normal component in the en2? That is en2, that will be equals to epsilon 1. What is epsilon 1? So region 1 is this, the relative permittivity of region 1 is 3, the relative permittivity of region 2, that is epsilon 2, is 4. Yeah, both will be multiplied by epsilon naught, but that will be cancelled, so that is fine, into obviously the electric field intensity in the region 1, right? So this will be 4 will be divided, that will be equals to 22.5. So 90 upon, so 90 upon 4 into 3, that is 67.5. Okay, this is in the voltmeter. So your electric field intensity in the region 2 would obviously will have the same sign, because this is just a scalar, will be 67.5 az cap volt per meter. So let me now certainly convert this into flux density. So how to convert this into flux density? Simply multiply this by epsilon naught, right? If I multiply this by epsilon naught, I will get this into flux density, right? So that would be equals to uh, yeah, what is epsilon naught? Epsilon naught, if you remember, it was 8.854 into 10 raised to the power of minus 12 farad per meter. So this will be, so I see these components are same everywhere, right? I see these components are same. Oh, what is different? So this is 1.06, this is different here, certainly. Okay, I see these two options are same. So yeah, there will be some discrepancy here. We need to change the options, because I see these two options are same. So yeah, I will certainly change these options, so we will see, but I think this is the answer basically, so we will compute that. So certainly if you scale, I don't need to compute the ax and ay component. All I need to do is compute the z cap component, right? So z cap component would be 67.5 into 8.854 into 10 raised to the power of minus 12 farad will be multiplied with volt. This will become coulomb per meter square. Okay, good. The difference is here the unit is meter, that is the difference, right? The unit is meter. So certainly you have to take care of the unit as well, right? So here the unit is meter, here the unit is meter square, so it will be meter square basically. Why it will be meter square? So you're multiplying volt into capacitance. So c into v, c into v has a unit of what? Q equals to cv, it has a unit of charge, that is coulomb. So you're doing multiplying by farad, and obviously the denominator is also getting multiplied by meter. Here already I have a meter, and again I'm multiplying, so it will be meter square, it will not be meter. Okay, so be very careful of the dimensions. So yeah, certainly then of course this will be the correct answer. Okay, we'll see. Okay, sorry, either this or this can be the correct answer, right? Because here the dimension itself is incorrect. So let me compute this. I have to compute in nanofarad, so I can take 10 raised to the power minus 9 in common. So if I take 10 raised to the power minus 9 in common, this will be 8.854, yeah, into 10 raised to the power of hold on a second, divided by 10 raised to the power, this comes out to be 67.5. Oh, don't just multiply by epsilon naught, you are forgetting we have to we have to multiply basically by epsilon, right? So your E2 would, D2 would be simply epsilon 2 into E2. So that is epsilon 2 is epsilon R1, epsilon R2 into epsilon naught. So epsilon R2 is actually 4. So don't forget there is a 4 as well, right? Don't forget to multiply by 4. So we'll have to multiply by 4 as well. So 67.5 into 4 into 8.854, yeah, into 10 raised to the power of minus 3, that is 2.4, approximately 2.39. So 2.39 coulomb per meter square, nano coulomb per meter square, because I have taken it as common, which is present I see in this option, right? So option C will be correct. You can verify the other components as well, these values will come up. Okay, so option C will be the correct answer for this question. The following expression represents a magnetic field intensity in free space, expressed in the spherical coordinate system, right, where AR and A theta cap denote the unit vectors along the radial and the polar theta directions. Okay, assuming theta is this, right? Theta is the angle from the z axis. Assuming that the given field is physically valid field in free space, determine the value of the constant T. So we know if the field is valid, right? So we know the divergence of any magnetic field will be always 0, because any magnetic field is solenoidal, correct? Any magnetic field is always solenoidal. So in this case, we know that basically, right, or magnetic field flux density will be equals to mu into H. So it is just a constant. So this will be replaced, this equation can be replaced as del dot H will be equals to 0. Same thing, right? Because it is just proportional with a constant. So now what we can do is we can compute the divergence of my magnetic field intensity. But to compute divergence, I have to compute in the spherical coordinate system, and this exact concept I have taught in the RPYQ series, where I have told you how can you remember the table. How can you remember the table? So what is the table? Table will have three constants H1, H2, H3. I have told this in RPYQ how to remember. So R, theta, phi. You just watch the RPYQ video AIMFT part. Okay, AIMFT measurements part. In the AIMFT part, there I have explained this solution. So this will be H1, H2, H3 constants. So H1, the differential length is dr, so it will be 1. Here the differential length is r d theta, so this will be r actually, I will divide it by d theta, and here the differential length would be r sine theta d phi, so this will be actually r sine theta, right? And your divergence del dot h would simply be equals to 1 by h1 h2 h3, that is r square sine theta into del r, because I have ar cap here, into H2 into H3, the other two components, right? Other two components, that is r square into sine theta into obviously the whatever is the component that is present here, because minus 2 is common, right? That can be vanished. Minus 2 will be totally gone. I don't need to consider the minus 2. Okay, I can take less stress regarding the minus 2. This will be P cos theta, that is the component in the r cap direction, right? Just give me 1 second. Let me keep it here. Yeah, this will be the component in the r cap direction. Now I have theta cap component, right? So in the theta cap, I will multiply h1 and h3. So del theta into h1 into h3, that is h3 is r sine theta. h1 into h3 is r sine theta into obviously the a theta cap direction component, that is 4 sine theta, right? Four sine theta. So yeah, if I differentiate this with respect to r, right, this will be 2r. So because this is equals to 0, right, so this, all this does not matter, this will be vanished, because this is equal to 0, this will be vanished, and this will be equals to 2r Sine theta, basically 2 into P into R sine theta cos theta, plus this will be, I'm differentiating with respect to theta. This is actually 4r, 4r can be outside, and sin square theta differentiation would be 2 sin theta into cos theta. This is equals to 0, right? So as it is equal to 0, this is already gone. So this is also gone. Sin theta cos theta is also gone. 2 sin theta cos theta is also gone. R is also gone. So essentially your P is equals to minus 4. So if this equation has to be 0, right, your P has to be minus 4. Otherwise these things will not be cancelled. So the answer of this question would be minus 4. Find the power delivered in watts to 20 ohms resistor connected across port 2 if Z parameters of the network is given. Right, so basically the Z parameters of the network is given, and in the port 2 20 ohm resistor is connected, and they are just simply asking me what is the power delivered to this particular 20 ohm resistor. So simply what are they asking? They are asking me P, that is equals to 20 into I2 square. Now here remember, what is the direction of current? I don't know. So here they are telling me the direction of current is this, right? This is the direction of current, right? I2. So this will be plus minus, because current always enters the positive terminal for a resistor. Current always enters the positive terminal for a resistor, right? Because resistor can only absorb power, it can never deliver power. Great. So for that I need to calculate I2. So let's do that. So they have given me the Z parameters. So Z parameters are nothing but the like voltage equation. So V1 will be equals to Z11 into I1, that is 40 into I1 plus 60 into I2, and V2 would be 80 into I1 plus 100 into I2. Okay, that is your V1 and V2. Now okay, that is my V1 and V2. Now few more things, right? If I write the KVL equation at the output side, what is the KVL equation in the output side? So this will be minus, I use my KVL equation, you can use your own convention, right? Minus of V2. Then again I observe a negative sign, right? This is a negative sign. So when I rotate in the clockwise direction, whichever sign I observe first, that I write. So minus V2, again I observe a negative sign. So minus into 20 into I2. Correct? So because this is my I2 current direction. So this I2 current direction is with accordance to my port parameters. If you remember, the port currents are always entering into the port. So this will be equals to 0. So from here I get the value V2 is equals to minus 20 I2. You don't need to use that much of brain. Anyways, you can see, right? This is plus minus and this is just opposite. So anyways, it will be negative. But if you want to understand it properly without any confusion, yes, write the KVL equation. So V2 is equals to minus 20 I2. And what about the input side? If I write the KVL equation in the input side, so this is the direction of current in the input side. So this will be plus minus 10 I1. So this will be minus 20 plus 10 I1 plus V1 equal to 0. So V1 equals to 20 minus 10 I1. That is my V1 value. V1, V2 I got. So simply I can use it, right? Because ultimately I need to find out the value of I2. For finding out the value of I2, I need to replace these equations. I will be able to calculate that. So it's just simple equation manipulation. That's it. Here, if I see some things, okay, yeah. So let me first replace this part. Let me replace here. So that would be minus 20 I2 equals to this, and so basically, right, this will be basically minus 120 I2 equals to 80 I1. So from here my I2 value is actually equals to minus 2 by 3 I1, correct? Okay, so this can be again I can replace the V1 here. This would be 20 minus 10 I1 equals to 40 into I1, and your I2 is equals to minus 2 by 3 of I1. So this will be 60 into minus 2 by 3, that is, so 20 into 2 I1. So from here this will go down to 0. So I1 would be equals to 2 amperes. This will be the answer. I1 is equals to 2 ampere. This is the answer for your question, right? So I1 is 2 amperes. What is I2? So I2 is minus 2 by 3 into 2, that is minus 4 by 3 amperes. That is your I2 current, right? I1 is 2 amperes, I2 is minus 4 by 3 amperes. Got it? I1, I2. So we know I2 value, right? It is negative. What does negative means? Basically, if it is negative, that basically means your initially assumed direction of current is wrong. Actual direction of current is this. In our case, it does not matter because we are doing I2 square. Got it? If they would have asked some other parameter which involves the sign, then things would have changed. In our case, it is very simple. All we need to do is 20 into I2 whole square, that is minus 4 by 3 whole square. So if I calculate this value, that is 1.77 into 20, that is 35.55 watt. This is the I2, so this is the power delivered to the 20 ohm resistor. This is your answer for the question.
Input output relation is given. This is output, this is input. Like here I am representing my Rn, Cn. You are more comfortable with Yn, right? Yn equals to minus 1 by 3 x of n minus 2 plus x of n plus 3x of n plus 2. Now in these kind of questions, what you should check first? Always you should check first LTI, because that is very easy as well. We have studied LTI system in a great manner. So first we should always check LTI. And if you have got that, yes sir, it is LTI, then for LTI system you have the techniques, no? For LTI system, what do you know? That sir, if you want it to be stable, that means impulse response has to be, you can find out its impulse response, no? Right? If it is LTI, then I can find out its impulse response. Now, regarding the impulse response, I know everything. What do I know? That sir, if it wants to be stable, if it wants to be Bibo stable, that means its ROC should include Z equals to 1 circle. If it wants to be causal, that also I can check, right? LTI is already there. Stability, how will I check the stability? It should be absolutely integrable. In that manner I can check. So basically, if it is LTI, then your question would become easy. So first I will check it is LTI. Yes sir, it is LTI. Non-causal, it is directly visible that it is non-causal. It is depending on the future value. So it is non-causal. That is directly visible. But let's find it out in some other way. Let's find out h of z. So what will be your h of z? Y of z would be nothing but z to the power minus 2 x of z plus 3 z to the power 2 x of z. So y of z divided by x of z, what you will be getting? H of z. What that would be? Minus 1 by 3 z square plus 1 plus 3z square. From here I can sense that there are only two poles, which is at 0 and infinity. If there are only two poles, one is at 0, other one is at infinity. What does that mean? There is only one possible ROC, which will be this one. So this ROC is bounded by two poles. What does that mean? It has to be non-causal. If it is non-causal, that means it is having memory, so there is no chance that it will be memoryless. Now if this is the ROC, that means z equals to 1 circle will be somewhere here. So the ROC is including z equals to 1 circle, that means it will be stable as well. There you go. That's it. So always first check about LTI. If LTI is there, then my job would be very easy for me. I would be able to get h of z, and from there I can conclude everything. Is that understandable to you or not? Surely it is understandable. Okay, then let's go to the next one.
For a 3-phase 4-pole 50 Hz induction motor, the starting MMF wave includes fifth, seventh space harmonics. Remember, it is given space harmonics components. Like it is talking about the flux harmonics in the wave. Okay, MMF wave. Okay, in the space wave. What are the respective synchronous speeds in RPM of the rotating magnetic field produced by these components? So basically, this has been taught in this particular lecture. You can go into this lecture. Here I have exactly derived what will happen to the third harmonic, fifth harmonic. Sorry, will the third harmonics be present? Will fifth harmonic be present? Will seventh harmonics be present? All these things have been taught. So whenever there are space harmonics, right, you will get two kinds of waves. One will be the forward wave, another one will be the backward wave, right? Where k is integer. So k is positive integer basically. So basically what happens when my harmonic order is 6k minus 1, let's say 5, right? It can be 5, then it can be 11, it can be then 17. Yeah, when it is in the order of 6k minus 1, then the harmonic is backward rotating, right? Because it is negative, so it will be backward rotating. So your speed at which the harmonic will rotate, right, it will be fifth harmonic component. The speed at which it will rotate is basically ns minus of ns divided by 5. Why division by 5? This thing you have to go and see on this lecture. Here I have derived how division by 5 comes up. Okay, so it will be minus ns divided by 5. So it will be negative. Why negative? Because it will be backward rotating. How to remember it? Because this is negative, this also will be negative. So what is ns in this case? So ns would be the synchronous speed, that is 120 into f divided by p. So it is 30, that is 1500, right? So ns is 1500, so ns5 would be minus 300. Why this 5 comes? Actually the number of poles increases. Whenever there are space harmonics, the number of poles increases, that reduces the synchronous speed. So you can go and watch this video, lecture 45 on YouTube, and there the solution is like there the derivation is there. So this will be minus 300, absolutely correct. Fundamental component rotates at 1000, no. Fundamental component rotates at 1500 RPM. Seventh harmonic rotates at this. Let's see what does the seventh harmonic rotates. So seventh harmonic would rotate at ns7 would be equals to ns divided by 7. So it is 1500 divided by 7, right? 1500 divided by 7, that is 214.3 RPM, which is absolutely present in the option C, right? So these two options are correct for this particular question. What will happen if the prime mover of a connected alternator stops supplying mechanical power? So let's say alternator, right, is connected to the infinite bus, and we are delivering some power, right, to the infinite bus. Now suddenly the prime mover that was like like the force that was essential for moving the prime mover has stopped. So basically its input power, right, P in is equals to 0. What will happen? What they are asking me, while the alternator remains linked to the power grid, so synchronism is still maintained and its field excitation is still active. So its field is still active. The alternator will get burned. It will behave as an induction motor, behave as a synchronous motor, it will behave as a synchronous motor. Certainly it will not behave as a induction motor, it will not get burnt, it will certainly behave as a synchronous motor, right? Why? Because the field is still connected, so there will be some, because it is still linked, right? So there is still synchronism maintained, so it will still behave as a synchronous machine, but it will work as a motor, it will take power from the grid. That will happen. But what will be the direction of rotation? Will it rotate in the same direction or will it rotate in the reverse direction? As they have told you that the field current is same, so this direction, field direction is same. Field direction is same, and because it is working in the same supply, the phase sequence of the supply RYB is same, right? And the phase sequence decides the sequence of rotation of magnetic field. That is what my phase sequence detects, right? So if it detects the sequence of rotation of the magnetic field, that basically means that these two things are not changing, and these are the two things that are mostly responsible for the direction of rotation of my motor. Okay, so if these two things were changed, one of the things were changed, then I could have said that it would have rotated in the opposite direction, but this, as this is not changing, so it will rotate in the same direction. Okay, so why it will behave as a synchronous motor? Because the alternator is linked, it is synchronism is still maintained. That's why it will not behave as an induction motor, it will behave as a synchronous motor. Why it will rotate in the same direction? Because the phase sequence of the supply is same and the field current is same in both the conditions, in the previous condition and in the current condition. Why it will work as a motor? Because obviously there is no input power, it is connected to the grid, it will take power from the grid. So option C will be the correct answer for this question. A DC to DC converter operates with a switching period of 0.1 milliseconds. So the switching period of the converter, right, T, switching is 0.1 milliseconds. The inductor current is at the boundary between continuous and discontinuous conduction mode. So basically the inductor current, as you see, it is in the boundary condition, right, between continuous and discontinuous. That basically means the inductor current will be just continuous, that is, it will increase and then it will decrease, and then this will be periodic in nature, right? That will be happening. Okay, determine the ripple in the load current in amperes. What is the ripple in the load current IO, right? So this is the load basically in the load current, that is what they are asking me. Okay, pretty interesting question. So yeah, how do I solve it? So what will be the ripple in the load current? What will be the ripple in the load current? So if we see that what is happening when the chopper is on. So when the chopper is on, the voltage across the inductor is plus 100, right? So when the chopper is on, the voltage across the inductor is plus 100. When the chopper is turned off, what is the voltage across the inductor? It will be the whatever the voltage, like it will basically turn this diode on, and if this diode is on and this inductor is also some current is flowing through the inductor, right? So certainly this diode will be on, because this chopper is off, some current is flowing and that current has to come from the diode itself, so which has to turn this diode on, right, when the chopper is off. That certainly means this diode will be on, and if this diode is on, that means the voltage across the inductor is same as the this voltage, that is minus 500, right? It is, this is my inductor voltage, plus minus, right, it is in the opposite polarity, so it would be minus 500. Okay, keep this in mind, they have not told us what is our duty ratio of the switch. This we can actually compute by this relation. We know the current is just periodic, and if the current is just periodic, we know that the average value of the voltage, inductor voltage, would be 0. This is minus 500. So from this we can actually compute what is the switching period alpha, right? We know the average value of the voltage would be 0. So 100 into alpha t, that is a positive area, would be equals to negative area, that is 500 into 1 minus alpha into t. So from here we can actually get the value of alpha. So this will be alpha is equals to 5 minus 5 alpha, or alpha is equals to 5 by 6, right? That is what my alpha is equals to, right? Now if I check here how to, yeah, I got my alpha, that is fine. How to determine the ripple current? So what will happen is, as the voltage is constant, right, 100 volts, so automatically this current will change. It will go from, ripple would be, it will go from minimum to maximum, right, zero current to the maximum current, right? zero current to maximum current. It will go to Imax. Now, what will be this Imax? We have to compute that, right? We have to compute this Imax current. So we know the voltage across the inductor here is constant. What is the voltage? 100. We can use this equation. What is the equation? VL equals to L DIL by dt. As the voltage is constant, that's why the current is increasing linearly, right? So VL is equals to L DIL by dt. L is given to us, that is 100 microhenry. Let me change this to 100 milli. So 0.1 milli Henry, right? That will be useful to us. So voltage, what is the voltage across the inductor? It is 100. What is the inductance? 0.1 milli into the change in current, right? It is linear. What is the change in current? Imax final minus initial, Im minus 0 divided by the change in the time. What is the change in time here till t on, right? That is basically your alpha into t, your chopper is on, correct? That is the change in time. So it will be alpha into capital T. Alpha is 5 by 6 into capital T. Capital T is in what? Capital T is 0.1 milliseconds. Remember, this also is in 0.1 milli only, right? So 0.1 milli will be cancelled. So basically your Im value would be 5 by 6 of 100. Okay, 5 by 6 of 100. That is 83.33 amperes. Now this will be actually, so what is the ripple in the inductor current? That is uh, delta IL, that is equals to Im minus 0, right? I minimum minus I maximum, that is equals to 83.33 amperes. Now the interesting part here is that your whatever, so what is the current across the capacitor? So we know when this chopper is turned off, when the switch is off, right? So whatever current that is flowing, that will, some of the current will flow through the capacitor and some of the current will flow through the load, that is my 500 volt source, right? Okay, now can you tell me what is the capacitor current? If you see very carefully, this voltage source is always connected across the capacitor. So the voltage across the capacitor is always constant. So VC is always 500. It does not change. No matter what, your voltage will never change. Now if VC is 500, do you know what is the capacitor current? It is C dVC upon dt. Voltage is never changing across the capacitor. So the current across the capacitor will be 0 because it is at steady state. So whatever current that is flowing through the inductor, all of it will flow through the load, that is IL, that is IO only, right? So IL is equals to IO always. It is always the case. So that is what is happening. So whatever is the ripple current in IL, right, the same will be in the output as well. So this current is the ripple current in inductor, that is same for the load as well. So in the load as well, this will be my ripple current. So this will be my answer for the question 83.33 amperes. What is the percentage inductive voltage regulation in a full bridge diode rectifier if the commutation angle uh, caused by the source inductance is 18 degree? Basically they are talking about the delay angle. This should be delay angle, right, due to commutation. So the percentage voltage regulation is given like this, right? This is the percentage voltage regulation due to the inductance. Okay, basically they're asking the voltage, basically essentially they're asking the voltage drop due to the inductance. So this, if you don't know, I have derived all the formulas in the lectures itself, so I will directly use the result. So they are talking about the bridge rectifier, so we will use full bridge rectifier, this result, right, this one. Okay, so the voltage drop due to the source inductance is this is the voltage drop due to the source inductance. So this will be Vm upon pi into cos alpha. In our case, alpha is 0 because it is a diode bridge rectifier. So Vm upon pi 1 minus cos alpha plus mu, and alpha is 0, it is cos 18, right, upon Vm upon pi without, if the diode rectifier was not present, right, it was 2 Vm upon pi, correct, 2 Vm upon pi. This was the voltage. Alpha is 0 into 100 percentage. So our answer would be basically cos 18 plus 1, V upon pi will be cancelled, divide by 2 into 100, right? So it is approximately 2.44 percentage that is present in option A. So option A would be your correct answer for the question. In a power system of n buses, 25 are generator buses, 20 are voltage control buses, and 15 are shunt inductors. So 25 are generator buses, right? So out of this, how many are my PV buses? Because they're telling me out of 25 generator buses, 2 of the generator buses exhibit reactive power divergence. Okay, what is reactive power divergence? I see something they have written here. So assume the behavior of reactive power divergence to be same as load buses. So out of this 25 buses, right, 2 of them, they are behaving as reactive power divergent buses, that is basically same as load buses. So their P and Q will be known, right? And of course one bus is used as a slack bus. So actually PV bus is 22 and one bus is used as a slack bus where the voltage and the angle would be known, that is known as slack bus, right? Okay, good. uh, Now 20 are voltage control bus. In voltage control bus, what do you know? We know the voltage, certainly we know the voltage, and we certainly know the reactive power. These are my voltage controlled buses, right? Okay, that is what we know by voltage control buses, right? So yeah, so this will be 20 20 are voltage control buses and 15 include shunt inductors. Okay, 20 are voltage control buses, right? So 20 are voltage control bus, so this will be 20, right? And what about the other part? The other part is shunt inductors. So I have 15 shunt inductors. So this shunt inductors basically means they are behaving as load bus only. So shunt inductor basically means it is an inductor, it is a fixed inductor bus, so whose reactive power is fixed, and obviously whose active power also will be fixed, right? Because it is just acting as a load. So again, shunt inductor bus for which P and Q are known, so that is 15. Okay, now what do we need to calculate is uh, they have given me for NR method the Jacobian size of the Jacobian matrix is 356 into 356, right? So do you remember what is the size of Jacobian matrix? It is equals to the total number of unknowns in voltage plus total number of unknowns in angle. So of course in a slack bus the voltage and angle both are known. In a PV bus the voltage is known, the angle is not known. So 22. In a reactive power divergence bus, right, PQ is known, so voltage angle both are not known. So this will be actually, okay, this I can multiply by 1, this I can multiply by 2. Here what is known? The voltage is known but the angle is not known. Again I can multiply by 2. Here both the voltage and angle are not known, so this will be multiplied by 2, right? So this will be equals to 22 plus, this will be multiplied by 0, right? 22 plus 4 plus 40 plus 30. Now let's assume there are x number of load buses. So for load buses as well, their voltage and angle both are not known, so it will be x into 2, so it will be plus 2x. This should be equal to the size of the Jacobian, that is 356, right? So from this if I calculate 356 minus 22 minus 4 minus 40 minus 30 divided by 2, which is coming out to be, your x is coming out to be 130, right? I'm solving everything correctly. So you have 22 PV buses, then you have, oh sorry, this will be multiplied by 1. Sorry, your voltage is known here, right? Your voltage is known, your angle is not known. This will be multiplied by 1, sorry about that. So this will be 20, extremely sorry. So this will be 30 plus 20 plus 4 plus 22 plus 356 divided by 2. So your number of load buses comes out to be 140. So 140 will be your answer for the question. two generating stations, station 1 and station 2, are connected by an interconnecting cable. The voltage at both stations are maintained flat to 1 pu. Okay, magnitude is known, and this angle is 0. This is angle delta. The power flows through the cable to balance the load between the stations. As you can see here, it is taking more active power. Reactive power, there is no reactive power flow, because of course the magnitude of voltage is same. Station 1's generator has a maximum real power generation capacity of 20 pu. So this, right, has a real power capacity pg max of 20 pu. Determine the lagging power factor at station 1. What is the lagging power factor at station 1? So how do I compute that? So what is the power that is flowing from station 1 to station 2? How do I compute that? Two generating stations are connected. The voltages are such that both are used to maintain the flat voltage. And so what is the total power demand, active power demand, PG? The total active power demand in the system is 15 plus 25. These are the loads connected, right? So this will be equals to the generated power PG1 plus PG2. Why? Because certainly you can see your lines are all lossless, they are purely inductive. So whatever active power I am generating in the generators, that will be totally supplied by the two generators only. There is no line losses. This is one part. So Pg1 plus Pg2 is equals to 40 pu. Okay. And what about the reactive power? Reactive power Qg1 plus Qg2. Now this will not be same actually, because the line is inductive, right? There will be some reactive power flow. How do I calculate that? Okay, you cannot calculate that. I'm just thinking. So how much is the power flow from bus 1 to bus 2? How do I calculate the power flow from bus 1 to bus 2? Okay. Actually, yeah, I think the question framing is not proper. They should have mentioned that station 1 is generating to its maximum power. Okay, actually both the stations has a maximum power limit of 20. Actually both of them should have a maximum power limit of 20, then only it will be able to deliver. Okay, the framing of the statement here is not proper. Actually what happens is, this should have been mentioned that both station 1 and station 2 has a maximum real power generation capability of 20 pu. If both of them has a maximum generation capability of 20 pu, so both of them will generate 20 pu, right? If both of them generate 20 pu, right, so then what will happen? 15 pu will go to this load, and the remaining 5 pu will go from bus 1 to bus 2, right? Because generator, this can only deliver 20 pu. Okay, so yeah, I forgot to mention that. That should be mentioned in the question. So this I can use the formula, the active power transfer formula. So this will be magnitude of the voltage. So basically magnitude of V1 into magnitude of V2 divided by XS into sine delta equals to the power from bus 1 to 2. So magnitude of voltage 1 into 1 divided by XS. XS is J 0.05 into sine delta equals to P12. P12 is 20. Right, so sine delta would be equals to, this is 1 by 20. This is actually, oh, that's interesting. What is sine delta? So sorry, this is not 20, right? This, the power delivery is 5. We are delivering 5 pu power, not 20, sorry. So 0.05 into 5 sine inverse. So your delta comes out to be 14.47 degrees. So basically they're asking me lagging power factor. If I am able to compute what is the reactive power delivered from bus 1 to bus 2. Do you remember the formula for reactive power? So reactive power from bus 1 to bus 2 is it was basically V1 magnitude of V1 magnitude of V2 by XS into cos delta. It will not be sin delta, into cos delta. Hold on, V1 V2 into cos delta, and it was, yeah, this was opposite, other way around, right? So basically it was magnitude of V1 whole square upon XS minus magnitude of V1 magnitude of V2 divided by XS. This was the formula into cos delta. This was the formula, right? So this will be equals to, this is 1 upon XS, that is 0.05, minus 1 upon XS, that is 0.05, into cos delta, cos 14, right? Cos of 14, this will be 0.96. So this plus 1 divided by 0.05. So Q12 is 0.63 pu, okay, which is actually quite low. So this is the reactive power that is delivered from bus 1 to bus 2, and what is the reactive power that is delivered to this load, that is J5. So what is the reactive power delivered by the generator QG1? So QG1 would be, if I equate the power flows, it will be 5 plus 0.63. So this is equals to, because it is also lagging only, it is delivering lagging reactive power only, so that will be 5.63. okay, so it is 5.63, right? So it is 5.63. so QG1 is this, PG1 is 20 pu, right? This is my PG1. So of course your tan phi G1 would be QG1 upon PG1, so it would be 5.63 upon PG1, that is 20. So tan inverse of this, so that is phi G1 is equals to 15.73 degrees, right? So your phi G1 is 15.73 degrees. They are asking me what is the power factor. So power factor would be cos of this, that is 0. Cos phi G1 would be 0.962. okay, so this will be your answer for the question.
Function f you need to find out. Okay, so what is that? What kind of quad you are getting? One quad I am getting here, and other one I am getting here. That's it. This would be your function f. What that would be? C bar and B bar, plus for this one it is simply A B bar. There you go. So it is A B bar plus B bar C bar. This is your function f. Like within seconds it should be solved. Okay, it should take hardly 1 minute. You should be able to get this question correct. Let's go to the next one.
In the circuit shown, Zener diode has a breakdown voltage of 20 volts. So Zener diode has a breakdown voltage of 20 volts and a maximum allowable Zener current of 60 milliamperes. So maximum Zener current that can flow IZ max is 60 milliamperes. The resistance R1 and RL are as follows. So RL is 1 kilo ohm and R1 is 0.2 kilo ohm. Okay, because currents are in milliampere, so I am writing in kilo. Let the range of input voltage Vi for which the Zener diode remains on be alpha to beta. Then basically what is my beta minus alpha? They're asking me what is the value of beta minus alpha in volts, right? So beta is the higher value, alpha is the lower value. So what is varying? Your input is varying. So if your input, so what is the Zener current? Your IZ would be equals to, when the Zener is on, it will be, I can simply apply a KCL. It will be 20 upon 1 hold on, it will be Vi minus 20 upon 0.2 minus the 1 milliampere that is flowing, so 20 upon 1, right? 20 upon 1 that is flowing through the load resistance. Okay, so only one thing is varying, that is Vi. So when your Vi is maximum, your Iz also will be maximum. When your Vi will be minimum, your Iz also will be minimum. Nothing is mentioned, so Iz minimum would be 0 amperes. Iz minimum would be 0 amperes. Okay, and Iz maximum is mentioned, that is 60. So 60 would be equals to Vi maximum, that is equals to beta maximum value of the voltage, input voltage, by 20 upon 0.2 minus 20. So that will go on that side, this will be 80 into 0.2, that is 16 equals to beta minus 20. So beta is equals to 36. So 36 volts is the higher voltage. What about the lower side? So when Vi will be minimum, Iz will be 0, Iz minimum. So Vi is Vi minimum, that is alpha minus 20 upon 0.2 minus 20, right? So alpha would be equals to 24 volts. So beta minus alpha, that is 36 minus 24, would be equals to 12 volts. This will be your answer for the question. The root locus diagram of a control system is shown below. Okay, this is the root locus diagram. At a gain value of k equals to 12.5, the location of the poles are marked P1, P2 and P3. Okay, given that P1 is this, right? P2 also I can say what is the value of P2. Determine the damping ratio zeta for the system. Okay, so what we know is P1 is this, right? So what will be P2? P2 will be, because of course all the coefficients of my system are real, so P2 would be basically uh, real part will be same, but the imaginary part will be just the conjugate. So this will be minus j 1.3, that's it. Okay, that is what my P2 is equals to, correct? So what we can do, we can use dominant pole approximation, because I can see that this pole, right, the real part is 0.7 and the other pole is somewhere away from minus 20. So the ratio of the real part 0.7 upon 20 is much smaller, or the ratio of the further away pole 20 upon 0.7 is much greater than 4. So we can use our dominant pole approximation. If I use my dominant pole approximation, so approximately I can assume my system to be a second order system, right, whose complex conjugate poles are this. So they are asking me what is the damping ratio. So we know the real part for a second order system, for a second order underdamped system, this portion is zeta omega n, right, and this portion is basically omega d. Okay, omega d is nothing but omega n into 1 minus zeta square, or I can say this will be, this part will be omega n cos theta, where this is my theta angle, and this will be omega n sin theta, right? From here I can easily calculate the tan theta value. So tan theta would be 1.3 by 0.7. So of course I'm just only, this is the triangle, I'm just comparing the lengths of the triangle. Okay, ignore the negative sign. Okay, so tan theta is 1.3 upon 0.7 tan inverse. So theta would be 61.7 degrees. Okay, that is what my theta is equals to, 61.7 degrees. Now I need to find out zeta. Zeta is nothing but cos theta. Cos of this, right, will be zeta. Basically cos theta is nothing but zeta, because zeta into omega n is this value 0.7. So cos of theta would be my zeta. So cos of this value, that is 0.474. Okay, so this will be my answer of the question. The Nyquist plot corresponding to the open loop transfer function is shown. Okay, so I'm only plotting the positive frequencies. Nyquist plot for the positive frequencies, it is shown. Okay, so x is this distance and y is this distance. Okay, determine the magnitude of the ratio y upon x, where y and x represent their distance along real. Okay, y is the distance from the real axis, sorry, so it should be from the imaginary axis. Okay, y is the distance from the imaginary axis and x is the distance from the real axis. Okay, respectively. So like they are like, don't worry about this, like round off your answer to 3 decimal places. So y is this distance. Okay, so y is the value of my this Nyquist plot when it is cutting the negative real axis, right, negative side. When the angle is minus 180, then the magnitude, right, magnitude of my function g of h of j omega is basically my y, the distance, right, that is my y. Okay, that is one thing. And what is x? So x, right, is this value, right, this value, this distance x, correct. So x is the magnitude of my OLTF when when my uh, when my angle of the OLTF is minus 90. Okay, so we can easily find out the values of x and y with certain conditions, correct. So uh, so what is the value of y? So for that I need, first of all, need to find out, calculate the frequency at which the phase becomes minus 180. So what is the phase function? G of h of j omega, it would be minus of tan inverse omega uh, plus tan inverse omega by 2 plus tan inverse omega by 3. Okay, so yeah, so once I will equate this equals to minus 180. Okay, when does it become purely 180? So there is another way to solve for that minus 180 case, right? So when the phase will be totally minus 180, then there will not be any real parts present. So an easier way to find out is if I write the g of h of j omega directly. Okay, that would be basically 100 upon, this will be uh, s plus 1 into s square plus 5s plus 6. Okay, this would be 100 upon s cube plus 5s square plus 6s. Okay, uh okay, plus 6s is there, and this will be plus 5s, so 11s, and this will be s square plus 5s square, that is 6s square plus 6. So what happens is, when it will cut the real axis, right, the phase will be minus 180, basically there will not be any imaginary part. So if I replace my s with j omega, right, this will be 100 upon minus j omega cube minus 6 omega square plus 11 omega j plus 6. So when it is cutting the negative real axis, basically there must not be any imaginary term present, because the numerator is completely real, the denominator also has to be real, right. So this has to be 0, the imaginary part. That means basically omega cube uh, will be equals to 11 omega. So omega equal to 0 is not a solution, obviously. Omega cannot be equal to 0, because at omega equal to 0 I am lying here, right. So I will not consider that part. Omega equal to 0 I will not consider, I will only consider the omega equals to some other value. So that would be omega square would be equals to 11. I will consider that value, right, because at omega equals to 0 the value of the function is something positive. So at omega equal to 0 this will be 100 upon 6, that is something positive, right, that I will neglect. I will only consider the negative part, wherever the value of the function is negative. So at omega square equal to 11 this will satisfy. So if I put omega square equal to 11 in this function, right, this will be 0. The actual value of the function would be 100 upon omega square equal to 11, that is minus 66 plus 60, that is minus 60, right? So this would be 5 upon 3, minus 5 upon 3, which is absolutely correct because it has to be something negative. But what I'm concerned regarding the magnitude. So y would be 5 upon 3 because y is the magnitude of the gain, right? Magnitude, length, it is the distance basically. So y value I have got, that is 5 upon 3. Okay, what about the x value? So x value is the portion when the function is purely imaginary. There is no real part here, right? It is purely imaginary. So that means now I will equate this one to be 0. I will equate this to be 0 because it is purely imaginary. There is no real part here, right? At this point, it is purely imaginary. It is cutting the j omega axis. The function is purely imaginary. So the real part will be 0. So basically your minus 6 omega square will be equals to minus 6 omega square plus 6 will be equals to 0. So from here I can say that omega square will be equals to 1. Okay, or omega will be equals to 1. I will ignore the negative solution, negative minus 1. So omega will be equals to 1. So if I put omega equals to 1 in the value of the function, right, that would be 100 upon minus j1 and plus 11j, correct? So that would be minus j will go, so j, hold on a second, so plus j 100, so minus j 100 upon 10, that is 10, minus j 10, which again makes sense because this is the negative part of the imaginary axis, right, not the positive. So minus j10 is absolutely correct. I was expecting negative only, right? I'm in the negative side. So minus j10 I have got, but what is my x value? X value is the basically magnitude, right? Basically the length. X value is just the length, right? So x would be equals to 10 basically. Okay, so we have to find out y over x, y over x. So y is 5 by 3 over x, that is 10. So this would be 1 over 6. 1 over 6 would be 0 0.167. Okay, so your answer of the question would be 0 0.167. The solution of this particular differential equation, if y equal to 0 is given as minus 3, what will be the solution? So if I try to solve this, right, I am observing that first of all this is this a linear equation? I can convert this into a linear equation, but then this will be very complex. Yeah, because y is also here, right? Y into dy is there. So this is definitely not a linear equation. So if I cross multiply dx, right, this will be 2xy minus, this is not a linear equation, in x or y, into 9x square into dx plus 2y plus x square plus 1 into dy equal to 0. Okay, now if I observe one thing, right, if I differentiate this function with, partially differentiate this function with respect to x, this will be 2x. If I partially differentiate this function with respect to y, this would be 2x. So what is happening? That means it is, this equation is exact. If this equation is exact, so I can simply integrate this equation, right? So what I can do, I can integrate this side, okay, and for this particular integration I can assume my y to be constant and I can integrate my x terms, okay, and here what I will do, I will neglect my x terms, ignore x, okay, ignore the x terms, only integrate the y terms. Okay, so this will be x square by 2 into 2x 2y, that will be anyways 0, so minus 2 x square minus this will be 9 9 sorry 3x cube plus, I will ignore the x terms, okay, only y terms I will integrate. So this will be y square plus y equals to c. Okay, now one condition is given that y of 0 is minus 3, right? So y of 0, when x is 0, y is minus 3. So this will be 0 minus 0, this will be minus 3 whole square minus 3 equals to c. So c would be equals to, this will be 9 minus 3, c is 6. So my equation will be converted into this. x square just give me 1 second, x square minus 3x cube plus y square plus y equals to 6. X square, yeah, this is minus 3x cube plus y square plus y equals to 6. So option 1 will be your correct answer for this question. Also, like, there is another way to solve this. Simply what you can do, you can differentiate this function, right? And then first of all you check the initial conditions. So you put y of 0, so if you put x equal to 0, right, in this equation, if I put x equal to 0, this will be, this is anyway 0, so this is coming 6 equal to 0, right? That is invalid. If I put here x equal to 0, y is coming out to be minus 6, again invalid, right? If I put x equal to, like, it is not even a function of uh, my x, okay? So y square plus y equal to 6, which is again incorrect, because at x equal to 0 y value should be minus 3, but if I put here minus 3, right, this will be basically, no, this is actually satisfying. Yeah, this is actually satisfying. This equation is satisfying, that y square plus y equal to 6 at x equal to 0, because it is independent of x, y is coming out to be minus 3, it is satisfying, okay? But y is always minus 3, right? But it will not be, right? It has to be some function of x as well. You can further, like, already two options are eliminated. Whatever you do, you have to differentiate this function only once and then see if this differential equation is matching here. Otherwise, only option A will be your answer. That's how you can solve smartly in the exam hall, okay? The residue of the function fz equals to this at z equal to 1 would be, sorry, this will be square here, by mistake this is raised to the power 4, this will be square, okay? So what is the formula for residue of a repeated pole? It's a, like, pole, repeated pole, right? So the formula for residue of a repeated pole is basically, if let's say it is repeating n times, right? So the formula would be, residue would be 1 by n minus 1 factorial into d of raised to the power n minus 1 divided by d of z n minus 1 into fz, okay? Z basically multiplied by the, of course don't forget to multiply by the location of the pole, z minus a, basically where z is equals to a, I put at the end, okay? Z minus a raised to the power n, okay? So here this will be 1 by 3 factorial into dn minus 1, sorry, 1 by 2 factorial, because it is repeating, sorry, it is 1 by 1 factorial because it is repeating only once, correct? So d raised to the power 1 dz into z cube upon, this will be, I can simplify, z square minus 5z plus 6, okay? So this will be equals to 3z square into z square minus 5z plus 6 and minus z cube into differentiation of the other function, that would be 2z minus 5 upon z square minus 5z plus 6 whole square. So now I can put the value of z, that is z equals to 1, I can put the value of z equals to 1. So this would be 3 into 7 minus 5, that is 2, minus 1 into minus 3 divided by, this would be 7 minus 5, that is 2 square, okay? So 6 plus 3, 6 plus 3, that is 9 by 4. So 9 by 4 would be your answer for the question. Bus 1 with voltage magnitude V1 is 1.1 pu supplies reactive power to bus 2 through a lossless transmission line of reactance X, right? It is lossless, so there is no real component. Now the bus magnitude at bus 2 is regulated and held constant as 1, right? And the real power flow is 0. So if the real power flow is 0, and what is V1 magnitude? Have they told us what is the bus 1 magnitude? Bus 1 magnitude is so adjusted that the reactive power transferred is from bus 1 to bus 2 is increased by 1.2. So if the real power transfer is 0, right? We know this formula, the power transfer from bus 1 to bus 2 that is equals to V1 V2 upon X into sine of delta 1 minus delta 2, right? So in this case basically it is sine delta only, and as the active power transfer is 0, no active power is transferred, so your delta 1 minus delta 2 will be 0. So essentially this will have the same angle, right? If this is one angle 0, this also will have the same angle. Magnitude might be different, but certainly it will have the same angle. Okay, that is the first thing. So your delta 1 is equals to delta 2. Now if the voltage at bus 1 is adjusted so that the reactive power transferred from bus 1 to bus 2 increases by 20%. So we are increasing the reactive power by 20%. If previously, what is the reactive power transfer formula from bus 1 to bus 2? Again, this I have derived in the playlist. You can go and watch in the playlist. There all these things have been derived. That is equals to V1 upon X into V1 minus V2 cos of delta, right? The phase difference between bus 1 and bus 2, right? V1 minus V2 into cos delta. So delta is 0. There is no phase difference between bus 1 and bus 2. So essentially your reactive power is V1 upon X into V1 minus V2, right? That is what my that is what my reactive power transfer is equals to, right? So what they are telling is they are adjusting their voltage magnitude at bus 1 such that there is a 20% increase in the reactive power transfer. So your new Q dash is 1.2 of the previous Q. Determine the new voltage magnitude in per unit V1 dash, right? What is the new voltage magnitude? That is what they are asking, right? So if they are increasing by 20%, so the magnitude voltage here is constant. So what is your V1? So this will be equals to your V1 dash upon X into V1 dash minus V2, that is 1 only. So V2 is 1 only, right? Magnitude of V2 is 1. So this is 1. So these two, what I can do, I can take the ratio of this and this. So this will be 1.2 is equals to V1 dash upon V. Okay, what they are asking, if the voltage adjusted so that determine this value. How do I determine this value? So okay, we are changing our, what are they reading? The voltage magnitude in the bus 1 is adjusted. So hold on a second. Oh, sorry. So voltage magnitude in bus 1 is 1.1 and voltage magnitude, okay, and supplies reactive power. Oh, sorry. This magnitude is told to us, right? It is 1.1. Sorry. I forgot, like this is the first statement. So the voltage magnitude in bus 1 is told to us, that is 1.1. So this actually is 1.1. Sorry about that. This is 1.1, right? Okay, I'm sorry. So this will be equals to 1.1 divided by 10x, that is equals to Q, right? And now they're telling that now they're changing the voltage magnitude in the bus 1. What is the new voltage magnitude, right? So yeah, we can certainly calculate this. So Q is this 1.1 upon 10x, right? So I can replace my Q with this value. So this will be equals to 1.2 into 1.1 upon 10x equals to V1 dash upon X into V1 dash minus 1. So X will be cancelled. So this will be 1.1.2 into 1.1, 1.32 divided by 10 0.132, that is equals to v1 dash whole square minus v1 dash. So v1 dash whole square minus v1 dash minus 0.132 equals to 0, right? So we can solve the quadratic equation. This will be minus b plus minus b square minus 4ac, that is 4 into 0.132 upon 2a. So this into 4 plus 1 under root. Obviously we'll ignore the negative solution. Your magnitude of v1 cannot be negative, it has to be positive. So we will choose the positive solution, plus 1 divided by 2. So your magnitude of v1 dash is equals to 1.18 pu, right? This is the voltage magnitude v1 dash, right? This is the answer basically of your question. In the given no load power system has generator, each generator has this, okay, and transmission line are these, okay. So you can read this, and all generators are star connected. Actually they meant that in the given no load power system, actually they meant that initially the power system is under no load, okay. Then calculate the magnitude of the per unit fault current supplied to ground for a single line to ground fault. So I hope you remember what happens in a single line to ground fault. All the sequence impedances are in series. So I will draw the Thevenin equivalent of the zero sequence network. I will draw the Thevenin equivalent of the negative sequence network. I will draw the Thevenin equivalent of the positive sequence network, which will only have the EMF. And of course, if there is a fault happening in the middle of the transmission line, right? So calculate the point fault supplied to ground for the single line to fault point at F. So it is happening at the middle of the transmission line. So if it is happening at the middle of the transmission line, things will be very different, okay. And it is a direct short circuit fault, so this will be short circuited, right? And the voltages of the generator, pre-fault voltages, will be 1 pu if they are operating at no load, okay. So yeah, so let me draw one by one what is the positive sequence network, what is the negative sequence network, what is the zero sequence network. So let us first draw the zero sequence network, that is the simplest case. So let me first of all write the sequence reactance components. So positive and negative sequence for the generators, xg1 equals to xg2, that is 0.1, okay. And zero sequence reactance of the generator, obviously it is lower, that is equals to 0.04 G. Now for the transmission line, the positive sequence reactance and the negative sequence reactance are again same, that is 0.08. Now what is the zero sequence reactance? The zero sequence reactance is 250% of its positive sequence. So it is 2.5 times is its positive sequence, right? It is not 250 percentage, it is 250 percentage of its positive sequence reactance. So 2.5 times of its positive sequence reactance. So 2.5 times would be this will be 2.16 and 0.5 0.4, so that is point j 0.2, okay. So these are the sequence reactants, okay. And if I draw the zero sequence model, there is a generator here, that will be obviously okay, they should mention that all the generators are star connected, okay, and their neutrals are solidly grounded. They have properly mentioned all the generators are star connected and their neutrals are solidly grounded. So their x naughts will be connected, right? X naught will be connected to ground, so this will be xg naught. And then I have this transmission line, so half of the transmission line is on the left, half of the transmission line is on the right. So if the whole transmission line has a zero sequence reactance of J0.2, what will be the reactance of half of the transmission line? It will be J0.1. It your line reactance would be proportional to the length of the line. So that is, this will be x TL0 divided by 2. This will be x TL0 divided by 2. Now there is a short circuit, and here again xg0, it is connected to ground, again xg0, it is connected to ground. So I have to compute the Thevenin equivalent reactance from here. There is no voltage source, so that is anyway 0. So what is xth0? So I see this two reactances are in parallel, so this will be xg0 divided by 2 plus xtl divided by 2. So what is xg0 divided by 2? Xg0 divided by 2 would be 0.02. 0.02 plus 0.1, right? This is half of this again, right? So 0.1 plus 0.02. So on the right hand side, the reactance is somewhat like this, J0.12 to ground. On the left hand side, it is simply xg0 plus xtl by 2, that is 0.1 plus 0.04. So it will be J0.14, right? So xth0. So these two are in parallel again, because this point is same and these two are grounded. So this will be 0.14 into 0.12 divided by 0.26. So xth0 would be equals to J0.0646. Okay, this is your equivalent zero sequence network, right? So yeah, let me write this. Let me put this here. 0. Okay, let me put xth0 is this. Now let us do the same thing for negative sequence. Okay, actually negative sequence and positive sequence, the reactance will be same, but like the open circuit voltage will be different. Of course, there is no negative sequence voltage, right? All the generators are balanced. It will be mentioned, if the generators are balanced, then there will be no negative sequence voltage. They will only develop positive sequence voltage. Okay, so basically the negative sequence Thevenin impedance and the positive sequence Thevenin impedance will be same, but what will be the open circuit voltage? So when you will have, basically, let me draw the circuit. Let me draw the positive sequence circuit, right? So if I draw the positive sequence circuit, I will have here 1 angle 0, assuming both of them are EG only. Pre-fault voltage is 1 angle 0. This will be JXG0. So not XG0, sorry. This will be JXG1. And here, this will be, so not J, sorry. XTL by 2, XTL1 by 2. XTL1 by 2. XG1. XG1. This will be 1 angle 0. This will be grounded. This will be 1 angle 0. This will be grounded. And the fault is happening over here, right? Now what is the open circuit voltage? You see that there will not be any power flow from here to here. Why? Because these voltages are same. So if voltage potential difference is same, there will be no current flow, right? From this point to this point, from this point to this point. That makes sense, right? No current flow. So what is the voltage here? plus minus VTH 1. The voltage here is simply, there is no current flow, right? This is open circuit voltage, 0 ampere. So whatever is the voltage here, this will be totally shifted here, right? That will be the voltage here. So VTH1 will be equal to simply 1 angle 0. No current is flowing, so there is no drop across the inductances. So this whole voltage can be copied here as well, right? So VTH1 is 1 angle 0. That's why you take VTH1 to be 1 angle 0. Don't just blindly take it, because one day the circuit will be different and VTH1 may come out to be different. So be very, very careful. So VTH1, of course, it will be 1 angle 0. It will be easy for you. What about your equivalent? Equivalent reactance. In the positive sequence, in the negative sequence, it will be same. So equivalent reactance, right? This will be shorted, this will be shorted, this will be shorted. So xg1 xg1 divided by 2 plus xtl divided by 2. So xg1 plus xtl divided by 2, that is, what is xg1? Xg1 is 0.1, xtl is 0.08, right? So it is 0.18 divided by 2. So on the right hand side I have j 0.09, and this will be xg1 plus xtl divided by 2, right? xg1 plus xtl divided by 2. So xg1 is how much? Xg1 is 0.1 and xtl is 0.08. So this will be again, okay, xtl divided by 2, right? So this will be 0.04 plus 0.1, that is 0.14. So these two are in parallel and I'm calculating the reactance from these 2 points, right? So the reactance would be 0.14 into 0.09 upon 6 and 3, 0.23. So that is your xth1 that is equals to your xth2, that will be equals to j 0.0548. okay, that is your per unit positive and negative sequence reactance, and we have computed the voltage as well. So now we can safely draw our circuit. This is the circuit, right? So this is not the fall current, this is the zero sequence current, right? And your fall current is 3 times zero sequence current. So what is the zero sequence current? It is 1 upon, basically if I want to compute the magnitude, it will be 3 into xth 1 plus xth 2 plus xth 0 magnitude, right? This is the actual fault current. So your answer would be 3 upon xth 1, that is 0.05. Because I'm taking the magnitude, I can just simply ignore the j. 0.048 plus 0.0548 plus 0.0646, 0.0646, right? This will be equals to into 2 plus 0.0646 into 3. So it approximately is equals to 17.22 pu. So your answer, they have asked us to round off to 2 decimal places, so your answer would be 17.22 per unit. For a certain binary communication channel, okay, it's a binary communication channel, that is either 0 or 1 will be transmitted. The probability that it transmitted 0 is received as 0 is 0.95. okay, so if I'm transmitting 1, there is a probability that I will receive, sorry, if I'm transmitting 0, there is a probability that I will receive 1 due to some error in the communication line, and the probability is 0.05. okay, the probability that transmitted 1 is received as 1 is 0.9. okay, and it is received as 0 is 0.1, then the remaining would be 0.1 basically. If the probability that 0, if the probability that is 0 is transmitted, if the probability that is 0 is transmitted is 0.4. So probability that I am transmitting 0 is 0.4. Okay, 0 is transmitted is 0.4. What is the probability that 1 was transmitted given that 1 was received? Okay, what is the probability that 1 was transmitted given that 1 was received? So they are asking me what is the probability that 1 was transmitted given that 1 was received. So simply, what is the probability that 1 was transmitted? It was 0.6. Now you say this is the answer. No, this is not the answer, because it is conditional probability. Some information is given to you, right? What is the information? That we already know that we are receiving 1. If I am receiving 1, right, that means there is a high probability that 1 will be transmitted, because if I am receiving 1, then like there is 90% chance, right, 1 was transmitted. Okay, if I am receiving the correct value, but I don't know whether I am receiving correct or not. So there are two cases here, right? Two cases. Either I was transmitting 0 and I received 1, because this is given to me in the question, or I transmitted 1 and I received 1. So we need to find out the condition case for which I was transmitting 1, given that I received 1. So what is the total probability of receiving 1? There can be two things. Either I transmitted 0 and due to some error in the communication line, right, I got 1. So what is the probability? 0.05. So first we need to transmit 0. So probability for transmitting 0 is 0.4. And what is the probability of error in transmission of 0? 0.05. So then I will receive a 1 at the receiving side. Or other probabilities, if I am transmitting 1, the probability to transmit 1 is 0.6, and of course I am receiving 1, that means the communication line has to be error free. What is the probability of error free communication line when I am transmitting 1? 0.9. So this will be 0.9. Okay, now this is the probability of receiving a 1. Now they are not asking me this, they are basically asking me what is the probability that I transmitted 1 given that I have received 1, right? So how do I calculate this? It is the probability that I transmit 1 and receive 1 intersection upon probability of receiving 1, correct? So what is this intersection? When I am both transmitting 1 and receiving 1, it is this value, right? This value. When I am both transmitting 1 and receiving 1. So if I solve this, this will be 0.4 into 0.05 plus, sorry, no, not this. This will be 0.6 into 0.9 upon this whole value, right? This whole addition. So let me just calculate this value. 0.4 into 0.05 plus 0.6 into 0.9, that is 0.56, right? 0.56, this into 0.6 into 0.9, that is 0.964. So yeah, approximately your answer will be 0.964. This will be your answer for the question. What is the area bounded by the curves y equals to x into mod of x and y square equals to mod of x? Assume range of y for second function is this, right? Range of y for second function, basically this range of y, right, with output of this function, right, that is y value can only lie between 0 to infinity. Okay, okay. The area bounded by the curves y into mod of x, so y equals to x into mod of x. So what is mod x? Mod x function is this. This is my y equals to mod of x. And what about my y equals to x function? Y equals to x function is this, right? Or we don't even need to multiply these functions. Like what you can simply do is you can define the function for y greater than 0, sorry, x greater than 0 and x less than 0. So y is equals to minus of x square when x is less than 0, because mod of x will be replaced with minus x, and y will be equals to plus of x square when x is greater than 0, because mod of x will be replaced with plus x. So if I plot the function, right, like x square is something like this, right, but I have to write in the negative region, I have to write minus of x square, so it will be something like this. Okay, and positive, it does not matter, like it will be same, it will be concave of, so here it will be same only, right? So it somewhat looks like a cubic function, this is my y equals to x into mod of x. What about the second function, y square equals to mod of x, right? Now they're telling me that the range of y is always it is between 0 to infinity, right? Like these are real numbers, it is between 0 to infinity. So y square is between 0 to infinity. What you can do, you can take the under root on both sides. If I take under root, so my this value, right, is always positive. Y square is always positive, right? It is real, y square is always positive. So if I take the under root on both sides, what will I get? This will be plus minus under root of mod of x, correct? If I take the under root on both sides. So already what they are telling you that your y value is always positive. Y value is always positive actually. And I should also mention the domain of x as well, right? So your range of y is between 0 to infinity. So obviously I will choose the positive number, I will not choose a negative number. And here I will mention the domain of x. Domain of x will be also same. It will be between 0 to infinity. Okay, infinity actually should not be included here. That's a mistake on my view. This should also be curly bracket. Right. So basically your y will be equals to plus under root of x, because the domain of x is positive, so mod of x will always be replaced with plus x only, right? And your y range of y is also positive, so this negative sign I will not choose, I will always choose positive value. So do you know how to plot mod of x? So mod of x plot would be not mod of x, sorry, under root of x, it will be somewhat like this, right? And they are finding they are asking me to area bounded by this curve, so basically they are asking me the area of these two curves, right? So this is nothing but my y equals to under root of x, and this curve is nothing but y equals to x square, very simple. So they are technically asking me this value, what are the common points? X equal to 0, y equal to 0. Here this, what is the common point? X equal to 1, y equals to 1, right? These two are my common points. So you can solve using anything, vertical strip or horizontal strip, it is totally up to you. So this will be double integration dx dy, right? Because I have to compute the area. Now if I choose dx, right, that will be a problem. Let me choose dy, because I'm choosing the limits of y, right? I'm choosing the limits of y, so let me choose dy. Y, this bottom curve is y equals to x square, and this top curve is y equals to under root of x, and x is going from what? X is going from 0 to x equal to 1, 0 to 1. So this value would be 0 to 1 under root of x minus x square dx. This would be x 3 by 2 by 3 by 2 minus x cube by 3. X is going from 0 to 1, right? So for 0 this is 0 only. For 1 this will be 2 by 3 minus 1 by 3, that would be 1 by 3. So 1 by 3 would be your answer, that is 0.33. So 0.33 would be your answer for this question. In a series RLC circuit with R equals to 20 ohm. So it's a series RLC circuit where they have given me that the value of R is 20 ohms. This value is 20 ohms. That is fine. And the circuit current, sorry, actually this should be different. The current in the circuit lags behind the applied voltage by 30 degrees. This circuit should not be there actually. Okay, this circuit should not be there. I will remove it. The current in the circuit lags behind the applied voltage by 30 degrees. So the voltage bit, so of course in a series RLC circuit we apply the voltage and we assume the voltage to be the reference. Sorry, we assume the current to be the reference actually, because the current is same throughout, and they are telling me that the current lags the voltage by 30 degrees. So voltage would be somewhere here because it will lead because current lags the voltage by 30 degrees, right? Lag basically means in the clockwise direction. And if the current lags the voltage, overall the circuit behaves as inductive. Overall the circuit behaves as inductive. So circuit behaves as inductive. We got a lot of information. So in a series RLC circuit, if the circuit behaves as inductive, we know that your XL will be greater than XC. Correct? XL will be greater than XC because the circuit behaves as inductive. The inductive reactance will be more than the capacitive reactance. Okay, and also they have given me the instantaneous voltage drop across the inductor. Okay, the maximum inductance voltage is twice the maximum capacitance voltage. Do you understand what it means? Basically, the peak value of the inductor voltage, right, is twice the peak value of the capacitor voltage. What will be these values? So, what will be the peak value of the inductor voltage? It will be simply peak value of the current into the reactance, isn't it? And here it will be the peak value of the current into the capacitive reactance, right? Because like of course VL will be measured across this and your VC would be measured across this, and this will provide a reactance of XC, this will provide a reactance of XL. So yeah, and of course there is a 2 here, don't forget there is a 2, right? 2 into IP into XC, that's all. So of course your IP will be cancelled because the peak value, it is a series circuit, right? The peak value will be same, so IP will be cancelled. So from here we got another information that our XL is 2 times XC, right? And this ratio, right, this, sorry, not ratio, this angle 30 degree, do you know what is this? So this is the angle between the voltage and current. So this is nothing but the impedance angle, right? If you remember, this is nothing but the impedance angle. How do I compute the impedance angle? So how do I compute the impedance? Right, impedance Z, that is equals to what? That is equals to V by I, right? If I see the voltage from here and measure the current from here, the ratio of these two will give me impedance. So V is V angle 0 and I is minus 30, I angle minus 30. I don't know the magnitude of current, but certainly I know the angle. They have told me that the current lags the voltage by 30, so that's why minus 30. So this will be magnitude of V by magnitude of I into angle of plus 30. So this plus 30 is nothing but the impedance angle, right? So impedance angle theta Z is equals to what? Do you remember what is it equals to? So if I write the Z equivalent, right, impedance, that is equals to R plus J into XL minus XC, because impedance, because inductive reactance is positive, that is a reference, and capacitive reactance is negative, right? XL minus XC. So it is equals to R plus J XL minus XC. So what is the angle here? How do I compute the angle? It is very easy, right? Tan inverse XL, the imaginary part, upon the real part. So yeah, theta Z is 30, right? So I can take the tan on both sides, so tan 30 would be equals to XL minus XC divided by R. So tan 30 is equals to 1 by root 3, that is equals to XL minus XC. Okay, so XL is 2 times XC, so this will be 2XC minus XC divided by R. R is 20 ohms, right? So from here we can actually get the value of XC, but what have they asked? They have asked me the value of L and C, right? Both L and C. So XC I can get, XC value I can get certainly. XC would be equals to 20 upon root 3 ohms. But they have not asked me what is the value of XC. They have asked me what is the value of C. And we know XC is equals to 1 by omega C. So what is omega? Omega can be found from here, right? Sin omega t. Because we know if I am applying an input sinusoidal frequency, the frequency won't change. The phase of the voltage can change. Certainly it can change, right? But the frequency would remain same. Frequency would remain same. So frequency is 377 radian per second. Always remember this is actually omega into t, right? Where omega is in radian per second in this particular equation. So here C value would be 377. Okay, so this value would be 20 into 377 into root 3. Okay, so this will be around 230 micro, right? 230 microfarad. So C value is 230, that is present in option A and option D. What about the L value? Again, right? So we know this. Our XL is twice the XC. So XC is this value. But about our XL? XL would be this. Twice this, that is 2 into 20 by root 3. And that is equals to 40 divided by root 3. So this will be equals to 2 into pi into f. Okay, omega into L basically, right? XL is omega into L. Omega is 337, right? That 337 is nothing but 2 pi f. Okay, so L would be what? This would be 40 upon root 3 into 1 by 377. Okay, so 377, where did it go? Okay, it automatically got, okay, something gone away. So let me calculate this. 40 divided by 377 divided by root 3. So this would be 61.25 millihenry. Okay, almost near about the option D, right? Of course, very close. So this would be my answer, right? Option D would be my answer, very close to option D. So option D is the answer. Option A is not the answer. So yeah, that's how you will solve this question. So I can solve this in 1 minute as well, right? I have to explain all this. That's why I am taking more time. But you know, like there is this phase angle difference. All these things are here. You will directly arrive at this formula. You will directly use this, right? And from there you will directly find out XC and XL, because you will also know this, right? This thing. So mainly you will use this formula, and then you will derive the relations. And after that, you know what is the omega, and you will use that. Right? That's how you solve this question. So for this question, the answer is option D.
Power dissipated in the resistor, they are asking. Whenever they ask about the, sorry, energy dissipation. So whenever they ask about the energy, our concern would be PT dot dt. That's it. And what is PT? Vt dot it dot dt. That means my concern is that I find out the voltage expression in the resistor and current expression in the resistor, and my job would be done. Multiply both of them, dot dt, circuit is starting at t equals to 0, so 0 to infinity. That's it. So voltage and current you can find out. Any way you can put, whatever the way is feasible for you. If you have studied from some other platform, then you will be applying Laplace transform. If you have studied from here, then you would know that just as I close the switch, then infinite current would flow, impulsive current would flow. C1, C2 both are equal. That means immediately voltage will change to 2.5 volt. Here also 2.5 volt. Here also 2.5 volt. And then eventually all the 2.5 volt will be discharging through the resistor R. Right? So what will be the VRT expression? Initially 2.5 volt, but discharging through the resistor R with the time constant of tau. What will be the time constant? What will be the time constant here? Time constant would be nothing but 2 RC, because both are in parallel. Time constant would come out to be 2 seconds. Sir, how did you write down this expression? It is completely based on transient, okay, and an intuitive way of studying the transient. I know you have studied in Laplace domain. It's your choice, okay. When we study in intuitive way. 3 kind of circuits are there: when there is no resistance, when the resistance is in series, and when the resistance is in parallel. This kind of question would be coming. Even educators and students, everyone will be solving with respect to Laplace transform. But those who have studied in a good manner, they will be solving with respect to transient analysis, actual transient analysis. So here impulsive current would flow, voltage will be divided, then complete discharging would be there. This is how the voltage equation is coming. Then directly I can write down the current equation, that would be 2.5 divided by R. That would also be divided by R. R would be 1 only. So that would also be the same. Minus T by 2. This will be volt, this will be ampere. So multiplication of both of them, 2.5 into 2.5, that would become 6.25. E to the power minus T by 2 multiply with e to the power minus T by 2 dot dt. So this will become e to the power minus T. Right? E to the power minus T by 2 multiply with e to the power minus T by 2, that would become e to the power minus T, and integration of e to the power minus T from 0 to infinity. Integration of e to the power minus at dot dt from 0 to infinity, that is 1 by a. So e to the power minus t dot dt from 0 to infinity, that will throw 1. So what is the power dissipated? That means that is 6.25 joule. Okay, so power dissipated would be 6.25 joule. That would be the answer. Let's go to the next one. So this was the pole zero diagram that was given, and you need to find out the frequency response. So what kind of h of z you will be getting? There is any zero? No. It could have some gain. I don't care about it. Where will be the pole? Pole is less than 1. Let's just say this is 1 by 2. I can assume anything, no? 4 options would be given. There 4 options are given. Okay, in your question, you can see the question, 4 options are given, right? So I can assume it to be 1 by 2. Let's assume it to be 1 by 2. I can assume anything. So what will be your h of e to the power j omega? K e to the power j omega minus 1 by 2. Now you need to draw the frequency spectrum, right? Frequency spectrum you need to draw. I guess they asked about the magnitude spectrum only. Okay, they were asking about the magnitude spectrum. So magnitude spectrum you need to draw. So I told you always check at 3 points. At omega equals to 0. At omega equals to 0, what is the scenario you are getting? E to the power j0, that would be 1. So 2k, some constant value you are getting. Check at omega equals to j pi by 2 as well. So k e to the power j pi by 2. What that would be? J only. J minus 1 by 2. So that would be k under root 1 plus 1 by 4. That would be 5 by 4. So this is coming out to be 2k by under root 5. So 2k by under root 5 is surely less than this. This value is more, this value is less, right? And at pi you need to check. If you check at pi, e to the power j pi, what that would become? Minus 1, right? So minus 3 by 2. So that would become 2k by 3. 2k by 3. So which value is more? This is the highest one. Then between these two guys, who is higher? Under root 5 is higher or 3 is higher? 3 is higher, no? That means this value is least. So you can sense that from 0 to pi. From 0 to pi, from 0 to pi, your magnitude is constantly decreasing. Here also I have written down the magnitude. You would say, sir, where the negative sign goes? We are talking about the magnitude spectrum. So from 0 to pi, your magnitude is constantly decreasing. It will work as a low pass filter. And after pi, it will keep on repeating. Not after pi, after 2 pi, it will repeat. Right? So here, this kind of spectrum would be there, and then it will repeat in this manner. Okay? So low pass filter, it is working as a low pass filter, and this was there in the options. Very straightforward, very, very simple question. Let's go to the next one.
A DC to DC converter operates with a switching frequency of 10 kilohertz. So my F switching is 10k. So my time period would be 1 by 10, that is 0.1 milliseconds or 100 microseconds. Is supplied from a DC source of 250 volts. So this source is a DC source of 250 volts, as you can see from the diagram. So Vs is equal to 250 volts. The output capacitor is sufficiently large so that the capacitor voltage may be assumed to be nearly constant. So the capacitor voltage is all like the load voltage essentially is almost constant, right? So your VO is constant, your IO is also constant because the load is a resistive load. The voltage waveform across the inductor over one switching period is shown. Okay, this is the voltage waveform. That's pretty interesting. I see the inductor voltage is 0 for certain period. If it is 0, then the change in the, so basically the what will be the current here? IL is equal, sorry, VL is equal to L DIL by dt. So for this duration there is no change in the current. Okay, we will see that. We will see that. Now determine the average power delivered by the chopper. What is the average power delivered by the chopper? Yeah, in a time period, basically inwards. So this case is what? This case is of the case of the discontinuous conduction, because here I see the inductor voltage is 0 for certain period, right? If it is 0, that basically means this inductor voltage, like the current here also will become 0, because uh, what is my, hold on, will the current be 0? Yeah, current also will be 0. So what is happening, if I, this waveform is periodic, okay, they have not like they should, I should have told you here that the voltage waveform across the inductor over one switching period is shown. Okay, this is the one switching period, again it will repeat after t, again it will repeat, it is periodic. So what is happening, if I assume initially, let's assume that inductor does not have any current, right? So if the voltage across it is constant, what will be the inductor current? IL. So I know VL is equals to L DIL by dt. So your IL would be integration 1 by L integration of VL dt. Okay. So yeah, 1 by L integration of VL dt. So integration, right, of VL is constant. So current will linearly increase in this region, and then what will happen is, as soon as this voltage will be negative, that is minus VL, I don't know what is the value of this VL, current will reduce. Okay. Now here your voltage, inductor voltage is becoming 0. If your inductor voltage itself is becoming 0, what will be your IL? IL also will be 0 only. IL also will be 0. If I integrate this 0, right, it is 0, constant 0, so this will be 0 only, right? So it will be 0 for a while, and this cycle will repeat. Okay, this cycle will repeat. So one thing that I have always told you, right, if the inductor voltage is periodic, the average area under the inductor voltage will always be 0. Why? Otherwise your current, right, will always keep on increasing. If your average area under the inductor voltage is non-zero, then your inductor current will always increase, the average inductor current will always keep on increasing, and your current waveform will not be periodic. If your current waveform is periodic, then your average voltage, like basically across the inductor voltage, has to be 0 if it is periodic, right? So if it is 0, average area under the inductor voltage is 0, then from this I can actually get the value of VL. That will help me to compute the value of VO. Okay, so the average area under the inductor voltage over a period will be 0, that is 62.5. It is given, it is 0.6 into t, right? That is the turn on period. This is the positive area, and the negative area is VL into 0.2 into t. So your VL is equals to 3 into 62.5, that is 187.5 volts, right? VL is equals to 187.5 volts. So that is what my VL is equals to, and this VL is nothing. So when the diode is on, right, when the diode is on, that is my VL is equals to minus of VO, right? So actually this is actually equals to VO, right, because it is minus of VL. So your like VO will be equals to 187.5 volts. Okay, got this. So we got our VO, right, VO average, because when the inductor is on, the diode will be turned on, and this will be my VO average. So if I know my VO average, which is almost kept as constant by the capacitor present over here, I certainly know what is my IO average. It will be VO average upon R, that is 18.75 amperes. And as all the components are ideal, there are no switching losses, then I can say that your input power, right, power delivered, average power delivered by the chopper, right, chopper, it will be same as the output power, because they are not, there is no power loss elements. So it will be VO average into IO average, which are constant only, 187.5 into 18.75. So let me compute this. So anyways, if you know the voltage, right, you know voltage is constant, so whatever will be the power consumed, it will be 187.5 divided by 187.5 whole square divided by 10. So like that also you can solve, or like this also you can solve. Both are same thing only. So this will come out to be 3515.625 watts. So this will be your answer of the question.
Yeah, that's a good question. Let's see the solution of this one. Like, you are not confused between these two, but you are actually confused between these two, right? So let's see the first one. If HT is periodic, impulse response is periodic. If your impulse response is periodic like this, if it is periodic like this, then it is surely not absolutely integrable. That means minus infinity to infinity mod of h of t dot dt. Will it be a finite value? No. If it is not a finite value, what does that mean? That means it will be unstable, right? So this is something that has been written. Now mod of h of n is less than k. Will that be satisfying the condition of stability? No. This is the condition of stability, no? That mod of h of k, where k goes from minus infinity to infinity, this should be less than or equals to m. Or you can say that it should be finite. It should be finite. This is the condition of stability. Now here I can take the example that h of n is un. If your h of n is un, this is the graph. All the values are less than a particular value. That means all the values are finite values. But still, is it absolutely integrable? No. It is not absolutely integrable. What does that mean? That h of n equals to un. That is a unstable system, right? And it is pretty obvious as well, because it is not absolutely integrable. So it is stable? No. Right? This is the condition of stability. Now the second one. For a discrete time LTI system, if a discrete time LTI system is causal, then its step response is 0 for n less than 0. What will be the step response? What is the meaning of step response? Step response means simply input is un convolved with h of n, right? Where this is your impulse response and this is your input. So your step response could be written, anything convolved with u of n could be written as running summation. Say yes or no. So s of n could be written as minus k going from minus infinity to n h of k. Say yes or no. Now what they are saying? They are saying that if a discrete time LTI system is causal, your LTI system is causal. That means this is a causal signal. Say yes or no. That means h of n equals to 0 for n less than 0. Say yes or no. That means let's just say if I put n equals to minus 1. So what will be your s of minus 1? So that would be summation k going from minus infinity to minus 1 h of k. That means all the samples will be added which are present between minus infinity to 1. That means h of minus infinity dot 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 dot, dot h of minus 3 plus h of minus 2 plus h of minus 1. What that would be equivalent to? That would be equivalent to 0 only. That means s of minus 1 will be 0. What will be s of minus 2? Similar thing would happen here, no? All the samples are 0 only. So what does that mean? That means s of n is coming out to be 0 for n less than 0. This is something that has been written. This statement is correct. Now next one. If the step response s of n of a discrete time LTI system is 0 for n less than 0, that means if this guy is causal, then this will be also causal. This is what they are saying. So shall we check it? From here, if I need to write down h of n, how I can write it down? This is running summation. When it goes here, it will become difference. That means this is how I can write it down. Like basically s of n was nothing but h of minus infinity and so on h of n. Right? Basically it could be written as s of n was nothing but although I have proved it in the class itself, but say here again I am proving h of n plus h of n minus 1 plus h of n minus 2 and so on till infinity, right? So what will be s of n minus 1? In place of n you need to put n minus 1. So in place of n I am putting n minus 1. In place of n I am putting n minus 2. Then n minus 3 and so on. When you subtract both of them, s of n minus s of n minus 1, what you are left with? This and this will get cancelled out, this and this will get cancelled out, only h of n will be left. So there you go. So this is how I can write down my h of n, right? Now what they are saying? That s of n is 0 for n less than 0. This is what they are saying. So surely s of n minus 1 would be 0 for n minus 1 less than 0, or you can say n less than 1. So your s of n minus 1 would be 0 for n less than 1. So for n equals to 0, what will happen? At n equals to 0, at n equals to 0, if you check the value, h of 0 would be this particular thing. Now this could be non-zero, h of 0 could be non-zero as well. What will be h of 1? What will be h of 1? H of 1 would be s of 1 minus s of 0. Both could be non-zero, I don't care about it. But what about h of minus 1? H of minus 1. So that would be s of minus 1 minus s of minus 2. S of n is 0 for n less than. This will also be 0, this will also be 0. That means h of minus 1 will also be 0. What about h of minus 2? Sir, s of minus 2 minus s of minus 3. 0, 0, 0. H of minus 3 and so on. What does that mean? That means from here also you can say that h of n is coming out to be n 0 for n less than 0. What does that mean? That means that if this is the condition, what does that mean? System is causal. System is causal. This is the statement that has been written. The system is causal. So both sides it is going. What does that mean? That if h of n is a causal signal, then impulse response, then the step response will be causal. And if step response is causal, then your system will be causal. Is that understandable to you? So again, very important statement in the examination. It can be surely coming in the future. But again, solving these kind of questions in the examination hall will be very difficult. But this is how you can think. Is that understandable to you? Okay. So this was a good question. Let's go to the next one.
If two eigenvalues of the matrix A are -1 and 4, then the magnitude of the determinant of A inverse would be. Okay. So if I know the two eigenvalues, right, then I can actually calculate the other eigenvalue. Okay. So I know the determinant of matrix A would be the product of all the eigenvalues. Okay. So okay, still I don't know. So what is the determinant here? This value. What is the two eigenvalues I know. Okay. So okay. So if I correctly remember, like the trace of my matrix A, right, for a third order uh, matrix 3 cross 3 matrix would be equals to the sum of all the eigenvalues. So let us assume that the third eigenvalue is lambda. Okay. If the third eigenvalue is lambda, then trace of A, right? Trace of A is nothing but the sum of the diagonal elements, that is 5 plus x will be equals to -1 plus 4 plus lambda. So from here I can get the value of x. X would be equals to lambda minus 2. Okay, that is what my x value is. Also, I can say the determinant of A, right, will be equals to the product of all the eigenvalues. These two properties will always hold no matter what. Okay, determinant of A will be product of eigenvalues. Okay, so determinant of A in this case is what it is, basically 3 into 2x minus 6 equals to product of the eigenvalues, that is -1 into 4 into lambda. Okay, so I know my x is equals to lambda minus 2, right? Either way you can solve this. uh, uh, Let me solve it like this: lambda equals to x plus 2, that will be easier. So this will be 6x minus 18 equals to minus 4x minus 8. So 10x will be equals to 10. So x will be equals to 1. So lambda would be equals to 3. So they are asking you the determinant of A inverse. So determinant of A inverse will be basically 1 by determinant of A, correct? Okay. So determinant of A is product of the eigenvalues, that is basically minus 4 lambda. Lambda is 3, so it is minus 12. So it will be minus 1 by 12 basically. So minus 1 by 12, I can calculate minus 1 by 12, right? 1 by 12, yeah, minus 0.0833. This will be your answer for the question. Yeah, let's solve this question. So like I've already solved this question using method 1, so that will come here. Later something clicked in my mind that we can use method 2 as well, right? So first you watch the method 1. This is the method 1 that will just come after this, right? Make sure you watch the method 2 as well. That is a easier method and a faster method to solve. Okay, let f be equals to y z z x x y and s be the portion of the sphere that lies in the first octant. Then evaluate the open surface integral. What will be the open surface integral, right? So first of all, you will think that I have been given a surface integral, so I will use the divergence theorem, del dot f, right? And they'll compute the volume integral. I can use the Gauss divergence theorem. So del dot f will be very simple. This will be 0, this will be 0, this will be 0. So answer will be 0 and you will be wrong. Because they have not asked you to uh, find out the closed integration. They have specifically mentioned that they are asking you the open surface integral, right? Open surface integral. Open surface integral. So what is open surface integral? Open surface integral, if I draw the surface, right, what is the first octant? So this is my x, this is my y, this is my z. So first octant would be this part, right, in the positive, and your sphere would be in the first like the sphere in the first octant would be this surface. So they are only talking about the first octant, where my both, I will mention this, where basically my x is greater than 0, y is greater than 0 and z is greater than 0. This is the surface. I will mention this, don't worry. In the question this will be mentioned. First octant basically means x greater than 0, y greater than 0 and z greater than 0. Okay, so basically this outer surface, right, of the sphere, they're asking you how do I compute. You cannot use Gauss theorem. So for this I obviously need to compute the unit normal vector, direction of the unit normal vector, n cap. So n cap, they told me that it is a n cap is a outward unit normal vector to the surface, outward vector. So how do I compute n cap ds? How do I compute that? It's pretty simple, right? What you can do is uh, you can take this surface and you can find out the normal vector along this surface. How to do that? Simply take the gradient. Simply take the gradient of this surface, right? So yeah, I hope you can take the gradient, right? So let's take the gradient. So what is grad of f? Not grad of f, sorry, grad of the surface given, right? Grad of s basically. Grad of s, the scalar point function, and that will give me the gradient. Correct? So yeah, let's do that basically. So grad of s would be what? This would be uh, 2x I cap plus 2y j cap plus 2z k cap. That is my grad of s. Now I have to compute the unit normal vector, right? Unit normal vector, because n cap is a unit normal vector. So n cap would be grad of s upon magnitude of s. So this is equals to 2. I can take common. So 2 is anyways outside, divided by 2. That anyways will go away, the magnitude. This will be x I cap plus yj cap plus zk cap divided by under root of x square plus y square plus z square. Now the beautiful thing about this is they have given me the surface of a sphere, and the surface of a sphere must satisfy this relation x square plus y square plus z square. So this will always be equals to 1. So technically your normal vector is this. Now what do you do? Now you convert everything. Now you do the f dot n cap, right? You do f dot n cap. So what is f dot n cap? F dot n cap. So f dot n cap would be simply this dot this. I think you can do it, right? So the first I dot I will be xyz, second also will be xyz, and third also will be xyz. I think you can do it. I hope you can do it. This dot with this, right? So actually your f dot n cap is actually 3xyz. And what is the magnitude of the surface vector, right? How do I write everything in terms of surface? Bit difficult. So how do I write down the surface vector ds, right? How do I do it? So this surface, right? This surface has what? This surface has r constant. If you see the radius of this radius, right, is always constant. So r is constant, right? What is changing? The theta is changing. Basically, x, y, z, the angle with respect to the positive z axis is actually called as my theta. An angle with respect to my positive x axis is called as phi, right? So I have taught this in vector calculus as well. Again, I will tell you how to remember this, right? So what will be the, so ds, right? ds, your r is constant, r is not changing. What is changing? Your phi and theta are changing. So it will be product of your phi and theta. Now what is the length of this arc? Length of this arc. So let me first of all tell you what is the length of this arc. This arc, right? What is the length of this arc? This is r d theta. I hope you know it. R d theta will be the arc length here, right? And what is the length of this arc? I have to compute the radius here, right? Radius. So what is the radius in the xy plane? It is, this is my radius r, r sine theta, right? This radius is r sine theta. This radius is r sine theta. R sine theta into d phi. This will be the arc length of this, right? And your surface will be formed like this and this. These two are my small sides along phi axis and along d theta. So this small length is what? This small length is r d theta, and this small length is actually r sine theta and d phi. And trust me, no one will explain you these small things. Everyone will directly say you that your ds will be r square into sine theta into d theta into d phi. Everyone will tell you to mug this up. But I am explaining you. Actually, this is the small surface, right? And the breadth and the length of the rectangle are these two values. That's how this formula came. Okay, I'm explaining you everything. And of course, your r is constant. R is equals to 1. Right? Radius of the circle, radius of the sphere is 1. So sine theta, d theta, d phi. That is my ds vector. So we got our ds vector, we got our f dot n. So ultimately, we have to compute this value. We can easily compute this value. Okay, one more thing. What is your x? So your x, right, in spherical coordinate. So if I project this r in the xy plane, this will be what? R sine theta. And your x value would be r sine theta cos phi. Correct? And your y value would be r sine theta sin phi. Okay, so these are very basic conversions which you should know. R sine theta cos phi, y will be r sine theta sin phi. And z will be r cos theta. So replace all these things. And in the first octant, what happens? In the first octant, if you see, your phi goes from 0 to pi by 2 and your theta goes from 0 to pi by 2. Correct? So your phi is going from 0 to pi by 2. Your theta is going from 0 to pi by 2. R is constant, obviously. So what is happening? This will be xyz, that is r cube. So r is 1, so I don't need to worry about that. Sine square theta into sin phi cos phi, sin phi cos phi, and cos theta is also there, right? And here on the in this particular function, what is my ds? Ds is this, right? Sin theta d theta d phi, sin theta d theta d phi. Okay, and obviously your theta both are varying from 0 to 0 to pi by 2. It does not matter, whichever one you solve first, does not matter, right? You can, this is in variable separable format, so you can easily solve it. So sine cube, so if I rearrange the terms here, this will be sine cube theta into cos theta d theta, and this will be this can be written as 1 by 2 into sine of 2 phi d phi. Correct? Okay. I hope I'm solving everything correctly here. So yeah, let us try to solve it. Okay, so what we can assume in this particular integration, we can assume our sine theta to be some t, right? Sine theta is t, your dt would be cos theta d theta. Okay, so this will be t cube dt, correct? And this is pretty straightforward, right? This will be 1 by 4 cos of 2 theta minus sign would be there. I can change the limits. So pi by 2 to 0. I have just swapped the limits because a negative sign is there. Okay, cool. What about the limits in this integration? So if your if your theta is going to 0, your t is going to 0 as well, right? So t would go from 0 to, if your theta is going to pi by 2, t would go to 1. So this will be 0 to 1, right? So this will be basically t raised to power 4 by 4 going from 0 to 1. So this will be 1 by 4 into 1 by 4 into, okay, uh, okay, one small thing you forgot, right? We're adding, so there is a 3 as well, right? There is a 3, don't forget there is a 3 at the starting. So yeah, these kind of small mistakes can happen, so be very careful, very attentive. And this value, right, this will be what? So cos of 0 is simply 1 and cos of pi is simply minus 1, right? Because 2 into pi by 2 is pi. So this will be 2 actually, so this will be 3 by 8. Okay, so this was a lengthy question. I do agree, I certainly do agree, this was a lengthy question. So your answer is 3 by 8. Let me write this in 3 decimal places because the answer has asked you to compute in 3 decimal places. So 3 by 8 would be 0. 375. This will be your answer for the question. So now, like, so let's solve this using method 2. So method 2 actually will use the Gauss divergence theorem, correct? How? So I have already mentioned to you what is the surface. This is my open surface, right? So if this is my open surface, what I can do is I can calculate the closed surface integral, right? And closed surface integral del dot f is actually 0. So your this integration is 0, right? So what does it mean? This, sorry, not closed, yeah, closed surface integration is 0, right, along this whole surface. So how many surfaces do I have? So this is f dot n cap ds. Okay, so if I show you this surface properly, let me show you this surface. So in total, I have how many surfaces? So this is the first part of the surface, right? The outer surface that we actually have to compute, and these other parts are all here. Let's say this is the surface 2, this is the surface 3, and this bottom part is the surface 4, correct? Now all these are interesting in surface 2. So how can I write this particular integration? I can divide them into chunks, right? So this whole closed surface integral is 0. It is certainly 0 because it is a closed surface, and I can use the Gauss divergence theorem. This will be equals to what? This will be equals to my integration of the surface 1, right? Surface integration, open surface integration of the surface 1, that is f dot n cap ds, and similarly I will add it with the surface 2. Surface 2, and same thing will happen for surface 3 and surface 4. I can break this down into 4 surface integrals. Totally valid, and I hope you will not be mad at me if I do that. Now the interesting part is, what is my unknown? I have to compute this part actually. I will only have to compute the integration for surface 1. So if I have to only compute the integration for surface 1, what will I do? I will simply, because this part is, this addition is all 0, right? So I can take all these on the other side. So my, this part, right, that I have to compute, I can avoid computing it, and I can compute this other 3 minus of all these 3, right? Correct. So these are actually very easy to compute. Why? If we see the surface 2, surface 2 is what? In the xz plane. In xz plane, what happens? Y0. Xz plane, surface 2, y0. Surface 3, what is 0? Surface 3, if you see, it is this surface, that is yz plane, x is 0. Your answers will be very simplified. Surface 4 is the bottom surface, your z is 0, right? Things will be very simplified. Minus, now what will be like the surface vector? It is unit normal vector outward. So in case of 2, right, it will be what? It is xz plane, so it is dx dz into minus j cap, right? Opposite direction, opposite of y axis. So okay, so I will write here, it will be ds vector would be dx dz into minus of j cap ds vector would be, in this case, like you can do it, right? It is simply the yz plane, and in yz plane it will be dy into dz into minus of ax cap. So dy into dz into minus of ax cap, that is nothing but minus of I cap. And similarly you can do it for here as well. Again it will be downward, so ds vector would be dx into dy into minus of k cap. So now this integration can be very easily simplified. So in the first case, your y is 0, and if y is 0, what is your function? If y is 0, okay, if y is 0, this will be only this part, zx into j cap. So zx into j cap, give me 1 second, zx into j cap, and minus j cap is there, also dy, dx dz is there. Similarly, you will do it for the other surfaces as well. You will see that whatever are the components here, this will come out, right? So y into z will be here, right? Because the x is 0, you can put x equal to 0 in the function, you will see this only, and this will be plus I cap into minus I cap. Give me 1 second, let me get more space. Let me keep this a bit smaller here. I cap into dy dz, and similarly for the third part it will be x into y into k cap into minus k cap into dx dy, right? So now what are the ranges of the surfaces? So what is this? This is a semicircle, right? This is nothing but a semicircle. So you can convert this into its own coordinate system. You can convert this into its own coordinate system. So for this particular part, you can assume that I have a rho radius, right? I will convert every particular surface into their own coordinate system. It is a bit difficult. So if you are not comfortable, use method 1. If you are comfortable, great. So this, let's assume this is a like 2D circle of radius rho, and I will assume my angle that will start from xy and that will start at x-axis and end at z-axis. So angle will go from 0 to pi by 2. So what is the conversion? What is my x? So x would be, if this is, let's say, theta, right? This is, let's say, theta. X would be equals to what? X would be rho cos theta and z would be rho sin theta. Very simple conversion I am doing. That's all. I am doing very simple conversion. Okay, I am just trying to compute this part. Now here, your rho is actually also varying because my surface is what? My surface is this part, right? This is my surface. So here is my rho constant? No. So here rho will be something else, here rho will be something else, here rho will be something else, right? So rho is also varying. So what is the variation of rho? Rho is varying from 0 to 1. What is the variation of theta? Theta is varying from 0 to pi by 2. If previously I told you rho is not varying, I was wrong, sorry. So rho is varying. Okay, rho is also varying, theta is also varying. Rho, theta both are varying. Okay, so what will be my dx into dz? It's very simple, right? So dx into dz, right? Dx dz, how will I convert this into this surface? It is very simple. So it will be d rho. So again, if I consider a very small section, right, it will be d rho. That is a small length along the radius of this 2D circular region into rho d theta, right? Because again, if I zoom in on this, right, I will have a length and breadth. Length would be d rho, okay, breadth would be rho d theta. That's how you compute the arc length, right, rho d theta. So this multiplication will be the small area. So dx dz will be converted into rho d theta. Okay, remember here theta is something else. Theta is not my spherical coordinate system. Theta is something else. Okay, rho d theta. Correct. So yeah, now I'm good. So it is symmetrical. So if I know the value of this part, right, all of them will be same. So there is negative sign. I can take the negative sign common, right? So this will be simply plus. This will become plus. Why? Because there is j cap dot minus j cap. So minus sign will come here. This will become plus. All these are in brackets. So don't worry, everything will be plus. All I need to do is just to calculate this first part, right? Because it is symmetrical, all these values will be same. So you have to be smart enough. If you're not comfortable, use method 1. So zx, now what is z and x, right? This is basically rho cos theta, rho sin theta. So this will be rho square sin theta cos theta into rho d theta. Okay, and this will be multiplied by 3. Why? Because all these three are same. This will be same only, right? These are all symmetrical. Here also you see you have a region semicircular. Here also you see like kind of not a semicircular, sorry, a quarter circle, right? Quarter circle. So all these are same value. This will come out to be symmetrical. This will be same. Okay, again I'm telling, if this intuition is not there, ignore this method. Use method 1. Okay, so this is rho square. This is rho cube, right? So this is a in variable separable format. So rho will vary from 0 to 1 and your theta will vary from 0 to pi by 2. Correct? So theta and rho. So this will be rho cube divided by rho cube integration, that is rho raised to power 4 divided by 4, right? And 3 is obviously there in the front. And this is sin theta cos theta 0 to pi by 2. This is nothing but sin 2 theta divided by 2, that is 1 by 2. So okay, this part will be what? 1 by 2 sin 2 theta, and integration of 1 by 2 sin 2 theta is 1 by 4 cos 2 theta negative. So again I will change the limits, interchange the limits. So this will be 3 into, this is rho going from 0 to 1, this will be 3 into 1 by 4 into 1 by 4 into 2. So this comes out to be 3 by 8. This is same as 0.375, right? So this is a way to solve this faster, but you need to have these much of intuitions, right? And you need to use Gauss, like here also we can use Gauss divergence theorem, but not in a straightforward manner, in a other manner. Okay, so answer will come out to be same, but you will have to be smart to understand this will be symmetrical. You have to assume few things, right? So if you don't want to solve that using basics, so your answer would be 0.375. A 3-phase delta connected cage type induction motor is directly connected to a 400 volt 50 Hz supply. The motor draws a starting current of 100 ampere per phase. So the starting current that the motor draws is 100 ampere per phase, and it is a delta connected motor. Okay, it is a delta connected motor. uh, Considering the above setup, which of the following statements are correct? Direct online starting current, direct online starting, the initial line current would be 173.2. Yes, because if the per phase current is 100 ampere in the stator, obviously from the line we know it's delta connected, so the starting current from the line would be root 3 times the per phase current, because the system is balanced, so it will be 1.732, that is 173.2 amperes. This is the current that the uh, motor will consume from the line side. Okay, I hope that part is clear. So option A is certainly correct. uh, in the star delta starting, the starting current would be 57.73. so in star delta starting, what happens? The starting current, right, in star delta starting becomes one third of the starting current in the line current in the direct online starting, right? One third of this. So what is one third of 173? It is approximately 57.7 amperes. So this statement is again absolutely correct. With auto transformer starting and a transformation ratio of 70%, the starting line current will be 84.78. Again, with respect to the line current, the auto transformer starting would be x square into the starting current of the direct online, right? Just give me 1 second. This would be, there is a tapping of 70%, this will be 0.7 whole square into 173.2. so essentially it is 0.49. Now 0.49 into 173.2 would be 149.2 amperes. This is again, so not 149, sorry, 84.87 amperes. This is again correct. What about option D? With resistance starting, where x is equals to 70%, the starting line current would be 121.24. so resistance starting essentially basically means that they are using stator resistors to drop the voltage, right, by x percentage. So whatever was the previous voltage, they are dropping the voltage, so overall voltage is getting reduced, right? So if the voltage is getting reduced, similarly we know in case of resistance starting, right, only the voltage is reduced. Okay, so basically what happens, our starting current is x times the direct online current. So these things have been taught to you already, right? These things have been taught to you already. So you can check out, like, in the RPYQ series as well, there I have also taken a question of starting current. Or if you want to study comprehensively in the playlist, go into the induction motor chapter. There, wherever the starting of induction motor lecture is there, in that lecture you can obviously understand the whole concept of this particular question. So there we have explained it. So this is 121, sorry, this is 173.2. so always compare with respect to the direct online starting. So if I multiply 0.7 with this, right, if I multiply 0.7 into 173.2, this becomes 121.24 amperes. So 124.24 amperes would be your answer for the question. So all the options are correct in this particular question. A salient pole synchronous motor has the following specifications: uh, quadrature axis reactance, direct axis reactance, terminal voltage, and excitation voltage. Assuming the motor remains synchronized, the power angle at which the maximum power occurs is this. The power angle at which the maximum power occurs is this. The maximum power is this. So technically, we will have to find out the condition for which we get the maximum power. So do remember what is the power developed in a synchronous motor? Do remember it? The power delivered or power developed in a synchronous motor is, it was equal to the excitation power, that is EFVT by x d into sine delta, right? This formula was there. Yes, Vt upon sine d del delta. This is the excitation sine delta. This is the excitation power plus Vt square by 2. Now here I had 1 by x cube minus 1 by xd into sine 2 delta. How to remember it? So this is called as the reluctance power, where obviously 1 by x cube will come first, then xd. Why? Because 1 by x cube will be greater than 1 by xd. That's why 1 by x cube will come first. Okay, that's how you remember the formula. Now this will be maximum. They are telling me this will be maximum. So let me put the values of EF, VT, XD, and then I will derive actually. That will be easier for us. So EF is 1.2, VT is 1, XD is how much? XD is 0.85 into sine delta. VT, this is half. This is 0.55, right? XQ is 0.55 upon 0.85 into sine 2 delta. So this will be equals to, if I solve, 1.2 upon 0.85, this is 1.411 sine delta plus 0.55 inverse minus 0.85 inverse into 0.5, so 0.32321 sine 2 delta. This is the expression for power developed, right, in the motor. Now I can differentiate this with respect to delta because this is just a single valued function. So this we can simply differentiate this. This will be 1.411 into cos delta plus 2 into 0.321 into sine 2 delta. Now let me put the value of delta, right, when the power angle delta is this and this, and let me see whether this is actually going to, so this is cos, right, this is cos, this is actually whether this is actually 0 at the particular values, right? We can solve for this, correct? Or you can simply solve for cos delta as well. Here also you can solve for cos delta, that also you can do. Okay, there are two ways. Either you solve for cos delta, because what is your cos 2 delta? So you know your cos 2 delta would be equals to cos square theta minus sin square theta, that is 2 cos square delta minus 1. Okay, if you want to solve, you can replace your cos 2 delta in here and then you solve the quadratic equation. You will get the condition for cos delta, or directly in this equation itself you can put the value of delta. Both ways will work. Okay, let's solve it using this way only. So let's assume that your cos delta is equals to x. So this will be 1.411 x plus this into 2, right, that is 0.6417 into 2x square minus 1 equals to 0. So this again into 2, so this will be 1.283 x square plus 1.411 x minus 0.6417 equals to 0. So this would be minus 1.411 plus minus b square, that is 1.411 whole square minus 4ac, that is 4 into 0.6417 into 1.283 upon 2 into a, 2 into 1.283, right? Of course we'll choose the let's see what we'll choose. Our cos delta value will be within plus 1 and minus 1, right? So this will be into 0.6417 into 4 b square minus 4ac, right? This will become plus 1.411 whole square, this whole under root, this is plus minus. Of course we'll choose the positive solution here because our cos delta value will be limited within plus minus 1, right? So of course we'll choose the positive solution. So this will be minus 1.411 divided by 2 divided by 1.283, so that is 0.346, 0.346. So that is what your cos delta value is equals to. Cos delta is equals to 0.346. If I take cos inverse of this, so your delta comes out to be 69.754 degrees. Okay, that is what your delta is equals to. That is present in option A. And if I put cos delta equals to, if I put delta equals to 69 point this, right, let me compute what is the power. Okay, so P max would be equals to this into 2 into sine of this angle into 0.321, that is 0.2 here 0.208 plus 69 point, what was the angle, 69.754 sine into the other term, that is 1.411 is 1 point, this is 1.323, this will be equals to 1.532 pu. 1.532 pu, that is present in option D. So option D would be your correct answer. Option A and option D would be your correct answer for this question. A system is described by the characteristics polynomial. This n1 be the number of poles lying on the imaginary axis, n2 be all the number of poles lying on the left hand side, n3 be the number of poles lying on the right hand side. Then this value n1 plus 2 n2 plus 3 n3 would be. So it is simply a Routh-Hurwitz quotient, right? RH quotient. So we have to basically first of all make the Routh table. So first of all I will have, let me write the things here. I will have s raised to power 6, s raised to power 5, s raised to power 4, s cube, s square, s raised to power 1, s raised to power 0. Okay, then I have yeah, this 3 and 12 and 3 and minus 18, 3, 12, 3 minus 18. Okay, 2, 4 minus 6, 0. Okay, so this would be 24 minus 12 uh by 4, correct? Sorry, by 2. 24 minus 12 by 2. So if I solve this, 24 minus 12, so 24, yeah, minus 12 by 2, that is 6. Okay, so we get 6 over here. I'm doing this correctly, right? 2 2 2 4, yes, 3 yeah. Okay, so yes, this will be 24 minus, yeah, 6. Then I have 6 minus 18. Okay, 6, sorry, plus 18, 6 plus 24 divided by 2, that is 12 only. Okay, this is also 12. Now what about the last one? Last one will be just, this one will be copied correctly, minus 8, 18, that will be just copied, correct? Okay, okay, now then this will be 0, this will be 24 minus 24, so I get a row of 0 here, right? I get a row of 0 here. This will be minus 36, okay, plus 36, this also row. So basically I'm getting a row of 0. To solve the row of 0, what you do is, we first of all write the auxiliary uh, equation, that is 6 s raised to power 4 plus 12 s square minus 18 equal to 0. So the coefficients of differentiation, like this is my auxiliary equation. Okay, the differentiation of this will be 24s cube plus 24s. Okay, so the coefficient of this auxiliary equation would be my the values here in the Routh table, that is 24, 24. And how do I find out the roots? The roots would be, let me do one thing, let me divide by, let me assume s square to be some x, okay, and divide by 6. This will be x square plus 2x minus 3 equal to 0. So this would be uh, x minus 1 into x plus 3 equal to 0. So of course I will ignore the negative solution, because like the roots are purely imaginary. So I will assume my s square to be, sorry, I have to choose the negative solution only, right? I have to choose the negative solution, because in a row of 0 we get purely imaginary uh, roots. Okay, so here this will be like your s square x would be minus 3. So your s square is minus 3, or I can say my s is plus minus j root 3. So these are my imaginary roots. I got my imaginary roots. Now we can further solve it. Okay, okay, we got these roots. Okay, actually no, this also will be, no, we'll get 4 roots. Sorry, this also will be valid, right? We will not neglect this. S equal to like x equal to 1, that is s square equal to 1 also is a solution. I'm sorry, this also will be a solution, right? Yeah, these are valid. So s equal to plus minus 1, these are also my solutions. So I got 4 roots. Okay, 4 roots. Now if I further solve my route table, this will be again 24 is here, correct? So this will be 24 into 12 minus 6 into 24, that is 12 minus 6, 12 minus 6, 12 minus 6 is 6. Okay, this will be simply minus 18 again, this will be 0. So this will be 6 into 24 minus 6 into 24, so 24 plus 3, plus 3 into 24, right? That is 4. So this is 96 actually. This will be 0 and this will be minus 18. So ultimately, right, there is only a single sign change, okay, in the last. So there is one sign change. That means how many number of right hand poles I will have? 1. Okay, I will have 1 right hand poles. Now that is already, that can be seen from here, right? This pole is the right hand pole, basically s equal to plus 1, right? Now okay, I have 3 right hand poles, and because I have one row of 0, from the row of 0 only there is a possibility that I will get my imaginary poles, right? So I have, how many imaginary poles I have? Imaginary poles 2. Only row of zeros can give me imaginary poles. Other than that, I'll never be able to get imaginary poles. Only auxiliary equation will give me symmetricity poles, okay, with respect to origin. So number of imaginary poles is 2. So how many left hand poles I will have? So overall, of course, it's a 6th order equation. I have 6 poles, out of which 1 is right hand, 2 is left imaginary. So 3 will be my left hand poles. Now what are they asking? So n1 is what? N1 is the pole number of poles lying on the imaginary axis. N2 is the poles lying on the left hand side, that is this N2, and N3 is the right hand side poles. So it is N1 plus 2 N2. So N1 plus 2 N2, that is 2 into 3 plus N3. N3 is 1. Okay, that is equals to 2, 6, 8, 9. So 9 will be your yeah. I hope I'm sorry. So what I'm doing? 6 plus 2, no, 9 is, sorry, 3 into N3, right? 3 into N3. So yeah, 11. 11 would be your correct answer for the question. The signal flow graph of a dynamic system is given, and the state variables x1, x2, x3 are defined according to the standard state space formulation. U and y are inputs and outputs respectively, right? U and y are inputs and outputs respectively. The controllability matrix of the system is shown. Determine of the product A cross B cross C rounded to 1 decimal place. So they are telling me that for a state space representation, the controllability matrix is shown. So do you remember, if I have a state space representation, x dot is equals to ax plus bu, right? Ax plus bu. Now what you will do? You can actually find out the controllability matrix. What is the controllability matrix? Right? Actually, this is QC. This is called as QC. That is equals to B into EB if it's a second order system into, or A square B, right? Where all of these, right, each tells us the row. So not the row, the column. So these are all column vectors. right? I hope you remember the controllability matrix. And if we say that if the determinant of the controllability matrix is 0, then we say that the system is not controllable. Basically, if the rank is less than the order, right, then we say system is not controllable. Basically, that states that if the determinant is 0, that's all. So let's actually see here what is my B matrix. So for that, first of all, I need to properly write the state equations. So let me write state equations one by one. So this is the first state equation, right? X1 dot. So X1 dot is equals to what? So there are two nodes that are incoming to X1 dot. One is 2 in minus 2 into X1, minus 2 into X1. Another one is this one, right? X2 into 2. Two into X2. This is my X1 dot. What about your X2 dot? So X2 dot would be equals to minus 2 into X2 and plus U. Again, there are two nodes like that are incoming. So plus U. And this is actually 0 into U, right? There is no U term, so that's why 0 into U. In the third case, X3 dot will be equals to how many nodes are incoming? One node, two node. So this would be minus X3 minus 1 into X3 plus U, right? Other terms are 0 basically. So can you now tell me what is my A matrix, B matrix? So A matrix will be equals to, so let me properly write it actually. So your X dot, right? X dot is nothing but the vector X1 dot, X2 dot and X3 dot. That is equals to that is equals to this, right? X1 dot, this will be minus 2, this will be 2, this will be 0. Let me write the matrix properly, then I will explain, don't worry. This will be 0, this will be 0, minus 1, and then we can certainly write this is into the X vector, that is X1, X2, X3 plus then U, right? BU. Okay, so what is your B matrix? So you see that U term is present here, this is 0, right? So this will be basically 0, 1 and 1. So like I have formed the A matrix, but you can understand, right? So minus 2 into X1, that is minus 2 X1, 2 into X2, that is 2 into X2, then 0 into X3, there is no X3 term, that's why 0 into X3, right? Similarly, you can do it for the other rows as well. Similarly, you can do it for here as well, right? So the first row will be equated with X1 dot, right? This first row. The second row will be equated with this equation. The third row will be equated with this equation. Got it? That's how we form the ABC matrix. So yeah, So uh, now we need to solve this. So I know my A matrix, I know my B matrix. So my A matrix would be, so my controllability matrix would be B, then AB, and then A square B. Why? Because it is a third order system, right? Because there are three state variables. So B matrix, this is 0 1 1. Now what is A into B? So A into B would be this into this, right? So this is minus 2 into 0, 2 into 0 2, 0 0 minus 1. And this will be okay. What about hold on a second, A into B, sorry, this is not the correct, right? So this is A into B, so this is the first element, minus 2 into 0, that is 0, 2 into, that is 2 only, and this is 0. Yeah, so first row is 2 and this is minus 2 and this is minus 1. Okay, this is correct only. Okay, I already did the multiplication, so I'm a bit fast. So minus 2 minus 2 minus 1, it is just simply multiplication of this matrix with respect to this. So this is my AB, correct? Now I need to do A square B. So again, with this matrix, with this column matrix, I need to multiply A. So A is minus 2 to 0, 0 minus 2 0, 0 0 minus 1, right? So this would be minus 2 into 2 minus 4, this is minus 4. So this first row is minus 4, this is also minus 4, right? This is 0. So minus 4 plus minus 4, that is minus 8. Can you see, like, are the things matching? You see minus 8 here, you see minus 8 here, you see 0 here, you see 0 here, right? Things are matching, right? More things will match. Next row, right? So 0 into 2 is 0, minus 2 into minus 2 is 4, and this is 0, so this will be 4. So you see 4 here, you see minus 2 here, you see minus 2 here, you see 4 here. So this will be 0 into 2, 0, 0 into minus 2, 0, minus 1 into minus 1, that is 1. So yeah, you see 1 here, you see 1 here, you see minus 1 here, you see minus 1 here. So everything is matching. So all you need to calculate is A, B, C. So A is 2, A is equals to 2, B is equals to, B is equals to 1, C is equals to 4, C is equals to 4, A is equals to 2, B is equals to 1, C is equals to 4. So A cross B cross C is 8. A cross B cross C is simply 8, right? Hold on a second. C is 1, sorry. C is not 4, right? What am I doing? C is 1, sorry, C is 1. So A cross B, so C is this, right? This value, C is this value, the last element. So A cross B cross 3 will be actually 2, not 1, sorry, 2. So 2 will be your answer for the question. A DC series motor runs a fan at a speed of 1000 rpm and draws a line current of 50 amperes, right? In a series motor, our line current is same as the armature current. The combined resistance of the armature and the field is 0.6 ohms. So your Ra plus RAC is 0.6 ohms, right? Now what will be the motor speed if a 4.4 ohm resistor is added in series? So your overall resistance has now been, if I add 4.4 ohms, it will be 5 ohms. Overall resistance has now become 5 ohms in series. Assuming the field flux is directly proportional to the armature current, that makes sense because it is a series winding, so field flux will be directly proportional to the armature winding, armature current. They are asking me what will be the motor speed, right? What will be the motor speed? So assuming the load torque to be proportional to the square of the speed, and they are asking me motor speed in this should be motor speed in rpm, so I'll put that motor speed in rpm. So yeah, what does my speed dependent on, so if you remember, your back EMF is proportional to flux into speed, so your speed is proportional to back EMF by flux, right? And what is your back EMF? Back EMF is basically proportional to Vt minus Ia into R. Okay, so right, so one more thing, they're telling you load torque is proportional to the speed of the fan load. So your load torque is proportional, or your like load torque will be equal to a developed torque for the motor to run. So your torque is proportional to the square of the speed of the fan load. So if a torque is proportional to square of the speed, what is torque? Torque is proportional to current into flux into armature current. So your torque is proportional to Ia square basically. So basically your current, right, Ia would be proportional to speed square. Ia would be proportional to speed. Okay, that is one thing. Ia will be proportional to speed. Ia would be proportional to speed. So let's assume that the initial speed n1 was n1 and the second speed n2 is n2, right? So your n1 upon n2, let's say, is x. Okay, so if I take the ratio in the case 1, so n1, what is it proportional to eb1 upon eb2 into phi 2 upon phi 1, right? N1 upon n2. Okay, now your flux is proportional to current. Your flux is proportional to current. So if your n1 upon n2 is x, right, and it is also equals to your ia1 upon ia2, because your speed is proportional to current. So this will be equals to your phi 1 upon phi 2, right? So your phi 2 upon phi 1 would be 1 by x, and this is x. So this is x, this is eb1 upon eb2 into 1 by x. Okay, now what is your eb1 and what is your eb2? Just give me 1 second. What is your eb2 and eb1? So your eb1, right, eb1, so your x square is equals to eb1. Eb1 is Vt terminal voltage is 250 volts, 250 minus IaRa, right? Ia is 50 into Ra plus RSH, RAC, that is 0.6. So this is your initial back EMF. What is your second time back EMF, right? It is actually equals to 50 to 50 minus Ia2. Now what is Ia2? So your Ia2 is actually equals to Ia1 upon x. What is Ia1? Ia1 is given, that is 50. So it is 50 upon x. So this will be 50 upon x into the resistance. The overall resistance has now become 5, right? Because I have added additional 4.4 ohms of resistance, right? So this is the new resistance. So this has now become 5. So if I take this on the left hand side, this will be 250 into x square minus 250 x, right? Because one x will be cancelled. Yeah, that's it. Equals to, what is this value? 250 minus 0.6, that is 3 divided by 5, right? 0.6 into 50, that is 30, right? So this is 220. So yeah, if I divide by 250 on both sides, this will be x square minus x minus 220 divided by 250, which comes out to be minus 0.88. So I get the value of x. What will be x? X will be equals to minus of b plus minus b square. B square is 1 minus 4ac, that is plus 4 into 0.88 divided by 2a. So this into 4 plus 1. Now what can be your x? So there are two solutions for your x. X is 1 plus minus 2.12 upon 2. What should you choose? So if for x, if you are choosing the positive sign, right? Okay, your x cannot be negative, right? You cannot choose negative sign here, correct? You cannot choose negative sign here. Why you cannot choose negative sign? Because then your x will be negative, and that is not possible. X cannot be negative. That is not possible, right? So x has to be positive. So this will be, because you will say that the motor will now rotate in the other direction. If your x is negative, the ratio of the speeds will be negative, right? Motor rotates in the other direction, not possible. So x will be positive. So I will choose the positive solution, plus 1 divided by 2, that is equals to 1.563. Okay, so x is 1.563. So I can put in this equation. So this will be n1 is 1000 upon n2, that is equals to 1.563. So your n2 comes out to be 639 or approximately 640 rpm. This will be the answer of your question. A single phase inverter employs a pulse width modulation technique designed to suppress the fifth harmonic. Determine the magnitude of the seventh harmonic component in the output voltage expressed in Vs. Okay, so we will have to suppress the fifth harmonic component. So then what will be the magnitude of the yeah, I think this should have been percentage. They should have told what is the percentage magnitude. I will change the question, don't worry. We'll compute the percentage magnitude, otherwise you will not be able to solve it. So do remember that what was the Fourier series, and this already has been taught in the RPO Eco series. This already has been taught in the full course. The Fourier series for a single phase inverter, right, which employs pulse width modulation, is this 4Vs upon n pi sine n pi by 2 into sine n d, where d is the so 2d is the pulse width. Okay, d is not the pulse width. So this is the waveform of the waveform. This is the waveform of the pulse width modulated technique output, right? And this is the Fourier series of that particular waveform, right? So sine n omega t. Okay, now in this case they want to totally suppress the fifth harmonic. So basically what we do is, from this information we can carry out, if the fifth harmonic is 0, this term will not be 0. This term also, it is sine 5 pi by 2, that is not 0. This term we can make it 0, that is sine 5 into d, that will be equals to 0. So from this we can get the angle of d. So sine of 180 is 0, right? Sine of 180 is 0. So 180 divided by 5, that will give me the angle of d. So d is 36 degrees. Now we can put the same value for the seventh harmonic. What will be the seventh harmonic? So they are asking me what is, determine the magnitude of the seventh harmonic component in the output voltage expressed in volts. Okay, in terms of the supply voltage Vs. Okay, actually, yeah, I will change the question, expressed in volt in terms of the supply voltage Vs. I will change it in terms of Vs. The question, the wording is not proper. So this will be 4 Vs. Determine the magnitude, right? Determine the magnitude. Magnitude is basically nothing but the amplitude, the coefficient of sine 5 omega t, that is 5 into pi into sine 5 pi by 2 into sine of 5 into 36 degrees. Okay, this is the magnitude, basically the amplitude, right? In terms of Vs I can compute. So 5 into this, okay, sorry, not the fifth harmonic, the seventh harmonics, right? Seventh harmonics upon 7 pi. So into 7 sine of this, and so sine 7 pi by 2, it will be either 1 or minus 1, does not matter, because I have to compute the magnitude. All these things won't matter. 4 upon 7 divided by pi. So this approximately comes out to be 0.173. Okay, so okay, I will change the question. I will write oh yeah, this is fine. Output voltage expressed in volt as I will change this question to alpha into Vs, where Vs is the supply voltage. So what is the value of alpha, right? In this case it is this into Vs, right? So alpha in this case, because I am talking magnitude, it will be 173 0.173. This is your answer. Okay, the wording of the question was not proper. I will change it to alpha into Vs, so where alpha value would be 0.173. A single phase 550 volt 55 kVA alternator has an effective armature resistance of 0.2. Field current is 10 amperes. It produces armature current of this under short circuit conditions and an open circuit voltage of 450 volts. What are they asking? They are asking me calculate the full load regulation of the alternator at 0.8 power factor. Okay, so full load regulation in percentage. They should have mentioned in percentage, right? Okay, so the field current is 10 ampere. Armature resistance RA is 0.2. So if I know the open circuit voltage, right, and if I know the armature current under the short circuit condition, it put like to produce 10 amperes of field current, I have to produce this much amount of armature current, right? So I can actually compute the short circuit impedance. Okay, it is a single phase. Remember, it is a single phase motor, so I don't have to worry about star or delta, right? This voltage will be my phase voltage and line voltage. I don't have to worry about that. So your synchronous impedance would be open circuit voltage upon the armature current required to produce the same amount of field, that is 200. So this would be equals to 2.25 ohms. This is my synchronous impedance. From this, I can actually compute my synchronous reactance. What will be the synchronous reactance? Synchronous reactance would be equals to Zs under root Zs square minus Ra square. So this will be equals to Zs square, that is 2.25 whole square minus Ra square under root. So this will be equals to 2.24 ohms. Right, this is my excess. This is my synchronous reactance. Now we will have to calculate the full load regulation at this much amount of power factor. It's very simple. So basically, if I draw the circuit, right, this is the circuit of the motor. So this is the circuit of the alternator, right? So this is the generating point that generates the voltage Eg. This will be my Rs. This will be, or armature resistance Ra. Actually, not Rs. Armature resistance Ra, and synchronous reactance Xs, and here is the terminal voltage. So whatever rating it is given, this is the terminal voltage. Okay, that is the full load voltage. There is always angle 0, right? So what will be the percentage voltage regulation? Percentage voltage regulation would be magnitude of the voltage at no load minus magnitude of the voltage at full load divided by magnitude of the voltage at full load into certainly 100. Right? So what is the no load voltage? No load voltage will be nothing but Eg. Okay, Eg minus, that is Vt upon Vt. Now we know Vt, that is 550. But what is Eg? Because at no load there will be no drop, so Eg will be equals to Vt. So this we can compute. Eg would be equals to, so at full load condition, what is the voltage that I need to produce? Eg would be equals to V plus I into Z, right? I into Z vector at full load, IFL into Z vector. So your Eg, Vt is I know, that is 550 angle 0. I full load, right? What is Ia full load? Ia full load will be kVA upon the voltage into the power factor, Vi cos phi, right? It is a single phase load. Remember, it is a single phase load. So this will be 55 into 10k upon 550 upon 0.8. So that is 125. What is the angle? Remember, it is 0.8 lagging, right? So it will be minus 36.86. So this will be, Ia would be 125 minus 36.86 degrees. So this, if I solve, so this into 0.8, so the real part would be 650 and the imaginary part would be minus j divided by 0.8 into 0.675. Okay, so what is the magnitude of Eg? This whole square plus 650 whole square whole, okay, 650 whole square plus 75 whole square whole and root, that is 654.31 volts. Okay, so we got our Eg value, right? We got our Eg value. So what will be the regulation? So the regulation would be Eg magnitude Eg full load minus the no load voltage, right? So okay, sorry, just this is the current, right? IA current. We also have to multiply this with the impedance. Don't forget we have the impedance as well. Okay, so what is impedance? Impedance is Ra plus jxs. Okay, sorry about that. So it's not that simple. So this will be 550 125. This is, we have to multiply by zs as well, right? So this will be 100 minus j75 into the impedance. What is the impedance? Impedance is this, right? So I can write this in the rectangular format, 2.2. So this will be 0.2 plus j 2.24, right? So yeah, let me redo this again. So this will be 100 into 0.2, right? So that is 20. So this will be 570 plus, so minus j square, so 75 into 2.24. So this again will become plus, so sorry, this will be plus 570 75 into 2.24. That is, this will become actually 738. Okay, that is interesting. This will become quite large. 738. I hope I'm doing this correctly. 100 minus j. This point, so that is 0.6, right? 0.6. This 3 by 5. 0.2. Yes, correct. 2.24. This is correct. And what about the other part? This is 100. So this will be plus j 224 minus 75 into 0.2, that is 15. So I will have to subtract by 15, that will be 14 or 210, 209. So this will be equals to 209 whole square plus 738 whole square whole under root. So your Eg magnitude comes to is 677 volts. So your voltage regulation would be 767 minus Vt is 550, right? 550 upon 550 into 100 percentage. So this will be 550 upon 550 into 100 percentage. So this approximately comes to with 39.458 percentage, which is actually bad. That's why it's a single phase alternator. We don't use single phase alternators because their voltage regulation is also very bad. This will be your answer for the question.
Yeah, so that's an interesting problem. So here, what is the conventional way? Like if you need to apply the mathematics, so you can find out V naught S divided by V in S, you will get the transfer function, or you can do then IS divided by V in S, you will get that transfer function. You can tell whether it is first order or second order, whatever it is. This is the mathematics. If you need to see the intuitions, so across the inductor L, if I say that my voltage is V naught, this is one variable that I am introducing. This is already input voltage that I already know. This is one state variable that I have introduced. Then that means across this inductor L, I can write down the potential in terms of known state variables. This is also known to me. This is also known to me. This is also this is not a state variable. This is a fixed input voltage, right? This is a state variable that is known to me. So here I don't need to introduce another state variable. That means with respect to the voltage, with respect to V naught T voltage, it is a first order circuit. It is a first order circuit. So the transfer function would be somewhat like this. V naught as V in S. What will come in the numerator, I don't know. But in the denominator, I know that, sir, S by A plus 1. This kind of scenario would come. First order circuit it is, So this is first order. Now what about the current? What will be the current? What is your IS? IS is nothing but V naught S divided by the resistance LS, right? So if I need to replace this V naught S, so V naught S would be written as IS into LS divided by V in S. That would be something in the numerator divided by S upon S by A plus 1, and this LS can go here. This LS can go downward now. So IS by V in S is looking somewhat like this. IS by V in S is looking somewhat like this. Yeah. So IS by VNS is looking somewhat like this. Now can you directly say that, sir, it will be second order? Luckily, if you have said that this is second order, then it would be okay for you. You would get the correct marks. But it might happen that here there is a 0 at s equals to 0. If there is a 0 at x equals to 0, let's just say here there was some term of as, then what would have happened? This and this would have got cancelled out and it would become a first order circuit. Similarly, you see this simple RL circuit, no? Simple RL circuit. This is your VNS, this is your V naught S. So what is your V naught S by VNS? That is, you simply know that, sir, it is LS plus, that is LS upon LS plus 1. So here, if I talk about this current as well, I naught S. So if I find out I naught S divided by VNS, so what will happen? I naught S is nothing but V naught S into V naught S divided by LS. That means V naught S is nothing but I naught S into LS. So this LS will go here and LS plus 1 and then there is LS. So LS is getting cancelled out. So with respect to current as well it is first order, with respect to voltage as well it is first order. With respect to voltage, with respect to current, in both of the cases it is first order only. Why is that so? Because here pole 0 cancellation was there. So always you need to check at omega equals to 0. At omega equals to 0, what is the scenario? If you are getting a 0 at omega equals to 0, then there is an issue, right? So are we getting a 0 at omega equals to 0? So let's go to this particular circuit and check at omega equals to 0. At omega equals to 0, what is happening? At omega equals to 0, this will provide 0 impedance, this will also provide 0 impedance. Whole circuit is shorted. What does that mean? Voltage will be simply divided. So how the voltage will be divided? 2 by 3 into V. So at omega equals to 0, you are getting a gain of 2 by 3 at omega equals to 0. That means omega equals to 0 is not a 0. What did I did? I put omega equals to 0 here. So this is also becoming 0, this is also becoming 0. Whole circuit is shorted. What does that mean? Voltage has to be divided now. So how the voltage will be divided? This is L by 2 and this is L. So it will be divided in this manner. This is L by 2, this is L. So it will be divided in 1 by 2 upon 1 by 2 plus 1. So it will be divided as 1 by 3 into V. That would be your V naught. So at omega equals to 0, at 0 frequency, this is what you will be getting. So your 0 frequency, at 0 frequency, your gain is 1 by 3. At 0 frequency, your gain is 1 by 3. So at 0 frequency, surely you are not having a 0. That means, yes, this pole 0 cancellation will not take place. Pole 0 cancellation will not take place. That means it is a second order circuit. So this was the first order circuit, this is a second order circuit. So value of x is 2, value of y is 1. That's it. Okay. So with respect to V naught S, VNS, only one state variable is there, first order. With respect to IS divided by VNS, it will be second order. Why is that so? Because, sir, in place of V naught S, when I am putting IS into LS, so LS goes here. If this LS goes here, then what do I see? Pole 0 cancellation I need to check. I checked at omega equals to 0. I go to know that, sir, both whole circuit is being shorted. That means the gain is becoming 1 by 3. V naught is not coming 0. If V naught was coming 0, then you would have said that, yes, sir, there is a 0 at 0. Like here, if you put omega equals to 0, what will happen? This inductor will be shorted. That means V naught S is coming out to be 0. So from here, intuitively, you can say that, yes, sir, we are having a 0 at 0. We are having a 0 at 0. But in this particular case, you are not having a 0 at 0. So this is a second order, this is a first order. Let's go to the next one.
So that's it basically. Those were all the questions from EE ReplicaX examination. So I hope your test has gone well. If it has not gone well, please don't be demotivated, because there are a lot of things that can go in your way in the exam day. So just be just be calm and collective during your examination. So we have around 2 weeks left for EE examination to occur. So be calm, cool and collective. Just think for the best, right? Have a positive mindset and go with a positive mindset, and you will see what happens. Maybe once the question comes, whatever topics you had studied from those topics only they were asking the questions, then you're very lucky, right? So you don't know what will happen. Just go with an open mind and hope for the best. So with that, I want to say all the best to all the aspirants, and I hope your exam goes well, and I will meet you in some other video. Until then, happy learning.